In this video, we're going to explore LINQ further, so specifically we'll take a look at some of the power of LINQ to, for example, perform aggregation functions like averaging and summation and counting and so on. Alright, and also we'll talk about lists of lists, which is a very practical thing. So think about a project, and all we're going to do is put a button in there to keep things brief. Alright, change the text on the button to show, like this. And then that's it. So switch to design view, left to double click on the show button. Alright, delete that. We don't need that. Alright, next stage here. So using system, and I will say using system.collections.generic, and then we'll say using system.LINQ, of course. Alright. So the code that we need I've prepared already in advance. That's why I don't have to remember it, because it's quite a lot, but it's mechanical. There you go. So let me highlight it, comment it out. So first we are going to create an array, so IEnumerable as the data type, and then we'll say INT. Then we'll say scores as the name of the array, and then we'll make it so new, and then INT like this, and then the initializer list. So throw in some values there like that, doesn't really matter what they are too much. There you go. Say 67, 76, doesn't matter, 71, and say 81. Close the semicolon. There you go. So this is good. Now, first we are going to find the average of this list. So you're going to say variable and then good student average. Alright? So we will decide that students who score 90 or above, imagine those are like final, semester grades for several students. So we'll say this, from score in scores, where the score is greater than or equal to 90, select that score. Okay, select score. This is a query. See that you can write like this in a single line. Here in this context, scores is the array, and then score is the range variable. And the condition that selects is this one, where. Okay? Then you're going to put a period, and then you can average that whole thing out. So in other words, the way this is written is that this query will run, correct? And then average that list. Now to hover a mouse over var, and you see it says double, because average, as you can see, also returns a double. So this average function acts on a list of type enumerable, but it returns a double to us. Alright, then you can display it, of course, because remember, it's just a single numerical value, an aggregation quantity, an aggregate quantity. So now we can say sample label.text, and then we'll say here $symbol, and so the average, say for grade students like this is, and then we'll stick in the average, right? So good student average, and close this with a semicolon. Alright, now, if you want, you can, for example, also use the count function. So you can say something like this, variable, and say average student count like this, and now we'll say the following. Here we used query syntax in a single line, inline query syntax. You see that because we used from and where, and now we can express the same thing using method chainings and lambda expressions within them. So we'll say here scores dot where, and then we'll say grade is such that, all right, 70 is less than or equal to the grade, and for example like this, and the grade is say less than 80 strictly. So we're defining people who earn scores between 70 and 80 exclusive of the 80 as say average students. Okay, and then we'll put that word, and then we'll count that. So this will tell us how many such people there are. And then we can display, so for example, sample label.text plus equals to append as usual, and then we'll say here, so the average, you can see there are, and then you're going to put average student count, students, there are, say, remember that will be a number, so there are, for example, 25 average students, like this, and then close with a semicolon, see? Alright, now, a very realistic application of this concept might be to have a list of lists. Imagine list like this, int, and then you'll have first student. Okay? Imagine you have one student. So, and he has some grades. So you're going to make a new list like this of integers. Alright? And then you can initialize that list, put curly braces, and then throw in his values. So 90, say 89, and 92. Right? That's it. So this is how you can initialize a list. Another way that we have not seen before. Let's do one more list of integers like this for another student. Alright, so this will be second student like this, and then we'll say here new list of integers. Initialize that list with some values 78, 81, 79, and close that. You see? Alright, now when you have a whole class, you would have a list of such lists, correct? Because you have multiple students to a class. So then you can create constructs that say a list of lists of integers. You see? You can embed lists inside other lists, like that. And then you can say, for example, here, we'll call this the class list, right, equals a new list of lists, like that. And to initialize this list, you can use add. So you can say, for example, class list dot add, and then you add the first student, like that. And then class list dot add, and then you add the second student, like that. At the next stage now, we want to be able to get some useful information. So for example, imagine you have this list of lists, and we want to summarize. So you're going to say this, variable average per student as an example, right? The average student grade. Alright, so we'll call this AVG, like this, okay? Per student, so average per student. And now you're going to type here equals, and now you will say class list dot, and then you will say select, you see? And the quantity to be selected is the list that represents each individual student. So you will say the following, right? Student, like this. Yeah, please be sure you understand what a student is. Okay? You can say class list that selects students such that, and then you'll take the student and average him or her. See? And close with a semicolon. So every mouse over student, as you can see, that quantity there is a list of integers that corresponds to student number 1, first student. Okay? And then student at average means average out that student. Alright? And then repeat that for the next student. So hover your mouse over var. You see this? And the return in this case is of type IEnumerable. So we can iterate over those values. Alright? So to that you're going to say for each, like this, var average, we'll say AVG like this, okay, student average like this, and average per student. Alright, like that. Open close curly braces. We'll display same playable.text plus equals, and then we'll say here average grade equals, and then we will say average grade, or rather in our case student average, like this, and close this with a semicolon. There you go. Alright, delete that. So it looks like this. Now build this. There you go. And now run it in Edge. Hit show. There you go. So the only thing missing are the little BRs, right? So let's put those in there. Those are the things that are easily forgotten, of course. There you go. So BR, and then one more BR over here, like that. Hit show. There you go. See that? So now you have some professional results. The average for grade students is 98.5. There are 3 average students. Average grade is like this for the 2 lists. You see? There you go. So you've learned about, more of what can be done with LINQ. So the average function, the count function, and you've also learned that you can make a list of lists, and then you can operate using statements like select, and then you can embed lambda expressions in that to act on each list in the list of lists individually. Welcome to the course. My name is Tom. I will be instructor.
If you visit a page like Indeed.com, you type in C#, you see there are many jobs in the field. So again, this is a very valuable skill to master, or maybe you like to tinker, it's great for that also. If you do a search for Visual Studio Community 2015 online, it should bring you to a page like this one here. Just click the buttons, so click that button there. Alright, now here, depending on the browser you're using, you will have a different experience. In my case, I am using Edge, so I get a download saved to my system automatically. In your case, you might be prompted first to save the download in a given location. But then you click Run. This is going to bring up a splash screen. If you're installing it for the first time, just follow the prompts as they appear one by one by one. The only note to make here is this program is big, which means files will take time to both download and then be applied to your system. Sometimes it can take several hours, in fact, so keep that in mind. In my case, I already have Visual Studio downloaded, but there's still some kind of little update that improves the performance. That's okay, it doesn't matter for our purposes. So I'll just close this. So once we have it downloaded and installed, let's launch it. I'm using Windows 10. I'll type 2015 and then launch it right there through that ribbon icon. So again, this brings up a splash screen, and here is Visual Studio. So my specific version, if you click on Help and About Microsoft Visual Studio, is right here. This is what I'm using. That version, Update 1, and also the .NET Framework. That's a framework that operates behind the scenes that provides a lot of the functionality that we need to make our programs work, is that specific version right there. There you go. So thanks for watching, and in the next video, we'll take greater control of Visual Studio and configure it to some extent. In this video, we are going to configure the appearance of Visual Studio a little more. So into the upper right hand corner, into the quick launch box, type a word like font, for example, and then choose the first item. And from here, we can configure many different settings. So for example, select the text editor. That's the size of the code in the window so that it's easy to read. Set it to be something big like 20, for example. That makes a difference. When you're learning, how big things are makes a difference. They're easier to understand simply because they're bigger. Okay, at the next stage here, select, for example, statement completion. This is a very useful feature that makes coding more efficient. So again, set it to something big. Let's also configure the environment font. So select it there, and then again, there are many possible options, but one that I use very commonly is SEGOEUI, and then set it to be something big. So for example, 18 or 17, something easy to read as always. And also watch locals and autos tool windows. Select that. Set it to be something big like 19 or 20. Click OK. Some of these take effect immediately and some don't, so click OK. The environment font, for example, as you can see, is enlarged immediately. Now, one thing that's useful is, for example, being able to position some of the panels. What do I mean? So click on the view here and then choose Solution Explorer. That's a window or a panel. You can position this in many places. If you left click where it says Solution Explorer and Pool, you can liberate that panel and then place it where you like it. So for example, and you're also given a really nice preview of what to expect once it's dropped. So if I drop it there, the blue area tells me it's going to go across the top. So again, left click here and then pull, and then drop it on the left side, and it goes on the left side. There you go. So this is how you can control the layout of the panels. Pull it out. Sometimes you'll get a cross like this one. So this simply tells you, for example, if you hover your mouse over the middle of the cross, the document you're holding with the mouse will be tabbed together, for example, with the start page. See, now they're basically tabbed as a unit over here, the start page and the Solution Explorer window. Pull it out again, and then drop it, for example, on the right side. That's where it is commonly. And one more thing that you can do that's useful is this. If you click that pin, you can enable auto hide, which means when you're not using a panel, it hides out of view, obviously giving you access to more space. On the other hand, if you want it back, you click Solution Explorer and it reappears on the page. And if you want to pin the panel back, just click the pin again, you see? And now it's back, and it'll stay there even if you mouse away from it. So these are some of the things that you can do to make working in Visual Studio easier. In the next video, we will create a simple program and run it. In this video, friends, we are going to create and run our very simple first web page. So the minimum that we need to be able to work with C# later. So crank up Visual Studio, File, New Project, and then choose Website. And then if you want, Shift-Alt-N as a key combination. From the new website box, make sure you select Visual C# as the language and not Visual Basic. And then to keep things as simple as possible, choose ASP.NET Empty Website. Down below, you can save this in a couple different places. For the sake of simplicity, the file system is sufficient. And if you want, you can click Browse and of course save these anywhere that you like. So for example, see? Like that. So choose a location you want to use. I'll leave the default, click OK. Alright, so that looks like this. At this next stage, what we are going to do is this. Notice we have the Solution Explorer, and let's go over the structure of how things are designed here. So specifically, notice we have a solution. Within the solution, we have a website, and then within the website, we will have different files that make up the website. So specifically, web.config is a file that stores basic website configuration settings. For our purposes, you can leave it untouched. That's it, it's fine. And at the next stage, we need to add a document that can be shown in a browser. So right click the name of the website and then choose add, and then from here select web form and then leave the name as default. That's okay. This generates a very simple template. I'm going to close the Solution Explorer so it's out of the way. Let's go over what we see. That code across the top right there, this is highly specific to Microsoft. In the next video, we'll begin learning about C#. At this stage, this is specific to Microsoft. You wouldn't see this, for example, in HTML pages generated by hand or something like that, unless you're working with Microsoft products. This is an HTML document. HTML gives structure to web pages, essentially. And here there are a few different things. Inside Visual Studio, it's such a powerful system. First of all, this is collapsible. Hover your mouse over the 3 dots and it tells you what is inside as the code. And that little preview there. Expanded. Within the HTML, you have the head section. This is where you can store additional information, like for example, the title tags of a web page. So we'll just say our first and then page. And the title is what is visible when a page is launched on a tab of a browser, in Chrome, for example, or in Microsoft Edge and so on. After that, you have the body. So that's this unit. And within the body, again, you have a form. Forms are good for submitting information to web service for processing. And within the form, you have a div, or logical division of a page. And these things, as you can see, are individually collapsible. So there's a structure to the document, okay? A logical structure, in other words. All right, remember, these are tags. So HTML closing tag, HTML opening tag. It's good to structure things properly, so you put them as pairs. One opening, one closing. Excellent. Now, we see where it says run at. This is what we call an attribute, a property that something possesses. So the form over here has the run at attribute, and it's called server. That means that form can be dynamic. It can submit information, you can process it, and you can return it processed, so some output is returned. That's all I will say at this point. We'll talk about this, as we go through the course in more detail, obviously. And now we want to launch this. Put some text within the div. So we will say our first web page. And then click over here, for example, in Chrome or Edge, whichever browser you like to use. So I will, for example, choose Edge and then launch this in Edge. All right, there it is. Give it a second here to generate some basic stuff. And it says our first web page. That's it. In Edge, if you click the 3 little dots upper right hand corner and you click zoom, you can zoom in. If you want to see what has actually been generated and sent to the browser, you right click and you view the source. And as you can see, there's a lot of stuff generated. In Edge, for example, there are different ways of viewing this information. You can, for example, turn on Pretty Print, Control-Shift-P, and now it's been nicely formatted for you. For our purposes, the only thing I want you to know here is the code that we type and the code that actually ends up on the browser side are a little different. The code on the browser side is somewhat enhanced behind the scenes automatically. We don't really have to worry about it at all. But I want you to be aware that that will happen. There you go. Close that. To unload it or close it, stop debugging, Shift plus F5. So that key combination, Shift F5, and that closes it. There you go. So this is how you basically create a very simple HTML document, how you run in a browser. With this knowledge in place, we can now go on to connecting this to C#.
In this video, we're going to improve our little basic HTML page by adding C# code. So I have a template already set up. If you want, between the title tags, you can place something like
our first C# page or something like that. That's fine. Okay. Now make sure you show the Solution Explorer. If you don't have it, you go to View and then Solution Explorer. Control-Alt-L is a key combination if you like those. And now here, expand the node that says Default and then open up where it says default.aspx.cs. This is where you place C# code. Now notice by default at this stage, this here becomes grayed out. So we can remove it, just delete it. It's not necessary for our purposes. Before we talk about C#, go back to default.aspx and switch to design view. And we're going to add one visual item to the page, a label for displaying text in web pages. So click View and then Toolbox, Control-Alt-X. And now here, if you want, into that search box, so many boxes, type LAB, and then left click and drag it and drop it inside the div. So it looks like this. Then you can close the toolbox. At the next stage, switch back to source view, and there is the code or the markup generated for that item. Now keep in mind that this is specific to Microsoft, but you can still recognize it. You basically have an ID that is an attribute. That is how you refer to the item in your C# code. We can change that to something more meaningful. For example, we will say sample label for sample label or something like that. Run at server means the content the label displays can be generated automatically and dynamically over the course, for example, of your connection to a web page and so on, to a server. The text is what you see, so if you remove that and then switch back to design view, see it just says sample label, which is the ID. So now go back to default.aspx.cs and let's add some comments. So the comments will be the following here. Using system. Using is blue, it's a keyword, is a keyword. Okay, because it's blue. Another comment, these are comments, // and then writing after that, that is green essentially as a comment. So you put these here as annotations for yourself. They are not executable code. Using as a keyword is blue. System is a namespace, and the purpose is that stores already created code, which means the following here. Using system, that phrase brings in existing code. The benefit to us, we have less code to create. Okay. Go down to the next level here, so to speak. The next comment would be this one, comment number 4 essentially. For our purposes, at this level of explanation, a class is a required container for creating our own code samples. Later we'll create a class. But now, because of the design of C#, it has to be there as basically a scaffolding into which you place your own code. Okay. At the next stage, down over here, type the following. This will be comment number 5. Page load, that block of code, protected void page underscore load. So code below is where we place our own code, like that. And page load essentially is code that runs when a page loads from a server. That's the simple reason for having it. That's it. All right. Now remember, the connection between what we see in the markup, which is this aspect, is the ID, sample label. This is how you refer to it in your C# code. So go back to here and now type the following. Sample label, that is an object, right? A visible object on a web page, for example. Then you're going to say dot. And the things that can be used with a label are its properties, among other things. But for now, grab the text property, the text feature of a label. And you do that by typing the name of an object, dot, and then text. Then set that equal to the text you want to display. So for example, hello world, and then close this with a semicolon. There it goes. So let's add some comments here down below. 7. A label, basically, a label is an object, and objects possess characteristics or features, right? Features like text properties, like that, like a text property. And one more comment. In this context, the equals is called the assignment operator. It takes the value on the right side, which is hello world, and assigns it to the text property of the label. And one more comment. When you put stuff between double quotes, that is called a string. It's a sequence of characters between double quotes. When this code runs, in other words, hello world will show in the web page that we view. So this is a lot of preliminary work. Let's take a look at the action here. So I will open this up in Edge. Give it a second to load. And it says, there you go, hello world on the page. If you expand this, so if you enlarge this, it looks like this. That's good. And it says our first page, and that's it. So we've generated some very basic C# powered content. One thing to observe up here is you will see localhost. That means your local computer. That number there is the logical software port, and where it says default.aspx, default is the name of a page, and then ASPX is the extension on the page. Let me close that. There you go. So these are some of the basics of creating and running a simple web page powered by C#. Let me close this. Hit the brown button there to stop debugging. Unload it. Close that window. And this is the code. And that is it for this one. I will see you in the next one, where we begin by talking about variables. Welcome friends. In this video we're going to talk about variables. I'm beginning with a simple project already in place to save time. And remember, there's a label involved here, so make sure you have that. If I switch to design view, lower left hand corner in design view, that looks like this. If you're missing that, remember view and then toolbox, Control Alt X if you like key combinations, and then drag and drop a label into the design view there. Alright, at the next stage, so go back to source view, make sure you have it, name it right there, and remember that name. And now go into default.aspx.cs, so that's over here. And the code that we are going to create will be very basic and deal with variables. So the first question ultimately is, why introduce a variable in the first place? That's one important aspect. That is usually based on observation of the fact that something is changing. So imagine something as simple as this. You see a group of people, and what you will observe is that the height changes usually from person to person to person to person. Clearly, height is a variable quantity. It's changing. A group of people, right? And the height changes. In code, like C#, for example, you introduce a variable to represent this. So we're going to say the following here, double. C# is strongly typed, which means every single variable has a definite data type. Imagine a variable in a simplified sense as a little box. If a box is designed to hold numerical values, you cannot put a non-numerical value into that box. You cannot put a word into a box that is designed to hold numbers. It doesn't work. So double is a data type in C#. It's good for representing measured values, or things you can have decimal points like 65.75 and so on. Then you give a variable usually a very easy to understand and purposeful name. So for example, height. And now imagine you pick out one value, 65.00, and then you close with a semicolon. So this line declares and sets a variable. That is it. Okay, based on an observation of something in the world. Hover your mouse over this and you observe it says double. This is an absolutely important thing to understand. The data type you have on this side matches the data type you have on that side. If you don't have harmony between the two, many times this leads to errors, especially when you're learning for the first time. Really crucial. So here we're going to simply say, as a simple comment, declares and sets a variable value. That is the language that you would use to describe that line. This is a statement. It ends with a semicolon, so it completes a definite action, the declaration and setting of a variable. To display this, type samplable, as usual, dot, and then text, and then assign it to be displayed. So that means put equals, and then build up a string on the right side. So type, for example, imagine this is John, right? So John's height is, and to add his height, type plus, and then the height variable. Please understand that when I do this here, this does not mean add two numbers. It means combine two strings. Hover your mouse over the plus symbol. It's an operator. It operates on things. So specifically, string left refers to this string right here. or object on the right side. That's this quantity right here, you see? After it runs, it generates another string. So that word indicates when you add two strings, a string or an object, in this particular case, what you get back is another string. So again, what that means is this here is a string. Text also stores strings, so the two data types are matched. See that? It says string right here. So match the two data types. If you don't have that, many times that results in errors when you're learning for the first time. Let's run this. Crank it up in Chrome, for example. Give it a second to load. And it says John's height is 65. That is correct. If you right click and view page source, the only thing that's been generated is this right here, you see? And that label has been converted into this behind the scenes in basic C#, in basic HTML. All the other stuff is added by default. Don't worry about it. It has to be present because of the way this stuff has been designed by the people who created ASP.NET. Now, we understand why a variable should be introduced. We understand how to display its value. Of course, then you look at another person, and another person has a different height usually. So we will say height and assign a new value, like for example 55.5, close with a semicolon to complete the statement. So again, assigns new value, usually based on some observation that something should change. Okay. And let me fix the spelling here. It's pretty easy. There we go. To display this updated value, we're going to type the following here. Sampleable.text and then plus equals. Plus equals has a definite operation, which is this. Let me add a comment here. Comment number 10. Plus equals appends new text to existing text. If you put only equals, the previous text will be overridden. It will vanish. Plus equals appends new text to the existing text. So now imagine we say Mary is or has a certain height. Okay, so we'll say Mary's height is, and then again, plus height. Close with a semicolon. So look very carefully at what happens when I run this code. It's almost where we want it to be, except this needs to be separated into two lines. So to fix that, you can embed a line break. So to embed the line break, here type BR right in front of Mary's. So when you run the code this time, observe. Now we have the output that we want. John's height and then Mary's height on separate lines. So the values here are coming from C#, likewise with this one. The fact that Mary's on her own line comes from the fact that we have BR embedded into the string. So it produces a new line in HTML. There you go. So these are the basics of introducing and then using variable. In the next video, we'll format output strings so they look more professional. For example, they have currency symbols. In this video, we're going to extend C#, so it has a new feature called string interpolation, which allows embedding variable names directly into strings. So it makes coding more streamlined. It's a new feature of C# 6.0. So with a project open, right-click the name of the website there, and then choose Manage NuGet Packages. And from here, click on Browse. And these are packages you can add to Visual Studio to extend its features. So type code and then DOM. So code DOM like that. And from these items here, select this one, Microsoft.CodeDOM.Providers, and install that into your project. So click the Install button. This is an official product from Microsoft. I accept. Give it a second. At the end, you'll see a message that says finished. So you just have to wait until then. See, it says finished on the bottom. Alright, now close this panel. Close this tab. Here we are. And now go into default.aspx.cs. I'm going to show you how to use this new feature. So again, I'm going to say double as a data type, height equals say 65. So to keep things very simple, creates and assigns a variable. That's it. Alright, the next stage, imagine you want to print this variable. So we will say samplable dot text, and on the right side, put a dollar symbol. In the context of string interpolation, the dollar symbol has nothing to do with money. It's a symbol that is required to allow us to embed variable names directly into strings. So put double quotes, and then type the following here. Height is, and unlike before where we had to type plus and then the name of the variable, now we can just embed the variable directly. So type curly braces and then the name of the variable and close the curly brace. And this is string interpolation. So let me add a comment right above it here. Comment number 8. Dollar symbol makes string interpolation work. And then further, string interpolation allows us to put variable names directly into strings, unlike before. But when you run it, it's the same as before. Take a look. Launch it in Chrome. Give it a second to launch. And height is 65. If you right-click and view the page source, you observe the output is the same as before. Nothing has changed, except that it's now easier to code. It's more streamlined. So let me close this. And that is it. In the next video, working with this new feature called string interpolation, we will create strings and then we will format the strings so they look more professional. For example, they have currency symbols and so on. Welcome friends, in this video we're going to learn how to format outputs so it looks more professional. I'm beginning with a very simple template here in HTML as usual, and then switch over to default.aspx.cs, and that looks like this. Okay, so we're going to type code here into page load that looks like this. Double X, and then set it equal to some value like 25.098114. Not that it matters much. And let's add a comment here. So this value is needed so we have something to format. Formatting obviously is a big thing because you want the things that you generate in a web page, for example, to look properly formatted, for example, as currency, depending on what you need. So here, we will say the following here. X:C prints the value of X formatted as currency. So let's take a look at this down below. Samplable.text, dollar symbol for string interpolation, not related to the fact that we want to print as money at all. And now you will say X formatted as currency is, and then X:C. Close with a semicolon. So this should show us some money on the screen. So again, please remember that dollar symbol, string interpolation, the C applies the currency symbol. Not related. Google Chrome. Let's take a look at the action here. There you go. So 25.10. There you go. And it's got a dollar symbol. One thing to be observed about this is that it rounds. So for example, if you put in 25 as I did, right? 0 as I did here, 0.98114 is going to show you 2 decimal places, but that means this one here is checked because it's more than 5. The one before it is rounded, so keep that in mind. It adds the dollar symbol, but it also rounds using basic school rules that we learned perhaps years ago, or maybe not. Okay, so that's one kind of format specification. Let's take a look at another one here. So for example, we can format as a %. So to do that, I'm going to change the value of X. So I'll say now X equals 0.3459, some value, doesn't matter. Okay, so here I'm going to say the following as the next comment. So I'm assigning a decimal, saving a decimal, so the %P2 specifier is easier to see in action. That's the reason. Let me fix the spelling of specifier. This is the next. Samplable.text equals dollar symbol, double quotes, and now we will say X formatted as a % is, then put X:, and then P2. So that will format as a % with 2 decimal places. So let me add that comment down below. the action of x colon p2 shows the value of x formatted as a %. Let's take a look. Google Chrome. So 34.95%. Notice that this output doesn't show the previous output. So to fix that, we're going to take the following steps. You want to append, so put plus equals to append. And you want to make sure that this line is on its own line in the web page. So put a BR, which generates a break in the HTML. So let's take a look now. Google Chrome. There you go. So formatted as currency, formatted as a %. And let's do one more kind of formatting. And as you can imagine, there are additional ones, but they'll function very similarly to these. So next I'm going to do this one here. We're going to show a date. Okay, so to show a date, use datetime.now. And then to actually extract the date, you'll have to type something like this. To actually get the date, type datetime.now colon and then D, which gets the date. If you want, you can get the time by typing little t and so on. But we'll get the date. So let's take a look here. Sampleable.text plus equals to append, $ symbol for string interpolation, double quotes to make a string, BR to push down to the next line in HTML. And now we will say today's date is, and then curly braces for string interpolation again. And we will say datetime.now. And obviously datetime.now is something that already has been designed and created by other people. It's just available to us. And then colon, and then D to get the little date out, and close with a semicolon. So let's refresh the page here. You can hit that arrow there. And rebuild it and reload it to confirm the date is showing. There you go. So today's date is 4/17/2016. And if you right click and you view the page source, it all looks like this. See? And the BRs, as you can see, are present in the HTML. In effect, visibly speaking, is that you have output on several lines. And that is that. So thanks very much. In the next video, we'll learn how to use different data types to build up a description of an object. Hello friends, in this video we're going to learn how to describe an object using several different data types. So we have our little page here, HTML as always. And what we're going to do is go into default.aspx.cs, and inside page load we're going to create a description of an object that we can visualize easily, for example a table. But first, to show you that you can, we'll figure out how to set a page title automatically. So you can do that by typing page.title and then set that equal, for example, to table catalog, like this. And then terminate this with a semicolon. So before we do anything else, let's observe what this produces on the screen when we launch the page. So default.aspx so far looks like this. Notice that the title tags are empty. Hit Google Chrome. Give it a second here to generate what we need. And you can see it says table catalog in the upper left hand corner, so that confirms that the page title has been set automatically. If you right click and you go to view page source, it's also visible right here. You see, so this has been generated from C# this time. Nice little feature. Close that, and at the next stage we're going to do this. Inside page load, I made a comment right above this. The comment that goes with this is comment 7, right? Sets value of page title so it can be controlled essentially dynamically. You can imagine it changing depending on which page you load and so on. Okay. The next thing now, remember, a table basically is an object, so it has a description. So we'll type string, that is a data type. It stores sequences of characters between double quotes. And then we'll give it, the variable here will be called DESC, short for description. On the right side, we will put the value that it stores. Now, strings are a little more sophisticated, but for our purposes, at this simple of a level of explanation, it's a variable, and that's it. This is a fancy table from France. Close this with a semicolon. To make this display, simply type samplabel.text and set it equal on the right side to DESC, and that's it. Data type consistency between the two sides of an assignment operator matters. So on the left side over here I have a string, on the right side when I hover my mouse over it, I also have a string, so the two data types are consistent. Text property can store a string, for example. That there is also a string, data type consistency between the two sides of the assignment operator. So here let me just describe this variable a little bit so you understand the purpose. So comment number 8 essentially is stores description of table. So we're building up a little catalog using data types. Okay, line number 9 simply means assigns a disk or DESC, the description, to text property of labels so it can be displayed. Okay, so for display purposes, that's it. Okay, at the next stage, and again, let me fix the spelling. This is a really nice feature. I'll definitely get this. Okay, if you want, if you go to Tools, Extensions and Updates, you see in here you can search for updates and extensions. So type spell, for example. There you go. So install it. It's a really nice feature. And there might be even other ones. Okay, so if we run the code at this point, we have Google Chrome. Let's run it in Chrome. And I choose Chrome most of the time because it's easier when you go into view source to view it big. Simple enough. Okay, let's close this page. At the next stage of the process, if you have too much code, remember code is collapsible. You click that little minus and it collapses that into a single line so you have more room on the page to work with. Next stage, BOOL. This is the Boolean data type or Boolean data type, depending on where you live, people pronounce it differently. And this is good for storing true or false values. And tables, for example, you might know, have a little piece that you can put in the middle to either make the table bigger or you can have the original size. So we'll capture that in code with a true or false value. Either a table has that feature or it doesn't. So we'll say extendable. So Boolean, extendable, what we are saying is, can the table be made longer? Yes or no? So say the table is true there. Again, on the left side, hover your mouse over BOOL, you notice it's a Boolean. On the right side, the word true is reserved. It's a keyword. It's also a Boolean value type. The two data types are matched between the two sides. All right, excellent. So here, let's take a look. Comment number 10 essentially will be this one. Variable simply tells whether a table can be made longer, true or false kind of question. To print this, we will say samplabel.text. And remember, we want to append current stuff to the previous one, so plus equals. Dollar symbol for string interpolation, double quotes to make a string, BR to push down to the next line, so the content is stacked and not on a single line. And now we will say the following here. Extendable, colon, and then the value of the variable itself. So extendable, close with a semicolon. So this will, of course, simply print it. So let's observe that in action. Let me close this. So Google Chrome. There you go. Is it extendable true? This is a fancy table from France. And one thing to be observed here is when you generate output, even though sometimes you might put a little t over here, it comes up as a big T because of the way C# has been designed. So keep that in mind. It's not something that we've done. At the next stage, let me close that. We are going to add one more, like this. And then that's a data type that is good for representing monetary values because of the way it has been designed. And then price, and on the right side, you're going to type 399.99, for example, and then close with a semicolon. But that doesn't work. On the left side, you have a decimal data type. On the right side, you have a double data type. You cannot convert between them. So to make 399.99 be recognized as a decimal type, put M after it. This helps to ensure data type consistency. Decimal on the left and decimal on the right, and now there's no data clash. Great. So let's add a comment here. Stores price of table. That's it, using the decimal data type. To display it, we can proceed as before. Samplabel.text. So plus equals, put a dollar symbol for string interpolation, double quote to make a string. BR to push down to the next line in HTML, and then we will say price, colon, and then curly braces for string interpolation again, place the value, or rather the name of the variable whose value you want to print, so price, and then terminate with a semicolon. And that's it. So this, of course, as a simple comment, prints price of table. Because it is a monetary value, obviously, it's recommended to format with currency, so it looks professional. Let's observe this. So Google Chrome, just load. There you go. So it's looking pretty good. And remember, right-click, view page source. Regardless of how fancy it seems to be, it's sent to the basic HTML. And notice the table catalog, which was dynamically generated, is now within the title tags, the way you would do it if you did it by hand. So there's nothing, deeply mysterious happening here. Let me unload the page. There you go, and that is it. So in the next video, we'll continue learning more about C# by talking about computed variables and doing some very simple mathematics. Hello friends, in this video we're going to talk about some math operations, so really basic stuff. So imagine a simple situation, two people that have individual salaries. So I'm going to begin with a comment. I'll say comment number 7, basically line declares and sets two variables to represent two different salaries. Now in C#, when the data type of a variable is the same as the data type of another variable, you can put them on the same line as follows. You can type, for example, decimal. That's a good data type for storing monetary values. And then you can say salary 1, so that equals to some value, say 25,000. Put a comma, and then you don't have to type decimal again. You can simply type salary 2 and set that equals, say, to 65,000, something like that. So when the data type is the same, write it once and then make a list of variable assignments on the rest of the line. Take a look. When you type salary 1 plus salary 2, the addition here is an operator. Operators operate on things. So specifically, this is a tooltip. It shows useful information when you hover your mouse over the plus. See where it says decimal left? That refers to this value right there. Where it says decimal right, that refers to that value right there. Further, operator is simply a symbol like the addition symbol, and that is right there. That's the operator. When it operates, it produces a new value, and the data type of the value is a decimal. That is what that means. So that means over here you're going to type decimal like that, and then total salary, because the result of adding two decimals is another decimal data type value. Okay, so let's add here a comment. So the comment essentially is the two values are added on the right side. So values are added on the right side, and the result is another decimal data type. So the addition happens first, and after that, the result is saved to the variable named total salary. Now that we have that available, it's been created and set, we can print it to the screen. So we will say samplabel.text and equals. Alright, now here put the dollar symbol for string interpolation. Total salary is. Put a placeholder within the curly braces, put the variable name. Total salary, notice that shows up in IntelliSense. The list of items is called IntelliSense. And then close this with a semicolon. So of course this will simply print the value of the total salary. Because we are dealing with monetary values, let's put a colon and a C to format the output as currency. That's our code. Okay, let's run this in Chrome. And it says the total salary is nicely formatted as 90,000. Perfect. The next stage, another common mathematical operation, for example, might be to find the average of two salaries. Total salary, as an additional comment, we can say the following. Total salary is a computed variable. By that I mean its value is the result of a calculation on the right side of the equals. So it's called a computed, or some people will call it a calculated variable. Okay, so with that in place, let's move on. Next we're going to find the average. So because total salary has already been created and its value set, we can use it in code below that line. So we will say now decimal average salary equals, and to find the average of two quantities, you add them and you divide by 2. It's a good idea if you can avoid using repeated operations that have been done already to do that. In other words, type total salary divided by 2 instead. There's no need for you to type salary 1 plus salary 2 again because the total salary is the sum. It's already been found. So do that, and let's make a meaningful comment right above it. Comment 11 essentially is total salary divided by 2 is the average salary, or the salary per person. And if you hover your mouse over the division symbol, the slash, again it's an operator, and notice it says decimal left and then decimal right. So that means after it runs, it produces another decimal data type, and we know that because this is a decimal data type. Hence over here I have a decimal data type. Data types match. Same principle. When you hover your mouse over the plus, that there's a decimal data type. On that side we also have the decimal data type, so they're matched. Let's display it now. So we'll just say samplabel.text, and then again remember we want to append, so plus equals, double quotes to make a string, dollar symbol for string interpolation, and now we will say the average salary is, okay, within the curly braces write the name of your variable, so average salary colon C to format as currency, close with a semicolon. And don't forget the BR, so that line now will be pushed to its own line in the page. So put the BR. Let's observe the action. And here's the output: total salary nicely formatted as 90,000, average salary nicely formatted as 45,000. Perfect. And remember, right click, view page source. All you see behind the scenes is simple text, nothing fancy. That's it. And of course the supporting HTML. Remember, the purpose of HTML is to give structure to web pages. In the next video we will learn how to interact with users by collecting information from a text box in a web page. Welcome friends, in this video we're going to learn how to read input, convert the input, and then produce output. So let's take a look. Open up a simple project as I have here, and make sure you go to View and then Toolbox, and show the toolbox on the left. Then into the search box over here, type TEX, and that searches for the items. Then drag and drop a text box into the markup. To ensure that the box and the label are stacked vertically, over here type BR like this. And that's it. Now when you look at it in design view, you have the box and it's on top of the label. Next stage, what we want to do is add an event handler, and the purpose is after somebody inputs something into a box and hits enter, you want to be able to process that value. So go into the design view here and left double click on the box. This brings up the event handler. Event handler is basically code that runs when some event, like for example pressing a key, has occurred. So in our case, I'll let a comment here. Code below runs when the text is changed inside a box, inside our little box. Okay, so the next stage what we're going to do is this. You have to devise a sequence of steps that will do something useful. So imagine somebody inputs a value, you grab the value, and then you show that same value, but it's been increased, for example, by 10%. To accomplish that, we'll do the following here. So comment number 8 essentially, first read the value from the text property of the box. And it's very sensible that a box that is called a text box should have a text property. Alright, so to do that, type string, and then we will say input equals, and then text box 1 dot, and then text, and close with a semicolon. If you go back to default.aspx into source view, let me close the toolbox. When you drag an item in, it was automatically given the name text box 1. And that is what we see over here also being used, you see? Now further, the text here, if you have your mouse over it, you see it's got a string that it can store, for example. Same thing over here, it's a string. So the two data types are matched. Okay, now that we have a string input, that means the following. Imagine somebody inputs the number 10, that will go between double quotes like this. We need to strip away the double quotes and produce a numerical version of the input. Keep in mind that when you type 10, it's not the way you see it that matters. It's how the computer sees it that matters. Okay, so the computer will see your input as a string. You need to strip away the double quotes. You need a numerical value. So to do that, you can convert. So now we will say double here, and then we will say x equals, and then convert dot to double, and then input, and close with a semicolon. So this is a way of making a method act on a variable. Let's express that in a comment though. So the following holds essentially. Convert is a class, and for our purposes, at this simple level of explanation, is a class that stores, like this, the toDouble method. And a class, again, at this level of explanation, you think of it as a container. One of those things is a method, and a method is the following essentially. A method is a block of code that basically gets loaded into memory, it operates, and then produces output. So in other words, frequently this is what happens. A method is a block of code that accepts input, operates on the input, and produces output. That's it. So it's a little machine, just the way a program, if you think about it, is a little machine. And here's very important, hover your mouse over toDouble, and notice after it runs, it produces a double, which is the same as the data type over here. So the data types match. That's a big theme, obviously, in C#. And further, you see where it says string value? Well, in our case, that simply refers to the input. That's also a string. Okay, we know that because it's from here. That's a string. So string over here goes into toDouble. And we know that this is okay because according to the definition of toDouble, the value that it accepts is a string. And the value that it produces after it runs is a double. And that is then emphasized right there. You see? Same double. Okay. So the next stage, imagine we've produced a numerical version that's acceptable. We can make use of it. And what we are going to do is simply sampleLabel.text equals, okay, dollar symbol for string interpolation, double quotes for a string, and now we will say this. For example, your value increased by 10%, or 110% of your value is a new number. In other words, x increased by 10% is, and the only math that we are doing here is this, really basic math. If you have a number like 10 and you want 110% of it, multiply by 1.1, like that. And that will give you 110% of the number. So we'll do the same thing here. We'll take x and multiply by 1.1 and close with a semicolon. That's it. So that line below does a couple different things. Let's add a comment. X times 1.1 produces 110%, in other words, of the value of x. And this value is then printed on the screen. And that's it. Remember, at runtime, this will be replaced with the actual value of x. The calculation will be done, and then we'll go into the string to be printed on the screen. So let's observe the action here. Google Chrome. Let's load into memory. Alright, so here's a big box. And again, on your screen when you launch it might be smaller, so if you decrease that, if you increase it, I like the big one when you're learning, I think it helps. And I will input, for example, the number 100, we're familiar with that one, and then hit enter. And it says 100 increased by 10% is 110, that is correct. There's a flaw in the design of the program, and eventually we'll get to it, but for now just be aware of it. If you input a word like 10, which you can recognize in your mind as the number 10, for example, programs are not so smart. Everything has to be always spelled out very clearly. So if you input the word 10 and you hit enter, it generates an error message. It doesn't work. It doesn't allow that, okay? Keep that in mind. So I'll close this, and it generates a format exception. The input was not in a format the current code can handle. It can handle 10, but it cannot handle the word 10. There you go. Let me close that, close that. Hello friends, in this video we will learn how to read input and then how to process it using method chaining. So this is the ability to call multiple methods from left to right. In other words, The benefit is we write less code. Okay, let's take a look here. So I'm beginning with default.aspx, and into it we're going to drag a text box. So view, toolbox, Control-Alt-X, and into the search box, type text box. There's so many boxes here. And then drag the text box into the markup. There you go. Remember, this is called markup here. And in the next stage, we are going to say this. Switch to design view, and we see there's a box and then there's a label. So left double click on the box, and that brings up a stub. This is where we put our C#. Now, after you do this, if you go back to the source view for a second, it says onText changed equals, and then the name of the event handler. The event handler is this block of code that runs right here. That's why this name right here, this name here, and that name right there are the same. This is the connection between the markup and the C#. Okay. So here we're going to write the following code. We'll say bool, which is short for boolean, that is a true or false kind of quantity, is letter present. What we will do is create a program that collects input and checks whether it contains a certain letter or not, as an example. And of course, the example that I'm showing you here is completely made up just to illustrate some concepts. And I will say here textbox1.text. So first we get the text value from the text box by writing that line. Then after that, type dot, and then you can apply methods. Now remember, a method basically is a prepackaged bit of functionality that we can use in our own programs at this level of explanation. So here we will simply say to lower, and I will convert our value from the box to lowercase. And then dot, and then we can perform another action, like we can check whether our box value contains the word or the letter E. So we can say, for example, contains. And then between double quotes, put E. Now here, this is method chaining right here. So first we read the value from the box, then we convert it to lowercase, then we check whether it contains the letter E. Because the last method to be run is this one right here, we have to ensure that the result produced by the last method gives a data type that is compatible with the name here. So to do that, hover your mouse over contains, as an example. And when you look here, you see it says BOOL, and that is compatible. You see the same data types. Excellent. So this will work as expected, but let's add some comments here now. So comment number 7, assuming we're numbering all the way from the top, is this one. So first get value from box, and by that I mean the text value. So let's first get text from text box. Second stage would then essentially be run to lower to convert the input to lowercase. And the benefit of that is if you want to make a case-insensitive search, convert everything to lowercase. Don't mix cases, because then you might not find something that you want to find. Okay, comment number 9, let's add that one next. We'll say check for presence of letter E in the input. And you do that by using the contains method. So the contains method gives a true or false, like that, kind of result, which means the contains and the bool over here are matched. All right. Now the next stage, imagine we've gone through this whole process. We simply want to display some output to the users that confirms, so sample label.text, and then we'll say over here, there is of course a variety of messages you can display, but put the dollar symbol for string interpolation, double quotes to make a string, and now we'll say it's, and now you have to think in your mind a little bit abstractly the way you would think in English. It's either true or false that your input contains the letter E. So one more time. It's true or maybe it's false that your input contains the letter E. That bit that is true or false means you put a placeholder with a variable name. So our variable specifically is letter present. Okay, so it's true or false that your input contains the letter, and then close with a semicolon, like that. All right, let's observe the action here when we run the program. So launch it in Chrome. All right, so here we have a box, and into it let's type, for example, the word hello. and hit enter. And it says it's true that your input contains the letter E. That is right. So now, for the sake of variety, add a different word, like for example, fly, and then hit enter, and it says it's false that your input contains the letter E. So remember, if you right click and view page source, behind the scenes, the box that we created in C#, in the markup, is converted to a standard HTML box. This here is the code for a standard HTML box. That's all it is. A label becomes a span in HTML. That's a kind of element in HTML, you see? But the div, logical division of the page, stays as you see it. Alright, so let me close this and hit that brown button to unload. Close that little output window. There you go. So these are the basics. And remember, this is method chaining. So specifically, toLower.contains is the bit that expresses method chaining. So in the next video, then we'll take a look at making very simple decisions. Welcome friends. In this video, we'll learn how to use if-else blocks to make decisions. And there are many elements, but open up the toolbox, Ctrl-Alt-X, and then type CH, and then drag a checkbox into the markup. And then also under the checkbox is like a box. It has a check mark or it doesn't. That's it. And then wrap the label over here within a panel. So type into the toolbox search box, panel. So drag and drop a panel into the page. Close the toolbox. We don't need it anymore. Now space this out a little and then drag the label into the space between the tags that define the panel. That's it. Alright, so in design view we have just this. Let's take a look at it. So crank it up in Chrome first. Here's a simple checkbox. It's not checked. That is checked, not checked, checked. Because that is a true or false kind of quantity. In other words, either it's checked, which is true, or checked is false. So checked equals true, checked equals false. That's it. Only two possible values. It's a good candidate for working with if-else blocks in C# for that reason. So go back to default.aspx in your source code. One more thing that I want to do is, not on the panel, but on the checkbox, add this property or this attribute called auto postback and set that equal to true. This will get a fresh copy of the page basically from the server every time you either check or uncheck the box. So that is that. And at the next stage, also if you want the default value when the box first loads to be checked, type the following here, checked, and set that equal to true. Even here, when you think about it, right, when you type equals, notice only two options show, either false or true. These are used to control if-else blocks, so keep that in mind. So when we run the code this time in Google Chrome, give it a second to do its magic. Voila. See? So checked, unchecked. And notice when I uncheck it, that icon spins to mean that it's getting a copy from the server, and then when I check it, the same thing happens. So now we have a page that's dynamic, and that is accomplished by enabling auto postback in this simple case. And now go into this. Go to design view and then left double click on the checkbox. This generates event handling stub. The code that we have to write goes here. If you go back to default.aspx and source view, notice that this thing has been added right here. And the name of that item is the same as the name of this item right here. That's how you establish the connection between C# and the... Okay, so actions are taken and handled properly. So here we're going to say the following. If that checked, and we saw that checked is either true or false. That is why we can use it with an if right here. If you hover your mouse over it, it says BOOL, which is short for Boolean. In other words, this is a true or false kind of quantity, which means you can use it with an if to make a decision. So if the box has been checked, then we can show the panel. So to do that, we will say panel1.visible and set that equal to true. See? Now true, as you can see, is a Boolean value, a true or false value. It's a keyword, it's blue. It's not a word as we think of it. It has a specific reserved meaning to C#. And when you hover your mouse over visible, you observe that it's also BOOL, it's also a Boolean. So in other words, the two data types are matched between those two sides. So here we're going to say the following as comment number 7 to continue from the top. checks to see whether a checkbox is checked. That's all it's doing. So many checks now. That's all it's doing. All right. And now this code here runs. Code runs when a user essentially wants to see panel. All right. Remember, within the panel is a label that contains text. On the other hand, if the box is not checked, we've unchecked the box. We'll say else, and we'll run some other code. And that other code is to simply hide the panel. So we'll say panel one.visible and set that equal to false. False is another Boolean. You see that? It's still a true or false value. It's a reserved keyword. It's blue. That's how we know. This is a Boolean data type on the right side. On the left side, visible is also designed to store true or false values, which means the two data types are matched. I set a comment here, so the comment is essentially this one hides panel when user unchecks box, and that's it. That's the objective there. Okay, that's our simple code. That's all the C# we need. So now crank up the project in Chrome. There you go. So notice at first it's checked. Okay. So when I do that, all right, so one more thing that we have to do is this. Close that. Close the output window. Go back to default.aspx. And here put some text right there. So the text is the thing to be shown. So for example, hello world. And now run it again one last time. All right, hello world. Do that and it goes away. Check the box, it shows. Uncheck the box, it goes away. Check the box, it shows. So behind the scenes, this is powered by C#. That's it for this one. So I'll see you in the next video where we continue to learn about C# and specifically how to make variable values grow. And we'll need that to talk about loops eventually. Hello friends, in this video we're going to learn how to make a variable value grow by 1. And this absolutely does make a difference because when we talk about loops next, this essentially is assumed knowledge. Begin with a simple HTML page as I have it here. And then open up the C# page, so that looks like that. Some people call this a code behind page. Makes sense, right? It's the C# code behind the HTML. And here, keep in mind that all we are going to do is just demonstrate the operation of a single concept, or a couple different, related concepts. So say the following, integer x equals 5, and that's it. The only reason for having this variable present is the following. Variable is needed so we have something whose values can grow. So the first way of growing a value is to simply type x++. And the action here is the following. X++ has the result of making the value of x grow by 1. And that's it. Simple enough. Okay. Let's display the updated value of x. So we'll say here sampleable.text equals and then $symbol, double quotes, $symbol, not percent symbol, double quotes, and then we will say the current value of x is, and then put x within curly braces so its value can be merged into the string and shown in the window. All right, that is relatively easy. Let's take a look at the action here. So Chrome. There you go. So the current value of x is 6. That is true. Close that output window. Close that. At the next stage, another thing that you can do to grow a variable value, you can type x equals and then x plus 1. So the purpose of this line is the following. Comment number 9. X equals x plus 1 means this. Grab x, grow its value by 1, and store the value back to x. Over here, it's the same thing, where it says x++ has the result of making the value of x grow by 1. That value then is stored back to the same x. So ever and only in this entire process, there's only the variable x involved. Only one variable. Okay, let's print the updated value. So take this line from here, highlight it, Control-C to copy. If you want to go back to the beginning of a line, you hit Home. If you want to go to the end of a line on your keyboard, you hit End. And then paste, Control-V down below to paste. And because we want this output to be accumulated with the previous output, or appended to it, put plus equals. And because we want it to be on its own line, put a BR. And that's it. So let's take a look at the updated result. And it says the current value of x is 7. That is true. So we see the value of x growing clearly from 6 to 7. Close that. There you go. So this is our simple code. And remember, in the next video when we talk about loops, that ++ will be super important. Hello friends, in this video we're going to learn how to work with while loops. While loops are indispensable in real life. For example, you can use them to read a large number of rows from a file very quickly. So in real life they're super important, but I'll show you a slightly more academic example to keep things comprehensible and understandable. So in our case, we're going to display a list of the squares of some values. So 2 times 2 is 4, 3 times 3 is 9, right? 4 times 4 is 16. Clearly doing it by hand this way is not good. We need a superior way, a faster way. Well, a more mechanical but more efficient way, essentially. So go to View, and then from here choose Toolbox, and put a button into the markup. So drag a button and drop it into the markup right above the label. Close this, and then close the Solution Explorer. We don't need that either. So when you switch to Design View, we have a button and a label. And now we name the text on the button so it's more informative. We'll say here, list squares, so we understand the purpose of what we're going to do. All right, the next stage, put a BR after the button so that the button and the label are on separate lines. In other words, now they are vertically stacked and the button has a text that's useful, list squares. Okay, to make use of the button, left double click on it, and that brings up button1_click. So this is the event handler. This is the code that runs when somebody clicks it. So let's create the code. So we're going to type this integer, that's a data type for whole numbers, and then how many times. So notice that I'm naming my variables very meaningfully, and I'm using camel casing. Camel casing is called that because this here looks like the humps of a camel, you see? So it's called camel casing. There you go. And there are, of course, as you can imagine, rules for naming variables, but usually don't make them too long and make them meaningful so you understand what the purpose is, even if you look at it 2 months from now or 10 months from now. So integer, how many times in our particular case, and say 5. So the purpose of this variable is the following. Comment number 7, if we were counting from the top. Value tells how many times in all a loop. Next stage in the process is to create a counter variable. So type integer counter. Here, set that equal to 1. Keep in mind the fact that I've chosen 5 here means absolutely nothing. It can mean that number can be whatever you need it to be based on your specific situation. The fact that the counter is set equal to 1 doesn't mean anything. That initial value that's being assigned can be whatever you need it to be based on your specific problem. So you have to take a look at your situation and think about it carefully. Okay. And obviously, experiment. Okay, comment number 8. But it does serve a generic kind of purpose also, which is this one. This variable keeps the loop going. And by that, I mean the following. So let's construct the loop. We'll say here, while the counter is less than or equal to how many times. Let's add a comment. So the comment here is this one. Comment number 8. Counter less than or equal to how many times is the logical condition that controls the operation of the loop. That is the condition. And by logical, this is a less than or equal to. If you hover your mouse over it, a tooltip shows, and it tells you that when it operates, it produces a Boolean value, a true or false value. Because that is so, you can use it in a while right here. This is a Boolean or true or false kind of condition. It's either true or it's not. That's it. And then further, you observe that the operator itself is this quantity right here. So that is the operator, the less than or equal to. And of course, there are other ones that you learned in school, like greater than or equal to, and so on. And where it says integer left, that of course refers to this value. And integer right refers to this value right here. So everything that you see here is meaningful and there for a definite reason. Okay, so we have our condition. That is what controls the operation of the loop. Once the condition fails, the loop exits. So let's add that as a separate comment. once the counter, like that variable essentially, like this, is greater than how many times the loop fails, which means that it exits. We stop looping. Okay, so curly braces. And now you're going to say the following here. So remember, we're displaying the squares of some basic numbers. So to make that happen, type sample_label.text and then type here plus equals. You cannot use just plus, because if you use just plus, you will override the text every single time. So only the latest line will be visible. Plus equals appends or accumulates, so you see all the lines of output. I put a dollar symbol for string interpolation, double quotes to make a string, BR, so that content is pushed down to the next line, and then within the curly braces type counter and then squared. That's what that means. Now remember here, that quantity right there that is black will be replaced with the actual value of the counter variable. The BR serves as a way of pushing down to the next line. Dollar symbol ensures string interpolation works. Plus equals ensures stuff is appended together, so the string gets bigger and bigger and bigger. And now counter, when you see something brown, that means it goes out to the screen exactly in that form. Except of course stuff like this, which is really HTML. So that produces a visible effect. Okay, so in that case we will say this, equals, and now again, we are going to use the math class. The math class is a great class, it's got a lot of methods that are useful. So we'll type math, that's the name of a class, dot, and those are methods, the things that it can calculate. So one of them is the power, like that. And then you see double X and double Y. So what you have to do is specify two values. So counter is the first value, that is the value we want to square, and then 2, that means square. So let's add a comment here so we understand what we are doing here. There's a lot, I know that. So math.pow and then counter comma 2 means square the value of the counter. In other words, if 1 goes in, then 1 times 1 gives 1. Carefully now. 2 times 2 gives 4. 3 times 3 gives 9. So basic squaring operation from basic math. Close with a semicolon. At the next stage, type counter plus plus. Remember in the previous video we learned that plus plus has the effect of adding values. That is what that is doing for us. So let's add a comment here. And let me not forget the 1. So this will be 12 here. And we'll say this, counter plus plus grows the counter by 1 every time the loop runs. You have to do that. If you don't, the loop will never stop. And it would never stop because this condition here would always be true. The counter would always be less than or equal to how many times. Alright, so that's our code. Let's take a look here at the output. Alright, so you have a nice big button, and we hit list squares, and it shows 1 squared is 1, 2 squared is 4, 3 squared is 9, all the way to 5 squared, which is 25. If you want to understand anything in more detail, what do? You experiment, and you see what the effects are of changing quantities. Okay, so change that to say 25, and then run the code to observe what happens. That's how you can understand things in more detail. Make one modification, run the code, observe the result, and then usually the meaning becomes much more clear. So now then it'll take a look. There are 25 values. That is what it means. That's it. Okay? The fact that we're going by ones is not special, which means over here I could change the counter plus plus so that it goes up by 2 if I wanted to. Alright, if you remove the BR in this somewhat complex example and you run the code, you observe the result, and notice now everything is on a horizontal line. You don't want that, right? Close all these panels and put the BR in, and so on. And that's how you can learn more about this. Remove it, run it, observe the result, you understand what the purpose is and why it's present. And that's it for this one. So I'll see you in the next one where we talk about for loops. Hello friends, in this video we're going to learn how to use the for loop, and we'll also learn about list boxes. So first, let's put inside the HTML here a button. So view, toolbox, and then drag a button into the page right here. And the purpose of the button will be to click it so we can fill a list box using a for loop. Keep that in mind, that's the objective here. Change the displayed text so it says, for example, fill box, so the purpose is clear. Then type a BR to break down to the next line, and then after the button put basically a list box, so type list. And there's several, there's a bulleted list, but just put a list box. And that looks like that. That's all we really need. That's the visual aspect of our interface. Let's take a look at it here. Design view. So fill box and unbound. Okay. We're going to bind it in code. So left double click fill box. And that brings up the event handler. This is the code that runs when you want to fill the box with some entries. So how do we actually do that? Well, we are going to begin as follows. We'll say for int_i equals 1, I say less than or equal to 10, and then I++. Let's go over what is on the page thus far. What we have essentially is a for loop. This is a variable declaration. That's what the int_i equals 1 means. So you declare a variable right here. In the while loop, the variable was declared outside it. Here it's declared as part of the definition of the loop. Okay, then we have a logical condition. I is less than or equal to 10. We had a logical condition with the while loop. So far, if you think about this carefully, this is a very similar concept, logically speaking. It's not altogether different. Now, the I++ is needed to keep the loop going. It grows the value of I as the loop executes. Listbox1.items.clear. This is needed for the following reason. If you hit the button to fill the box, but you don't have that line, the output just gets more and more and more. It grows and grows and grows. So this clears out the items in the box. Listbox1 is the name of the box. Items is the collection of items that you have stored inside it, and clear is a method that can get rid of them. Move them away, clear them away. So let's add a comment here. Needed to clear box. So output does not accumulate. At the next stage, let's add some more comments here. Comment 8. Integer I equals 1 simply means the first value to show in the box will be 1. That's all it means. It could be 0, for example. So nothing special about that, to be honest. All right. Comment number 9. I is less than or equal to 10 is the logical condition that makes the loop run. The loop ends once the condition has failed. Once I, for example, assumes the value 11, then the condition will fail. It will stop running until, say, I has the value 11, and then the condition fails and the loop stops. All right. 10, I++ is needed to keep the value of I growing. In the context of while loops, we saw exactly the same logic. We saw counter ++, here it's I++. There's nothing special about even using I. You can use counter if you want also. Okay, so now what we want to do is take our loop and fill the box. How can we accomplish that? Well, take a look. If over here you have listbox1.items.clear, you very likely have a method called add. So let's take a look. Listbox1.items. And when it shows up here, you see this? These are the methods that can run. You can clear away the items in the list, or you can add them. That's it. So you can put an item inside the list, and then put the I and close with a semicolon. There's an error message. Hover your mouse over I, and it says, cannot convert from int, which is integer, to string. Well, we can actually. Type dot, and then the method on the screen can be used to operate on I. And one of them is called toString. See that? And it converts the numeric value to its string representation. That's it. So this step here is add a comment. The comment is this. I toString, like this, takes, say, 5 and produces 5 within double quotes. Remember, it's not how it looks to you, it's how it looks to the computer. The computer sees the number 5 and 5 within double quotes as 2 different data types. Okay. And notice another thing here, because there's only one line of logic after the for, a single line of logic, this is a single line of logic. You don't need even curly braces, that's it. Okay, let's take a look at this in action. So Google Chrome, give it a second here to load, and then we'll hit fill box, and the box is right here and has been filled, you see, with 10 values. So clearly generating values like this by hand could be tedious and time consuming. This loop is superior. There you go. Or if you had to read from such a box, clearly using a loop like this would be superior. And if you want to know the purpose of anything more clearly, well, what do? So switch this over from, say, 10 to 20. The difference in results usually reveals the purpose of the quantity you have changed. So fill box, and now it's 20, and so on. Let me close this window here. And one more thing is, sometimes, imagine you want to go in twos. Is that possible? Yes. You can type, for example, I equals I plus 2, like that. And now take a look. That will essentially make I grow by 2 every time instead of 1. So let's take a look at the values that show on the screen when we do that. It goes 1, and then 1 and 2 is 3. 3 and 2 is 5. 5 and 2 is 7. All the way to the end where 17 plus 2 is 19. So now you're going by 2s by changing that value right there. But it's customary to go, by 1s, I++. In the next video, we'll talk about for each loops and how they can be used to iterate over collections of items. Hello friends, welcome. In this video, we're going to learn about for each loops. These are good for examining collections of items. So imagine we are within default.aspx. Make sure you are within the form element, like that. And the first thing to be done is basically grab and drag a box, a text box, into the page. So view here and then toolbox, and then type TE, X, and then drag a box and drop it. For the purpose of the box, if you miss sometimes, it's okay. You see, when it's all highlighted like this, you can just still move it around and place it anywhere you like. I'll drop it there. That's it. So now we have a box. From the box, we will read a string and then grab each character in the string individually. So that is our objective here. So at the next stage, add a label also. So expand the toolbox. Let's type here LA. Drag and drop a label into the markup. So now we have a label. Separate them vertically. So put a BR in here to do that. And that looks like that. So let's view this in design view, lower left hand corner. So now we have a box and a label under the box. And now we're going to relate the two using following. So left double click on the box. That generates the text box 1 underscore text changed event handler. I had one from earlier. I'll delete it just to show you that you can. You see? There you go. All right. So at this stage, what we're going to do is the following here. We have to read the value from the box first. So we will say string, and then input equals, and then text box 1.text. So what this line does for us is the following. I will number this comment 7 because this is up top. Reads value from box and saves to input variable. That's the objective of the line. Now the next stage, once you have it saved in the input variable as a string, we need to now grab each character. To do that, use the for each. So type for each, and now what do you write? Well, the for each has a certain standard design, but before I do that, take a look. If I gave you the word here, he, like that, between double quotes, this word really consists of this character right here. That's one character, the letter H, and then there's the character E. So the word he, which is a string in C#, really consists of 2 characters. Each individual component of the string is a character, in other words. And that matters because now I know that here I should type CHAR. So for each character, C, that's a made-up word. For example, if you want, you can use D or something else, but I'll just use C, which is short for character, essentially. So for each character C in the collection, so the collection is the input, so type input, we will take an action. But let's interpret this in simple English. This means grab each letter in the string. Okay, so now we understand why the for each is present. At the next stage, we have to write additional code to, for example, begin with something like hello. And what we want to do is produce essentially something like this. H, and then the E would be on its own line like that, all the way down to LLO. We are beginning with a horizontal word and then spelling it out vertically instead. That's our objective. So because that is the case, we need to definitely push down to the next line as we do that. All right. So one thing that I want to do, however, is first go back to default.aspx, and you see where it says label, clear that out. That means in source view, remove the text property of the label, the attributes. Zero that out, make it disappear. Okay, go back to design view. That looks like that now. You see, the only thing left is the ID of the label, but that doesn't show on a page. The text, the value of the text attribute does. All right, go back to default.aspx.cf. And here we're going to say the following: sample label, or rather just label 1, the text, and plus equals. Remember, the action of the plus equals is to stack up input, okay, or output, depending on what you need. But the point is that it's accumulating it, not overwriting. And then you're going to put a dollar symbol for string interpolation, then double quotes to make a string. And then because the objective is to write it down to the next line, we'll put a BR over here. And then within curly braces, place the variable whose value you want to show. So that is C. And then close this with a semicolon. Now remember, this for each controls only the line right after it. When all you have is one line of logic after a loop, it's assumed that the loop controls only that one line of logic, whatever it happens to be. Prints C to the window like that, or to the page, in a vertical column this time. Let's observe this in action. Google Chrome, give it a second here. So here's our box, and if I just type, for example, hello, and I hit enter, it spells out hello in a vertical column, as I said it would. If you wish to understand what the meaning is of each line in more detail, what do? You just remove it. So first, remove the BR and run the code, and observe the difference. All right, so now, well, that just reproduces the word. So now we understand that the BR is necessary to break the word over individual lines. All right, and again, remove the plus, and that looks like that now. So run it. This simple procedure will eliminate all doubt as to the purpose of things. So hello. And notice that only the last thing outputs on the screen. There you go. So that's not what we want. So you put plus equals. And that's how you can investigate these things in more detail. All right, and that is it for this one. I will see the next one where we talk about examining multiple values with switch blocks. Welcome friends, in this video we will learn about switch blocks and a drop-down list. So when we'll make the switch block work with the drop-down list, and you'll see why that is very natural to combine the two. So over here, go to view, and then we'll go to toolbox. And from the toolbox, we'll place the following. Type drop, drag a drop list into the form. Under the drop list, also place a label, and that looks like this. So the drop list allows us to choose from among several choices. Switch over to design view, and now it looks like this. Notice the label needs to be pushed down to the next line. So over here, type of BR. That's the effect of pushing the label to its own line. In design view, you can see the label now is below the box. And now, click that little arrow that points to the right, and you see where it says edit items. Do that. And here we can add the items to be displayed in the list. For example, click add. All right. I will say here pairs, and notice the values automatically filled. Then click add, and say apples. Let's do one more. Mangoes. There you go. And that number there is the index. So this is at index 0, index 1, index 2, and so on. Okay, then just click OK, and make sure you select Enable Auto Postback. That means when you interact with the list and make a new choice, you get a fresh copy of the page essentially. So you're posting back to the server automatically. Okay, that looks like this. So before we do anything else, hit Google Chrome and let's take a look at the results so far. Give it a second here. So here we are, the page has loaded, so it says pears, right? You can select apples, and notice when you do that, that icon spins. You select mangoes, that icon spins, and so on. So now we're going to display some information about each choice. So if you select pears, we'll display some information, and so on. So let's do that. Unload the page with the brown button. Switch over now into default.aspx.cs. That looks like this. If you don't have that, I'll show you. You take this, you remove it. Go back into default.aspx and then left double click on the drop down list to generate this stub right here. Here is where we are going to process information. So we will say this, switch. To switch means to grab something and examine its possible value. So in other case, now we will type drop down list 1. That's our list, dot. And one of the things that it stores is the selected value. So we can examine a selection. Alright, so with that, we're going to say case, and then we will say here pears. So if somebody, for example, chooses the pears option, we need to run some code. We'll give the page a title, so page.title, like that. So this will be filled at runtime. It will change automatically. And now you will say, for example, pears. And that's it, close with a semicolon. So here, this is sometimes called a case label. Let me add a comment. Case label. This here sets title of page as program runs. After that, we can display some other information. So we have a label in our page, so type the following here. Label1.text, and set that equal to some information about pears, for example. So pears cost 25 cents each, and then terminate this with a semicolon. If you want to show a cent symbol, it's a really nice feature that you can do. This is what you do. You put a slash, like that, and then you type U and then 00A2. At runtime, this portion will be rendered as basically a cent symbol. The next stage, because of the design of the switch block, put a break. That's it. So here we have the case label. So title of page as program runs. This, of course, simply means fill label on page with some information specific to pears. And at the last stage, what that means is leave the switch block. That's it. So once you have processed a case, for example, pears, if that is the one that is matched, then you leave the body of the switch block. But let's create one more case for the sake of illustrating. Even though we have 3 there, I'll show only 2. After that, you can of course just take this code. So selected, Control C, and then Control V down below to paste. And now we switch. But this also is a lesson when you think about it, because it says here, the switch statement contains multiple cases with the value pairs. So now you know that's not allowed. You need to switch this to a new value. Right? That's what it means to switch when you think about it. So here we're going to say apples. Alright, in that case, we title the page. So give it a dynamic title like apples or apple information or information about apples, something relevant. Okay, change the message. So it says, say, apples cost 50 cents each. And then you leave the switch block after that. You could ask, for example, also for the case of mangoes, but this is sufficient for our purposes. Alright, so let's observe this in action now. Crank up Google Chrome. And notice that first it says pears, okay? So if I switch to apples, it says apples cost 50 cents each. Now we have that nice cent symbol. Go back to pears and it says pears cost 25 cents each and so on. Let me close this. There you go. So these are some of the basics of doing something fairly practical with a switch block. So again, because of the nature of a drop-down list and the fact that you can examine multiple values, it kind of marries very naturally with a switch block, as I've shown you. In the next video, I'll show you how to use the try-parse method to write more stable and professional code. Hello friends, in this video we're going to learn how to use the try-parse method, or a version of that method, to write more stable code. That's our objective here. So begin with a simple HTML page and view, toolbox, and let's place a button in here and a text box. So the button will basically say calculate, and we'll just display, like, for example, some number increased by 10%. That depends on what you need, obviously. So here I'll just say text box. So drag and drop that into the page. Right, above it, place a button so the user has something to click on. So BUTT. Drag and drop that into the page. Alright, stack them vertically. So after the button, type BR. You can even leave the names if you want, except display the text on the button. So it says something more informative, like, for example, find 110% of value. That's it. Let's take a look at in design view what we have here. So we have a button. Under the button, we have a text box. So we need one more visual element, which is a label. So type BR after the text box and then place a label under that. So we have a place to display information. So drag and drop a label into the page. So now we have a button, a box, and a label stacked vertically. Okay, so here perhaps display nothing. So you can just remove the text attribute altogether, you see? Now in design view, all you see is label, the name, the ID of it, in code is what becomes visible. But at runtime, it's no longer visible. Keep that in mind. All right, so let's just run this first in Chrome to observe what we've done so far. So here's our simple interface. If I click the button, that's nice, right? I have a box, I input 67. See? So you have a button and a box. Now we need to connect them together. And the label, that's not visible here, but remember, it's still there. So exit off the screen, close it. All right, so now switch into default SPX by left double clicking on the button. And that brings up the event handler, or the code that runs when somebody interacts by clicking on the button. So here all we're going to do is this. We'll say double X out and do not set that value. So let me add a comment. Why is this variable necessary? That's the question. So variable is needed so that try parse, that method that will attempt to convert to a numerical value if it can, try parse, can operate as it's been designed to do. As it's been designed to do. Alright, so to make use of try parse, type this as follows here. If, like that, and then type this, double dot try parse. Now if, remember, runs on Boolean or logical conditions, true or false kinds of statements, hover your mouse over try parse, and notice that it gives back a BOOL, a Boolean value, a true or false value. That is why it can be used with an if. As you can see, you have to feed in a string, and then also something called an out double result. So the out is basically a parameter. It's a value you can feed into it. If try parse can set it, it will. And then that value becomes available in our own code so we can make use of it. And double, of course, is the data type. So out is a new keyword here. Keep that in mind, out. Let's take a look at this in action. So double dot try parse, and now, for example, the string. So where will we get the string, the value? That should come from the text box. So here, if you want, you can just directly type text box 1.text. So that means get the text out of the text box, and try parse, remember, it's called try parse. It doesn't guarantee it will, but it might, depending on how you input the value. So try parse, and then we will say, for example, here, out, X out. So what this is saying, let me describe this in some detail here. Basically, a line below says something like this. Take text from box, and if possible, convert it to a numerical value. There's no guarantee that will happen for the following reason. If a user inputs the word 10, this cannot be converted to the number 10, like that. Keep in mind a basic fact. When you enter a value, even if it looks like a number to you, it's not. So when you enter a value, for example, like 10, into a text box, C# first sees 10 between double quotes, a string. This is when you hover your mouse over text, it says, you see that string. Right there, it's a string. So then, if possible, use try parse to convert that into a truly numerical form. so that you can operate on it mathematically. At the next stage, open, close curly braces. So imagine try parse succeeds. So try parse really does two things. When you hover your mouse over it, it first of all indicates whether something has succeeded in terms of being converted to a numerical value. That is a true or false result. That is the meaning of it right there. So that tells you first, yes, perhaps I've been able to succeed in converting your input into a numerical value. But beyond that, if that process succeeds, it also makes available to us the result, the value itself. So try parse accomplishes two different things. Keep that in mind. All right. So imagine we have that numerical result available now. We can make use of it. For example, label one.text and set that equal to something like, for example, put a dollar symbol, double quotes to make a string, and then we'll say X out. Increased by, say, 10% is, and then to find the value of X increased by 10%, it's like X out times 1.1, and then close this with a semicolon. That's it. All right, now, the beauty of try parse is because it returns a Boolean true or false value, that means there's an else involved. So type now else, and if your input cannot be converted to a truly numerical form that is mathematically useful, then you can display a message. So label one.text, and then say, for example, input cannot be treated as a numerical value, and you close with a semicolon. So this immediately improves our program over the way we might have written it previously. All right. In other words, it's more stable. It won't crash this time. So, but let's add a comment here. So this is the line right here. Line runs when successful conversion to numerical form occurs. So line runs when input can be converted. These comments here are a little bit lengthy. Line runs when input can be converted successfully to numerical form. So in other words, if you input something like this, 10, and here 12 runs when input cannot be converted to numerical form. So let's take a look at what happens here. That's our code. Crank it up in Chrome. There has to be some benefit, obviously, to writing this. Okay, so let's take a look. Find 110% of value. So input 100, that's easy. And then hit the button, and it says 100 increased by 10% is 110, correct. But now input the word 100, and it says input cannot be treated as a numerical value. That is correct. So it's more stable in that sense, you see? Let me close this. Close this. Remember, try parse is powerful. There's decimal.try parse, boolean.try parse, and so on. But the thing that matters is understanding it properly. So remember, it does two things. It takes that value and brings it into the method so it can operate on it. That there, assuming the method has worked successfully, sets a value we can use in the code below. Further, the bool that you see over here tells you whether the conversion has been successful or not. In the next video then, we'll talk about the ternary operator. Hello friends, in this video we're going to learn how to make use of the ternary operator to make decisions. I'll show you how to use it with the try parse method so you can understand its power more fully. Alright, so we're going to create a program that takes two boxes. Let's do that first, and then we'll read the values and then operate on them mathematically. So go to view and switch over to the toolbox, and then add two text boxes. So type TX and then drag a box into the form, and then say put a BR, put another box under it, like that. After that, put a button, and we'll hit the button and do a calculation. So drag a button and place that right there. So now change the displayed text on the button from button to, for example, say find sum. Switch over to design view, and that looks like that. Now we need to be able to display the results somewhere. So in source view, again type BR, and then after the button put a label. So LAB, drag and drop a label into the page, clear out the default text on the label, like that, and now go over to design view, and there we are. So there's our simple user interface. Now we're going to create code. So left double click on the button, and that brings up the event handling code. So the code to be created and run, take an action when somebody clicks the button. So the code is one that looks like this. We have to read the two values and then take an action. So we will say the following here. Double X out and Y out. So the purpose of these variables is to try to set them using try parse. Let's add a comment here. So purpose of these variables is to try to set them using try parse. Remember, try parse, if it is able to convert, assigns a value. But if it's not able to convert, it saves a 0 to the variable. Keep that in mind, so it does that. Okay, so there's a value saved of some kind, but a 0 obviously is not the one that you want in most cases. Keep that in mind. So here we're going to say the following here now. Double X equals. And now we will combine try parse with double.try parse. And you have to read from the first box. So we'll say text box 1 dot text. And this is okay because in default.aspx, when you drag elements into a page, they're given an automatic ID. So ID is text box 1 and then text box 2. See? So over here we can type comma and then we will say out and then a result. So the value that we can potentially produce from the attempt to convert using try parse. So let's say here X out. Now, if this is successful, if you successfully produce a numerical value, you want to save that over to X as an example. So you can put that, and then you can type, for example, X out. On the other hand, when there is no success, you can just save the value 0. Here, if you wanted to, you could also type X out, so believe it or not. But the only thing is this is now becoming difficult to understand, correct? So here, remember when the code runs, if this process succeeds, then the value here is saved over to X. And that value could be 5 or 10 or 15. On the other hand, if this process right here fails, then X out is given the value 0, so that would save 0 over to X. But I prefer to keep things explicit, so I'll just put a 0 in here. So here let's add a couple comments above. So comment number 8 will be line below combines the ternary operator with try parse. And again, to refresh our memory, let me check the spelling here. Let's say the following comment number 9. So if we can successfully convert, if conversion works, save X out has the intended value and it's then saved to X. On the other hand, if conversion fails, X out has the value 0, and you could save that again to X, but I've chosen to make it explicit, just put a 0 in there, that's it. But I've chosen, to just save X to, or rather 0 to X explicitly by writing it right there. That's it. Okay, at the next stage, we are going to repeat this. We want to add two values. So now we will say this following here. Double Y equals, in the same process, so double.try parse, and then you'll say text box 2 this time, so grab the value from the second box as a text, as a string value, and set it inside the methods, so out, Y out. If that is successful, then the Y out value, that value there, will be saved over to the variable named Y. So in other words, if this here is successful, then you have a value, and that value is saved over to the Y. Now, one more thing that I haven't mentioned, hover your mouse over try parse. Remember, it's a Boolean kind of quantity that it gives back to you. And remember, the try parse operates on this basic logic that here you have a condition, a logical condition. Then you have a question mark. Then the second bit is the stuff that is, for example, saved to a variable if the condition is true. On the other hand, that bit right there is what is saved to the variable if the condition is false. So if this is true, then that is saved to the variable. On the other hand, let me repeat it one more time. If this condition is false, then this is the exclamation mark, or the question mark rather. So if that's false, then this here is not saved. You skip it, and the thing saved to the variable is this third thing right here. This is the thing that would be saved to the variable on the left side of the equals. That's how it operates. Regardless of how sophisticated it seems, that's what it's doing. So here, if yout is produced as a good value from the result of using try-parse, then you can save it over to the variable named y. On the other hand, just save a 0. If you wanted to, because the conversion might fail. If the conversion fails, then yout is just given the value 0. You could just type yout also. But then it gets like really confusing, so I make it explicit by typing 0, and that's it. Okay, it's a matter of preference. Alright, so the next stage here, we're going to say the following here. The same logic basically applies to this line as to the one above, so keep that in mind. But I'll make these explicit anyway, just to save some space also. So in this case, we're going to put yout has the intended value, and it's then saved to y. If the conversion fails, yout has the value 0, but I've chosen to just save 0 to x, or in this case y, explicitly. So it's easy to understand. That's all. So now that we have these two perhaps potentially correct numerical values, we can make use of them. We can say label1.text and just display the sum. So your sum is, alright, let's use string interpolation, so put a symbol like that there, and then your sum is, and stick in the sum, so x plus y. You can do a calculation right within the curly braces, and that's it. So comment 11 down below would be x plus y are added. The result is saved into the string for printing. That's it. So let's observe this happen. So Google Chrome, give it a second here. Alright, so here we are. Let's enter some values of 5 and 10 and find the sum. And it says your sum is 15. But if you input some, mumbo jumbo and a number like 10, it says your sum is 10. So now it doesn't try to add something that clearly is not numerical with something that is numerical. Alright friends, so in the next video we'll talk about using various logical operators. And notice also that I've renumbered the comments so they go as they're supposed to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And please remember that the code is always available. I put the link in there, lesson, resources. In this video, friends, we're going to learn about several different kinds of operators that are commonly used. So let's take a look at these in action. Crank up a project, and this time let's go to View here and Toolbox, and just drag a label into the markup. And also above the label, let's place a button. We will click the button, and then we'll show some output in the label. So remember, these things in code are called button 1 and label 1. So the ID, remember, is how you refer to it in your C# code. Okay, so go back to design view, and then left double click on the button. Now notice I left the textless button. We can fix that. Alright, so that brings up the code event handler down below. And let me delete some of the comments that I had left here. Alright, so the only difference is I will rename that so that it says button1_click is code that runs when a page loads from a server, essentially, for our purposes. So when you click a button, that's it. So here we're going to illustrate some operators. So we need a variable whose value we can change. This variable does not represent anything. We simply need it for the purposes of illustrating the concepts. And that's it. So this line here, of course, declares and sets a variable. So we can illustrate some basic concepts. Alright, so the first one is this. Imagine you want to print a value of a variable after it's been incremented by 1. Type label $1.text and then set that equal to the following, say $symbol, and then say x equals. And remember, the objective is first increment x by 1, so grow its value by 1, and then print the updated value. So type ++x, and then you close this with a semicolon. So the effect of this line, this is the pre-increment operator. It acts on x to increase its value by 1, and that updated value is then stuck into the string, and it's printed using string interpolation, as you see there on the screen. So here let's describe the action of this operator. So plus x runs first, which means x will show 26, not 25. Let's observe that in action. All right, I will just hit the button here, and it says x equals 26. That confirms it's working as expected. Okay, let me close these windows and load the project. All right, so that's one thing. As you can imagine, of course, there are many other ones. So imagine you want to do something like increase the value of a variable by 2. So how can we do that? We can, for example, say the following. Label 1 dot text. All right, and then remember plus equals, so that we are going to append what we want to output at this line to what already has been output. Dollar symbol for string interpolation, double quotes to make a string, BR to push down to the next line, so everything is on its own horizontal line. And now we're going to show the value of x increased by 2. How can we do that? So for example, you can say x plus 2 would have some value. To do that, you can type this. Within the curly braces, type x, and then you will say the following here. Plus equals 2, and then close with a semicolon. So here, let's describe what we have done here. Line number 9. So code below, where it says x plus equals 2 means the same thing as x equals x plus 2, which in simple English means grab x, add 2 to it, and store back to x. So there's only one variable involved here, named x. That's it. There aren't multiple variables. Even if they're written multiple times, that doesn't mean anything. All right, so here let me do that, and let's observe the results. Also remember, this right here, when it's brown, it's printed to the screen exactly. When it's black within curly braces, that means you're going to do a mathematical operation and then take the final value and stick it into the string. The BR pushes down to the next page, or rather to the next line within a web page. Let's observe. All right, so button, and it says x equals 26 and x plus 2 equals 28. That's correct. 26 plus 2 is 28. All right, so here what I want to do is unload this. Let's fix up the default.aspx a little bit. So switch over to source view, and after the button, put a BR. And notice also when we clicked on the button to generate the event handler, the code, it added one of these things right here. So again, onClick equals button1 underscore click means connect what we see here to what is shown right here. That's why those two names, that is also button under one score click. That's how you establish the connection between the two. All right. All right, the next stage here, I'm going to show you a couple other operators. So imagine comment number 10. You want to take a value of x and say decrease it by 1. Okay, before printing, or something like along those lines. So we can do that as follows. Minus minus x has the action of decreasing x by 1 and then printing the updated value. Because the minus minus is in front of the x, it runs first. Then the updated new value of x is printed. Let's check that out. So label 1.text, and then we will say plus equals to append, dollar symbol for string interpolation, BR to push down to the next line, and now minus minus x is the same as saying subtract 1 from x. It's like writing x minus 1. All right, so let's observe the results here. Hit the button, and it says x is 26. 26 plus 2 is 28. 28 minus 1 is 27. There you go. All right, so that's working as expected. Let's show one more. For example, you can also do logical comparisons. So stuff like this. Comment number 11. Now, of course, I cannot show you all of them. There are many of them, but the logic is pretty much, follows these lines. And then we'll say one more here. So this symbol here, 2 equals, checks whether two quantities are equal or not. Let's check that out. So we'll say label 1.text and plus equals to append. All right, string interpolation with dollar symbol, BR. And now we just want to check, for example, whether x equals the number 3. So does x equal 3? And to answer that question, we can say, for example, plus, and then you will say x equals 3. Close with a semicolon. So here, if you hover your mouse over the double equals, that is an operator, and it compares two values. The double left simply means whatever the value of x happens to be. The double right refers to the 3. When it operates, it's an operator. It operates on two things, something on the left, something on the right. The result of running this operation is a Boolean data type. Either x is 3 or it's not. That's it. So it's a true or false kind of comparison that you are making. So again, to emphasize this, remember, that means assignment. That means compare two values. So the equals and the double equals have different meanings, as they do, in some other languages. All right, let me fix the spelling here of quantities, and let's take a look. Hit button, and it says, does x equal 3? That is false, because x is 27. It's up here. X is 20. Well, x minus 1 is 27. See? So the point is x does not equal to 3. It's a false statement. All right, let me close this. There you go. And there are, of course, similar ones to these. Next, we'll talk about another kind of logical operator. Hello, friends. In this video, I'm going to show you how to use the logical AND operator. So crank up a project, and this time what we are going to do is build a simple interface with two boxes, a button, and a label. So I have the toolbox ready to go over here. I'm going to type TX, and then drag a couple boxes into the page. So we will read a couple values from the boxes, and then we'll just check whether they're empty or not, for example. Alright, and then do it one more time. So one more box, one more text box. Drag that into the page. Excellent. Okay, after this, we can place a button that somebody can click on. So BUTT, drag a button into the page. And after that, place a label. So let's do a label also, so we have a place to display content. Pull that into the page. Alright, there we are. So a very simple interface. So here before each text box, let's put a little bit of text. So we'll say enter value. And then do it one more time to enter second value, enter value again. And change the visible text on the button so it says, for example, save. We are pretending that we're going to save to a database. Eventually we'll do that in real code, but this is just a simulation, that's all. Okay, and then take a look at it in design view, and that looks like this. We've got two boxes and a save button and a label. So now left to double click on the button. So here we are inside the event handler, and we're going to create code that ensures that both boxes have entries. In other words, we're going to ensure that neither box is empty. So you will say if text box 1.text does not equal to that. So this symbol here is read as does not equal. This is simply confirming that the text in the box is something different from nothing, that there is something there, in other words. That's what it's confirming it. Alright, and then you will use the symbol AND. That's what that means. The logical AND operator. And then you will say text box 2.text does not equal nothing. In other words, in simple English, this is saying is something present in the boxes. Let's add a comment here. 7 this time. So line below ensures entries are present in both boxes. That's what it's checking. Alright. Now, imagine there are entries in both boxes. In that case, display some text. So label 1.text, and then we'll say, for example, your entries have been saved. We're pretending we're saving to a database. In real life, that's not so easy. You gotta write a lot more code. On the other hand, if one of the boxes is empty or both boxes are empty, we have to display a relevant message. So we will say else, open close curly braces, and then we will say label 1.text, and then we'll display a relevant message. So for example, both entries must be specified. And then close this with a semicolon. That's it. This is our simple program. Let's add a couple more comments. This line right here. Line runs when both boxes are filled, in simple English. On the other hand, comment number 9 would be here. Runs when one box or the other box, or both boxes potentially are empty. Or both boxes are empty. Now this symbol here, this is a logical AND operator. It's short circuits, which means the following. If this right here is false, that is a logical condition. If that is false, the right side is not checked and you skip into the else. So in other words, I'm going to use the letters F. So imagine this evaluates to F, this side. That means you're going to skip down to the else block directly. Okay. If this is true, that condition is true, and this condition is true, then the code that executes is this one right here. So the only time that runs is if the left side is true and the right side is true. Imagine that's false. So again, that's going to skip down to else, and the right side would not even be checked. That is called short circuiting. And one more thing here. If this is true, but the right side is false, then again, you're going to skip down to the else. All right. So let's go through this process now. Chrome. So here we are with the boxes, and now you experiment with possible values. So first, don't enter something in the first box or the second box. They're both empty, and you hit save, and it says both entries must be specified. That confirms that the else block has executed. You can see that in the messages. Now, put something into this box, so for example, hello, but leave the second box empty. And look at the values. Again, it says both entries must be specified. That confirms the else block has run again. All right, then put something into this box here. Empty out the first box, and then hit save. And again, that confirms that the else block has run. So we have tried 3 cases, and all of them, the else block has executed. Now put in entries both, and then click save, and it says your entries have been saved. So the only time that this runs is if you have entries in both boxes on the page. If you don't have them in both boxes every single time, then that code doesn't run. The else portion of the block runs. So these are the basics of using the logical AND operator and specifically understanding how it executes. Alright, let me close this. There you go. In the next video, we'll talk about the logical OR operator. Hello friends, in this video we're going to learn how to use the logical OR operator, and we'll also learn about checkboxes. So, into the form here we're going to place a couple of checkboxes. So open up the toolbox and drag a checkbox into the page. If you switch over to design view, that looks like this. Let's launch this so we can see how it's rendered in Chrome. And keep in mind that the rendering of these things, the visual appearance, can vary sometimes from browser to browser. So this is a checkbox. You basically check it and it's checked, or you uncheck it. So clearly what is true about this is it has 2 possible states, 2 possible values. Checked, unchecked. That's it. Alright, let me close this. Shut down the program and okay, go back into the source view here. And we are going to build up the interface. So put a BR at the end. Add one more box. So again, drag another box into the page. And then I put another BR over here. Alright. And then also add a text attribute to each checkbox. So for example, type text. And set that equal, for example, to something like smoker. And one more text. And say, over 45 or something. There you go. So that looks like this. So go back to design view, and now we have 2 checkboxes. And notice they look much more plain when you design them. They look a little more attractive when you actually view them in Chrome. And now one more thing. So add a button so we can analyze the results. So put a button there under the boxes, BU, like that. And change it, for example, it says here, submit. And then put another BR, and then a label for the purposes of showing the results. So put LAB and drag a label into the box, well, into the markup. Alright, and now click over to design view. This is our markup, our basic HTML. And there's the appearance. So let's view it again. When it gets a little more complex, it's good to view things in stages as you build them. Alright, so that looks pretty good. There you go, right? You got a couple of boxes, you hit the submit button. So clearly we need to be able to examine the values, whether something is checked or not, and so on. So to do that exactly now in C#, you're going to left double click on the submit button, and that brings up the event handler. So let me just add a bit of code here. So code below runs when submit button is clicked. Alright, excellent. So what is the code? The code is this. We'll say if, and then you'll say checkbox 1 is checked. You do that by typing dot, and then you get the checked property. This is a true or false kind of quantity. However, you mouse over it and it says BOOL, Boolean. That is why you can use it with an if. So if checkbox 1 dot checked, right? In simple English, this is saying, is there a check mark in the box or not? Alright, so if one of the boxes is checked, or in C# to say or, you type 2 vertical lines like that. That means or. Checkbox 2 is checked. So in simple English, let me express this. In English, that bit right there would essentially be expressed as follows. We'd say the following. Is box 1 or box 2 or potentially both boxes checked? So is the first one checked or the second one or both potentially? So then we have to take an action. Imagine both boxes are checked, or maybe one or the second one. It doesn't matter. Here, let's display a relevant line of text. So label 1.text, and now we will say, for example, you do not qualify for a discount or something like that. Close with a semicolon. There you go. Alright, so let's add a comment. When does this run? So this runs when, and let me close the toolbox so I have more space. Runs when one box or the other or both are checked. That's when it runs. On the other hand, imagine neither box is checked. In other words, both boxes are empty. Type else, open close curly braces, and then type label1.text equals, and then you'll say, for example, you do qualify for a discount. Close with a semicolon. There you go. So let's add a comment here. Runs when neither box is checked. In other words, there's not a check marks in the first one or the second one. Okay, that's just, I know that still seems a little abstract, so the best thing to do is to actually type the code, run it, and experiment with potential box values. That's always the best approach, experiment. Google Chrome, let it load. So here we have this. So first of all, if I don't check either box, right, they're both blank, and I hit submit, it says you do qualify for a discount. There you go. Imagine I check smoker and I hit submit, and it says you do not qualify for a discount, maybe on health insurance or something. Imagine I hit only over 45 and I hit submit, and it says you do not qualify for a discount. Now imagine I select both of them and I hit submit, and again it says you do not qualify for a discount. So these are the basic operations of the logical OR operator. That looks like this. In other words, if this side is true, but this side is false, then the whole operator evaluates to true, which means this runs right here. Alright? On the other hand, if this is false, but this is true, this thing will still execute. Only one of these conditions has to be true for the line immediately within the if block to run. Alright, now if this is true and this is false, this operator right here short circuits, which means because the left side of it is true, this runs and the right side is not even checked. This is called short circuiting. So one more time, if this is true, that side is not even checked, and then you just run the if block. One more thing, if this is false and this is false, then the else block is the one that executes. This is why I have the two check boxes, because if you write the code and you check the values of the boxes, you can experiment, and then that'll allow you to develop a deeper understanding of the operation of this thing right here. This is the OR, the logical OR operator. And that is it for this one. I'll see you in the next video. Welcome friends, in this video we're going to learn about the basics of arrays. So create a couple text boxes and then read the values from the boxes into an array. An array is like a block of memory. Okay, so grab a text box. And then one more text box. And then after that place a button. And then under that place a label so you have a place to display some output. There you go. So this is the basic user interface. Let's change a couple things here though. So first of all, put this so that they're on separate lines. So put the BRs, the line breaks, after the button. The label doesn't need it because there's nothing under it, so it can stay there. Change the text on the button so it, for example, says summarize. And what we will do is read some values, store them to an array, and then, for example, show the total of the values and then also the average of the values. So this is the basic interface. In design view, what you see looks like this. So two boxes, a button, and a label. Let's preview it quickly, make sure that you can see it clearly. When it comes up, it looks like this. That's it. Alright, so now you can close this. Let's unload this. And left double click on the button labeled summarize. So here we are inside the event handler for the click event. When somebody clicks the button, we respond to it with this code. So we're going to first remember we have two boxes. So we are going to create an array, read the values, and operate on them. So as an example, you can say decimal, that's a data type. Then you put brackets to indicate you're creating an array. Then values, the name of it, and then on the right side type new to make basically the array live in memory. And then decimal. And then you type over here a 2 and close with a semicolon. So what is the purpose of this line? This line creates an array of length 2. Or in other words, it can store 2 entries. So an array is basically a block of memory, and you can store values inside that block of memory. A big thing with arrays is the concept of an index. So how does that matter? Take a look. Remember, this array is designed to store 2 entries, because the 2 is where it says new decimal, there's a 2. But the entries are stored not at index 1 and 2. The word index is simply a fancy word for address. That's it. So I actually add that as a comment. So index in this context is just the same as saying address. Okay? In our particular case, because the length of the array is 2, the addresses go from 0 to 1, or the indexes go from 0 to 1. 0, 1, and not 1, 2. So even though naturally we might be inclined to count 1, 2, 3, in C# you begin at 0, not at 1. So that means the following. Values, bracket, and then the index, which is 0. So this will store the first value at index number 0. And now you will say, for example, read it from the box. So we'll say over here decimal.parse, and then text box 1.text. In real life, you probably want to use try parse and make this code more sophisticated, because this could crash. If somebody here entered this, that's okay. But if somebody entered that, it would crash potentially. So try parse would be the better, more realistic way. And here we'll say the following now. Comment number 7 converts and saves value from box to array at index 0. Now we can repeat this for the second box. So values and then 1 equals, now you will say decimal.parse and then text box 2.text. Alright, and then add a comment here. The comment is the same as above, so converts and saves value from box to array at index 1. So now when you talk about this in spoken language, you have to be extremely careful. So this here is the first entry at index 0. This is the second entry at index number 1. So keep that in mind. That's how you would describe that in language. Okay, so how can you make use of it? Well, keep in mind this basic fact. It doesn't matter how fancy it looks. Ultimately, this right here simply represents whatever number has been typed into the first box. This represents whatever number has been typed into the second box. That is all that it means. That is all that it can possibly mean ultimately. It's a number. So we are going to say here decimal and then total. On the right side, we'll do a basic addition. So values at 0, and then plus values, and then index 1. So the action here is very simple. Add the two, and then store them to the total variable. Add the two values in the array, and store to total variable. That's it. I always misspell the word variable. I don't know why. Okay, so after this, of course, you can display it to the user. We'll say label1.text, and then $, double quotes. Now we will say total is, and then total :C. We are imagining money, for example, so we'll format as currency and close with a semicolon. So of course the action here is very simple. Display total value formatted as currency. Alright, let's run this and observe it happen. So let's enter a couple of values here, say that and some other value, and hit summarize. And it says the total is 110, correct? Exit, unload. Now, let's do one more thing here, which is this one. Imagine you want to display the average. So how can you do that? Using a natural feature of the array. The fact that our array is 2 units long, can store 2 entries, is something that we should be able to use. So we will say the following here. Label1.text plus equals to append the line we are about to create to the previous line. $, double quotes. And now we will say, for example, averages. And then within the curly braces, stick in a calculation, which is this one. Take the total and divide by the values.length. And now that is also money. Okay, so format as currency. And close with a semicolon. So let me describe that in a little more detail. So below there on line below, you have total divided by values.length. That's the same as if we were doing very simple math and we, for example, took 23 and we added 34 and then we divided by 2 to find the average of those two numbers. That's it. It's the same thing. All right, so line below does total divided by values.length because total is the result of adding the entries, and then further 12 values.length tells you how many entries there are. So this is just a simple arithmetic average, simplest kind of average you can possibly do. And now let's observe this in action. And I also format that as currency because it is still money, right? When you add $10 and $15, the average is another monetary amount. So here we are going to say the following. 56 and some other number, and hit summarize. And it says total is 511 and average is 255.50. And the only thing missing is the BR. So let's add that now. Put the BR right in front of the average, so that line goes to its own line in a web page. There you go. So summarize, enter some values. That's it. So now it's working as expected. And remember, behind the scenes, right-click, view page source. Remember, most of this is automatically generated. You don't have to worry about it. The stuff that we put in is rendered to this very simple HTML. So if you know anything about HTML, this should strike you as immediately familiar. There's nothing, plain HTML is what the browser ultimately receives in this context. All right, let me unload this. And that is it. In the next video, we'll talk about using loops with arrays. Hello friends, in this video I'm going to show you how to make loops and arrays work. So begin with a simple markup like this one here, and into it we're going to place a button and a label. So I have the toolbox open. Drop that in there, put a label in there, that's it. Put a BR after the button, and here remove the text, so it says for example just show or something along those lines. That's good. And then remove the text attribute of the label so it goes away. And now in design view, we have a very simple interface consisting of a button and a label. Left double click on the button. That brings up the event handler, and here we're going to create our code. So I will say string and then brackets. That means simply an array of strings named S. And then here we will say a list, an initializer. So you put curly braces and then the entries. So you will say H, comma, and then E, and then Y, and put those within double quotes and close with a semicolon. So this is simply an array of strings, and that's it. Each entry here is a string. That's a string, that's a string, and that's a string. Don't be thrown by the fact that those are individual characters. The fact that does matter is they're between double quotes. That means it's a string, not a character. C# does have a character data type. Then you would put, for example, G between single quotes. That's the character data type. The way it's stored in the system, in other words, is different. So double quotes, single quotes absolutely make a big difference. Keep that in mind. So here we are going to say the following. Comment number 5 simply makes array of strings. So now we can examine these values. We can do different things with them, but imagine all we want to do is just print them. So we will say, for example, for each, and then you will say string. The fact that I'm writing string there reflects the fact that this is a string, that's a string, and that's a string. And then you will say C. C is basically a variable that is scoped to the loop. It exists within the context of the loop only. When the loop operates, that's when C exists as a variable. And first, C, let's add a comment here. So comment 6. As loop runs, C stands for H, then E, and then the letter Y. Okay, that's the purpose of C. It represents each of those characters as the loop operates. So for each string C in, that's a keyword, and then a collection of items, the collection is S. That's it. Perhaps all you want to do is display them. So we will say label 1 that text, and then plus equals to append the current line to the previous lines as the loop operates. All right, dollar symbol for string interpolation, double quotes, BR to make sure the output is stacked in a column vertically, and then the value to be shown, so that goes within the curly braces, and then C. And remember, the black portion is replaced at runtime with an actual value like H, E, or Y. And it closes with a semicolon. Let's add a couple more comments. So comment 7, of course, the for each is needed, so each letter can be grabbed. And of course, this line down below simply prints each letter in a column. That's the idea here. Let's observe this in action. Hit it in with Google Chrome. All right, it's loaded, so hit the show button, and it says HEY, and that's it. Simple enough. All right, close it, unload it. In the next video, we will talk about creating simple methods. Hello friends, in this video we are going to learn about creating and running our own methods. Begin here with default.aspx, and let's show the toolbox of Control-Alt-X. And then let's put a label in here. So again, the label will be there simply as a place to hold some output. And above the label, let's also place a text box. So grab a text box, drag and drop that into the page. Alright, let's put a BR in here. So this is our simple user interface. Switch to design view. And now, double click on the box that generates the event handler. And here we're going to create our code. Right there above it, we're going to first create a method. Now, a method is simply a chunk of code. Usually, it has a very definite purpose that is expressed very clearly through the name of the method. So let's begin with some of the requirements. We'll say private, and the fact that this says private indicates that this method can be called only within the code that we see, and it cannot be accessed by code, for example, in other programs. Right, so private, and then you will say here static. The word static in this context means that we can call the method. When we do call it, we can simply type the name of the method. Alright, and then we will say double. Double is the return type. It tells us that when the method operates, it basically produces a double data type as the result of its operations. And then the name, so we'll say get increased value. So this here is the name of our method. So the name says get increased value. Now we know this method will produce some kind of increase in the value. There you go. If you want, you can make it more exact. You can say get, example, 110% of a value. That is what ours will do, and so on. So here we'll just say get increased value, and then you put parentheses. And then the next bit is a data type like double, and then X. Alright, so this is basically the header of our method. Then you define the body, open close curly braces. Double in this context right here is the data type of the parameter named X. The parameter is X. And you can imagine the parameter as basically a placeholder through which values are passed into the body of the method so we can operate on them. Okay, let's add these comments up here. I'm going to be very exact this time. So private means this method is reachable only within this class here. Alright, comment number 6 to be exact, we'll say static means we can call this method directly by just its name. 7. Next stage. Double, the first double is the data type of the value returned by a method like this one here. Alright, get increased value is the name of the method. Comment number 9, where it says double X is the data type and name of a parameter. Alright, and now further, parameters you can imagine as doing this. Parameters serve as placeholders through which values are passed into methods. That's the purpose of a parameter. Now we have to define the body of the method, the logic that defines the body of the method. So we'll say return, very easy here, X times 1.1, and that's it. That's what we mean by increased value. Now notice I'm using the return keyword. That means X, the value of X multiplied by 1.1 is returned to the calling code. So let's add a comment here. Comment 11 will be this one here. Sends the value of X times 1.1 back to the calling code. And by the calling code, I mean the place where the method is invoked or called. Alright, so go into where it says textbox1 underscore text changed. Now let's add a comment, so we'll say comment 12. Line below reads value from box and converts to numerical form, and then finally saves to variable. There you go. So that is actually all that is happening, all of those little things. So you'll say double value equals, and then there's a class called convert. Now, if you hover your mouse there over convert, it says converts a base data type to another base data type. So basically this is a nice class, a collection of functionality that we can use to convert between different data types. Alright, so in our particular case, I will say convert dot to and then double. And specifically, we'll take the input from the box, so textbox1.text. There you go. So here, remember this here will read from the text box. That value will be converted to a double and then saved over to the variable named value. So all of that will happen within that single line. Keep that in mind. Alright, so then assuming once we have this numerical value, we want to increase it, say, by 10% or multiply it by 1.1. So to do that, to accomplish that step, we say the following here, double. Why am I writing double here? Because here I have double, and I know that I'm going to use this method right here. Right? Because I'm using that method. That method right there has a return type of double. So in other words, this confirms that this one right here and this here, these two match. That's how I know. Alright, then I will say double, and I will say result equals, and now I will write the name of the method, so get increased value, and then it says double X, so then I will say the following here, value, and then close with a semicolon. So the big idea here is, of course, when you hover your mouse over to double, you observe that it's got a double data type that it produces, and that matches the double data type over here, you see? When you hover your mouse over get increased value, the way we've defined it, is that it produces a double data type. So over here I also have a double data type. The two sides are matched. If not, many times you might get an error. So here, get increased value is the name of our method, and value in this context is called the argument. So let's add a comment here. Value is called the argument because it's the value passed into the method. So the method can operate on it and produce a result of some kind. Okay, lastly, once we have this result back from our method, we can produce some kind of output. So we'll say label1.text, and then we'll say here that. Then we'll say value. Remember, at runtime, this will be replaced with the actual value of a variable. And then increased by 10% is, and then within a second set of curly braces, type result, and then close with a semicolon. So this line simply, of course, prints the value to the user, increased by 10%. So let's add the comment. So shows value to user increased by 10%. Okay, so here, keep in mind this basic fact. When I click in the text box, right, first step is to read the value. The second step is to basically call the method. That means processing will be switched to this point right here. Okay. After that operates, you go back over here, and the result is saved to this variable. Then that variable is used down below right there. Okay, that's the sequence of operations here. Google Chrome, here's our box, and if I enter a value like 56, it says 56 increased by 10% to 61.6, and so on. Of course, but if you enter a word like this, then you're going to have an error, right? So that's, you see, it generates a format exception. So that's something that we have to obviously learn to handle, but for now, just be aware that. Alright, and that is it for this video. I will see you in the next one. Friends, in this video, we're going to learn how to work with arrays and how to pass them into methods, how to operate on arrays, and then return some kind of useful quantity based on the array. So begin with this very simple interface. Here's our markup, and all I have in here already is a button, and then I have a label. So in design view, it looks like this. And I will just left double click on the button to generate the event handler so we can write some code. And when I do that, it generates this. Great. So here, right above it, we're going to create a method. And the purpose of the method will be to find the total of some values inside an array. So we'll say private, we've seen that before, static, we've seen that before, and double. We've seen that before. And then name it sum. And now, because we're going to accept an array so we can operate on it, type double as an example, and then put brackets, and then values. So our parameter is named values, and the data type essentially is an array of doubles. There we are. And we're going to find the sum of the values, open close curly braces. Let's add some comments though. Comment number 5, values is the array we're going to essentially pass in. So values is the array, that is the parameter, correct? And then within here we're going to find the sum. So to that type, double sum equals 0, close with a semicolon. Here it's very important that you begin with 0 rather than some other value. So imagine you want to add 1, 2, and 3. Well, really what you're doing is putting a 0 there. It is not how we write it on paper, but this is how the computers understand it. So begin from 0 right there. If you don't, if you, for example, have 4, but you're adding 1, 2, and 3, you'll have an error. That's not what you intended. So you want to begin with a 0. That is why it says double sum equals 0 as the initial value of the sum. There you go. So let's add a comment here. Begin sum with 0, so its value does not change the sum. Alright, now because we do have an array, the name of the array is values, naturally we use a loop of some kind. So we'll say for each double d in values. Now remember, double here is a data type, and we know that it should be that because our array stores doubles. That's the reason. D basically, as the loop operates, refers to each value individually, and the name of the array is values. Okay, so the purpose here is grabs each entry inside the array. Next stage, type sum plus equals D. So that line right there is at a comment. Why does this line matter? Why is it necessary? Sum plus equals D has the action of adding up the values as the loop operates. And you have to have plus equals. If you don't have plus equals, then you'll be overriding and things will not be saved properly. So plus equals helps to create a sum. There you go. At the end, of course, we return the value, so type return sum, and that's it. So here just a comment is returns sum at the end of the method. That's it. Now keep in mind, if our array, for example, has 10 values, then this here will run 10 times, like that, because the loop says there are 10 entries, right? So you run it 10 times. And the sum plus equals D is linked with the for each, right? They run together, essentially. Keep that in mind. Okay, so that is that. How do you make use of it? Go into button1_click, and we're going to make an array. Now, of course, in real life, this could come from, for example, a database, a web page entry box, and so on. But here, we'll do it this way to save time. Double, and then we will call our array vals. On the right side, we initialize it with a list. So we'll say 4, 5, 9, -10, and 2, and close with a semicolon. So this here simply creates an array of doubles. So we have something to add up. Something to add up. Okay, to make use of our method, we can do this. Type label1, dot, and then text, and then put an equals, $symbol for string interpolation, double quotes to make a string. And I will say sum of values is, and then you can just embed the method call directly into the string. So put curly braces, and then type sum, and then vals, close with a semicolon. So this line right here has a certain action. Let's take a look. Line below calls the sum method, and the result, which is a double. Remember, this here is the result, right? That tells you the data type of the result. That is what is returned by the method, the sum, which is a double data type. That is ultimately what is stuck into the string, so you can print it right there. So sum of values is, then you write the name of the method, you pass in the array, and that's it. So here's add a comment, or extend this one, and the result is then printed on the web page, and that's it. Let's observe this in action. So Google Chrome. So the page is loaded. Let's hit show sum, and it says sum of values is -10. Correct. Remember, in this simple sense, you should be able to check the code, make sure that it works as expected. So 4 and 5, of course, is 9, and 9 and 9 is 18. 18 and 2 is 20. 20 minus 10 is 10. You set them up on your calculator to confirm that it works as expected. There you go. And that is it for this one. I'll see you in the next video. Hello friends, in this video we're going to learn about reference type and value type variables. So, I got a simple project, and this time just put nothing but a label within the form as I have it here. Alright, so that's the label. Place it anywhere you like, it doesn't matter. Within design view, all we have is that. Now, what I want you to do is left double click, say, slightly to the right of the label, and that brings up the page load event handler. That's how you can generate that if it ever disappears for you. Just click somewhere over here, left double click, and it brings it up, generates it again. We are talking about reference type and value type variables. We have to understand what the difference is in behavior between the two. So to do that, we're going to create methods. We'll say private, and then static, and this time void. Now void simply means our method will perform an action, but it will not send a numerical value, like 10 for example, back to where it's called. Alright, so do something, but don't send a numerical value like 10 back. Just perform an action. And we'll say here change array as the name of the method. we'll pass in an array of integers and then ARR. And all our method will do to illustrate the concept, let me add a comment. We've seen obviously a lot of this before, but the only thing perhaps we haven't seen is void. So void means do not send a value, for example, like 10 back to the calling code. And in this case, remember, R is the parameter and the data type is an integer of arrays. That's what's going inside. Now here, type ARR and then 0 and set that equal, for example, to a new value like 10. So what is the purpose of this line? This line essentially will confirm the following. Let's add a comment. This line changes the value stored at index 0. This change, because of the way arrays behave, is visible in the calling code also. So in other words, when you're passing things by reference, for example, that means you're giving one thing multiple names, but all of those names basically allow you to change that one thing, which means as a result, if you change something through one name, that change becomes visible through other names. So imagine you might be named, for example, Tom, Adam, John, and you might respond to Tom or Adam or John. So you have multiple names, but they all point to you. Same principle holds here with arrays. When you deal with arrays, if a change is made through one name, that change is visible through other names. Now, let's also make another method here, which is this one. Private static, again, void change value, and then we'll say double x. Open close curly braces. And now type x equals 30. So here, we've seen most of this, but except perhaps that, so we'll say here, setting the value 30 to x will not change the argument where the method is called. So let's take a look at this in action. I know these things seem a little abstract at first, but you need some more code to illustrate these concepts. So you will say this, integer and then R1, like that. And set that equal to a very simple array, like for example 1, 2, and close with a semicolon. That's it. Now call change array and then type R1 and close with a semicolon. So here, let's take a look. Let's add a comment. Comment number 8 essentially is, so it creates a simple array. Now this here calls a method and passes in the array. And the question is, will the change that is made right here be visible in the code down below? That is what we want to check. So let's take a look here. We will say label 1 text, and then the value at index 0 is, and then stick it in. So you're going to say R1 and then the index value 0, close with a semicolon. Alright, so let's add a comment here. The question, in other words, is, does R1 show 1 or does it show 10? In other words, this one, the original one, does it show that, or will it show the 10 that is set right there? So let's take a look at the action here, Chrome, and it says the value at index 0 is 10. So what this confirms, as you just saw on the screen, it said the value is 10. What this confirms is when you deal with arrays, they are reference types, which means when the change is made right here to the array, that change is visible throughout the code. See that? So if you change it inside this method, that visible change is also right here. So imagine this is step 1, step 2, change the value, and then step 3, all the way back inside page load, confirms the value has been changed. That's one behavior. Now let's take a look at another kind of behavior, which is that of a simple data type. So we are going to say here just something much easier this time. Double Z equals 25. So comment 11 essentially is creates a variable. And now we're going to say change value and then put in the z, close with a semicolon. So this, in this context, z is the argument that is passed into the method named change value, like that. The question is, as before, will passing z over here into change value have any impact on a z, on the value of z? And let's take a look. How can we answer? You print its value after change value operates. So label 1 dot text equals, and then we will say the following here. And let's append this. There you go. It's the same label, right? So you've got to have plus equals to append. And now we will say the value of z is now, and put z within curly braces. Close with a semicolon. Now, because I've done this before, obviously, I'm predicting that the value of z will not be changed. But let's observe it. And it says the value of at index 0 is 10, the value of z is now 25. Okay, so that confirms we have to also add a BR over here. But we also saw that the value of z was not changed. So here the purpose is this. When change value z is called, it's passed into the body of change value as a copy. And it's passed as a copy. So in other words, from here, imagine this is step 1. When you call change value, what goes into the body of change value here through the x is basically a copy of z. So you can imagine that what this receives is a copy of the data of z, which means that the z itself, the original value, never changes. This is very different. So contrast this with doing the other thing, which is when I call change array 1, this is the first step, and that goes into this method right here. Essentially what is passed is a reference, which means at this second stage, if this changes the array, that is visible down below at this step right there. So with arrays, a change made in one place becomes visible in multiple places. With simple data types like doubles, what is passed into the body of a method is a copy of the data, which means the original is not changed. So very different behaviors in that sense. In the next video, we'll learn how to create more powerful methods using the params keyword. Welcome friends, in this video we're going to learn how to use the params keyword to create more powerful and flexible methods. So begin with a simple markup page like this one. Alright, open up the toolbox, so Control Alt X, and so we have something to click, put a button in here. Change the displayed text, so for example all it says is show product, and then also place a label here. So we have a place where output should go. There you go. Separate the two. It's not good when you're learning to keep things cramped, so that BR. I've tried doing this by placing the label right after the button, but it gets really confusing when you're learning. So even that little BR is helpful. Now, go back into design view and left double click show product. So it brings up the button 1 underscore click event handler, the code that runs when somebody clicks the button. And above it, we're going to create a method, and the name of the method is product, using the params keyword. So let's take a look at what I mean here. So we will say the following. The params keyword here allows us to pass a variable number of values into a method. So specifically, there's no reason why, for example, you shouldn't be able to do this. You should be able to say product, for example, 1, 2. Or if you want, you should be able to say product 1, 2, 4. Or product like this, 1, 2, some numbers, right? It doesn't matter. You should be able to pass a variable number of values into the method. The word product in English simply means what you get when you multiply numbers together. Okay? And if you want, you can even, here, that. So you should be able to multiply some numbers together. And the number of numbers you're multiplying should be flexible. It shouldn't be fixed that says you must multiply only 2. You should be able to multiply 50 if you want. So let's create this method. We will say private, we've seen before, static, we've seen before, and then here you will say double, which is the data type returned by the method we are about to create, and name it product. And now use this new keyword, params, like that. And then you make an array, double, and then you name the array. So this is our thing here that gives flexibility. Specifically the params keyword is what gives flexibility when we call the method. Alright, so let's define the body of the method. Open, close, curly braces. And now we'll say double product equals 1. So again, remember, if you want to multiply numbers together, you've got to begin with something. You cannot begin with a 10, because if you did, for example, 2 times 4 times 10, you would end up with not what you want. Right? Imagine you want to multiply 2 and 4. You want the value 8 to come out. The way to do that in C# is to first begin with a 1. So 1 times 2 is 2, 2 times 4 is 8. Okay, that's an example. Imagine you want to multiply 5 and 4 and 3. In C#, you begin with a 1 at the front. So then it keeps the product correct. You have 5 times 4, which is 20. 20 times 3 is 60. 60 times 1 is still 60. You cannot begin with some value, for example, like 5 over here, because that would not, or 2 or whatever, it wouldn't work. It would throw off the product. So you begin with a 1. You cannot begin with a 0, because if you put a 0 here, 0 times anything would still be 0. It wouldn't be useful. So you begin with that. Let me add a comment here. So the comment is begin with 1 as the first or as the initial value of product. Then, because we do have an array of doubles, use a for each loop. So type for each double D and R. So this simply means grab each value inside the array, of course. Grab each value inside the array, and then you accumulate or you build up the product. So to do that, you type the following here. Product star equals, and then you type D. So this line right here has the effect of building up the product. This line makes the product grow until the loop ends. So the way we are multiplying this essentially is this way. You begin with, for example, imagine the array has some values like 4, 5, and 6. So first you would do 1 times 4. Then you would take that value, this would give 4. Then you would do 4 times 5. That would give 20. Then you would do 20 times 6, and that would give you 120. See? You begin it in that sequence of steps. This is how it operates. It does it 1 times 4 first, then 4 times 5 is 20, then 20 times 6 is 120. It's doing it in that fashion from left to right. This also shows, remember, you've got to begin with 1. Okay, at the end, you return the product, so type return and then product. Close with a semicolon. There you go. So this simply sends the product back to the calling code. That's it. All right, let me separate these. And remember, this is treated as a unit essentially, which means that if the loop has 10 values, that there will run 10 times, and so on. All right, go into button under one underscore click, and now we'll say double x equals 5, y equals 10, and z equals 20 or 15, it doesn't matter. So we're just declaring and setting some variables here. And that's okay to do because they're all of the same data type, so you can just declare and set them on a single line. You don't have to keep typing double y, double z, and so on. So next comment here is declares and sets values of the same data type. At the next stage, we're going to make use of the product method. So type label1.text, and then you will say here equals $symbol for string interpolation, double quotes to make a string, and then you will say, for example, x times y. Now remember, if it's black, it's replaced with the value of x at runtime. If it's brown, it goes to the screen exactly as written. X times y equals, and then you will say within curly braces the name of the method, and then you pass in the values. So x comma y, close with a semicolon. So 12 essentially simply means call product with x and y as the arguments. So in this case, we're operating on 2 values. Let's observe this happen. All right, so hit Google Chrome. All right, so show product. And it says 5 times 10 is 50. Excellent. But now we want to be able to multiply, for example, 10 values, or however many we want. So 3. We'll say label1.text plus equals to append $symbol string interpolation double quotes to make a string. And now we will say x times y times and then z equals, and now within curly braces you place a call to product. So product and then x comma y comma z close with a semicolon. So this here simply calls product with x comma y and z as arguments. So now it takes 3 values being passed in. But the result is that it works nonetheless. And don't forget to put a BR so it goes down to the next line on the web page. And remember, if it's brown, whether it's equals or a star, that simply means appear on the page exactly as written in code. Let's observe, show product, and it says 5 times 10 is 50, 5 times 10 times 15 is 750. There you go. This is how you create a more flexible and powerful method. This is used, for example, with a method called split that operates on strings and so on in real life. It's very useful. In the next video, we'll learn about creating more powerful methods using the out keyword. Hello friends, in this video we're going to learn how to create more powerful methods using the out keyword. And by powerful I mean a method that essentially is more useful because not only can it return a value, but it can also set other values that become available in our code. So let's take a look. I'm beginning with a simple interface here. I have, into the form I've dragged here a button, and the text on the button says summarize, and also put a label here, and I removed the text attribute. So if I switch to design view, I have a button that says summarize and a label right under the button. Alright, so left double click on the summarize button, and that brings up the event handler. Now here, to make working with arrays a little more efficient than before, or a lot more efficient in fact, I've added a new thing that says using and then system.link. So make sure you add that to the top. This language integrated query has a collection of extremely powerful methods that, for example, make working with things like arrays and collections of various kinds much more efficient. Right above here, we're going to create a method called summarize. So type private static double and then summarize, and then type double. So this will take an array of values, and then out double average, open close curly braces. Let's add a comment here. So comment 6 out keyword indicates that average right there value will be set inside summarize, and it's also then available in other methods. So because it's an out kind of parameter, it's available in other methods. So let's add that comment also. Average is also available in other methods. Keep that in mind. Now our method does also return a value using the return keyword. That's what I mean by creating a more powerful method. One value is returned as usual using the return keyword, but other values like average are also still available after they are set inside summarize. So this method is, in other words, does 2 very useful things. Alright, now also keep in mind this method also still returns a value of type double to the calling code. So here double is right there, see that? So now to create the code, so we will say average equals, and now look very carefully, I'll say values dot, and then I'll say average. That's it. So average is a method, and as you can see, link is no longer faded. That means average has been called, and that confirms average is stored within link. Hover your mouse over it, and even though it says a lot of different things, but doesn't matter, as you see where it says double, an average also is of type double, correct? So the 2 data types are always matched, as always. That's obviously a big theme in C#, match data types. You might get errors of some kind. So here's that a comment number 9, uses average. More specifically, average is called an extension method, like that. But for our purposes, very useful thing, that's what matters. It uses average extension method, average of values inside array. That is then used to set the value of the average out parameter. Let's add a comment. Comment number 10. This average found is used to set the value of average out parameter. You can also now type the following here. So type a return and then values.sum, close with a semicolon. So this line, of course, simply sends the sum back to the calling code. This line sends the sum back to the calling code. Hover your mouse over sum, and it tells you after it operates, it produces a double data type. That's why over here I also have a double data type. The two data types are matched. Big theme. And as the next stage, we're going to say var. That's an implicit data typing, and that's fine. You'll say vals equals, on the right side you will create an array, so new double, and then you make a list of the values. So put curly braces and then make the initializer. So type, for example, 4, 5, 6, 7, 8. Put in some values, doesn't really matter what they are. Close with a semicolon. There you go. So here is at a comment number 12. Creates an array to operate on. In real life, this might be read, for example, from a database, all kinds of things, some table or a page and so on. And notice that I'm using the new keyword, and then double as the data type, and then I make square brackets, and then I make the list of the actual values stored inside the array. That's the initializer. On the left side, we're using the var keyword, and this is useful when you don't want to have to figure out what the data type is. You can type var, and C# will decide what var represents based on what it finds on the right side. So remember, C# is strongly typed. Hover your mouse over var and it says double with brackets. So var recognizes the fact that this is an array of double values. You don't have to do it though. Just put var and it does it automatically. Alright, at the next stage we're going to make use of our summarize method. So type the following here. We'll say label one.text equals, and then here you'll say sum of values. And now we will make use of our summarize method. So put curly braces. And you can place a call to summarize right within the curly braces. So summarize. And then type vals, which is of course the array you're passing in. And then you have to type out. And now we need one more thing. See, right now if you leave it in this form, you will get an error. Right? It says here, there's no argument given that corresponds to the required formal parameter average. So in other words, you see this? We're missing this bit, the average, the out parameter that is needed. So up here, to make that work, you gotta come up here and make a new variable. We'll say double average. And that's it. You don't even have to set its value. So let's add a comment. This will be used to call summarize. All right, and notice that its value is not set here. Okay, so set a comment here. Its value does not have to be set here. Value does not have to be set here. So now go back and after vals type out average. Close with a semicolon. And then also you want to display the average. How can we do that? Well, remember the benefit of the method is after it runs, not only does it return the sum of the values, but also makes average available, the value of the average available. So to do that, type label one.text, double quotes, dollar symbol, and I will say average is, or average of values is equals, and then within the curly braces type average and close with a semicolon. We could not do this before. This is obviously, a more powerful way of writing code. All right, let me go to the beginning here, and I will say line below. The line below calls summarize with value array and sets the average value also. This is the line that actually displays it right here. So let's add a comment. Line displays average. Right, crank up Google Chrome. Let's observe the effect. So keep in mind, until now we had no way of doing this, reproducing this kind of behavior. We would have had to, for example, create two methods or something. Hit summarize, and it says average of values is 1.25, correct. Okay, let's just add a BR over here. There you go. And also plus equals to append. And then you can relaunch it. You see, restart. Control Shift F5 if you like. Some people love key combinations, and if you learn enough of them, you can definitely become very efficient in Visual Studio. All right, has summarized, and it says, there you go, sum is 10, average of values is 1.25, correct? And remember, when you create your code, when you begin, you want to use small values that you can check easily, right? You should be able to enter these into a calculator, find the average, make sure that it's okay. For example, sum the values and make sure that whatever your code is producing corresponds also to some simple calculator-based results. All right, that is it for this one. I'll see you in the next video. Hello friends, in this video we're going to learn how to use the out and ref keywords. So begin over here with default.aspx. Into the page, drag a button, and on top of it write show summary, and then under it also place a label. So that we've done before, right? That's nothing new. This is basic markup here. It looks like this. This is the markup. All right, so go over to design view and left double click on the button, and it brings up the event handler. So now we work within the event handler. We're going to first create a method above it called get value and interest. So we'll say private, we've seen before, static, we've seen before, void, we've seen before, and then we'll say get value and interest. That's the name of our method. And then you're going to type out, so, and then decimal, and then interest, and then ref decimal value, like that, open, close, curly braces. Let's add a couple comments so we understand how this helps us. So first of all, comment number 5 will be, the interest is the result of a calculation done inside the method, because that is so, it's an out value, an out parameter. So it's an out parameter. It doesn't have to be set where the method is called. You can set the value inside get value and interest. You don't have to initialize it when you call the method. You do it within the method. Okay. Stage number 6 here, comment number 6 will be value is needed to calculate here the interest, like that. But it's set in button 1 underscore click. So value is different because value is ref. It's modified with the ref keyword over here. That means its value has to be set with basically before the method is called. And then it's passed into the method, and then it's changed, and then it becomes available again where it's called. Okay, so keep that in mind. The out one is a little different, remember. This does not have to be set where the method is called. It's set inside the method, and then that new value becomes available throughout our code. So different behavior to some extent. And I will just say here interest equals 0.05m times, say, the value. So this line simply calculates the interest, so finds interest and saves it to the interest out value. All right, and then the next thing is value equals value plus interest. So this line simply now updates the principal or the value. So this line updates how much money there is with the new interest added to it. So we've updated the interest, and then we've updated the value. Now those values become available down in button 1 underscore click. Let's check that out. So you're going to say decimal principal. This is the amount invested. Say it's $4,500. In real life, of course, this might come from a database. So you might read it, for example, from a web page or some kind of text box. But this is sufficient for our purposes to save some time. Okay, let's add a comment here. So comment number 9 is basically this. This is the money on which we want to find the interest. At the next stage, you're going to call the method. So, but even before we do that, also do decimal and then say here interest. So this is our out parameter, our out value comment. This is our out value. It does not have to be set here. Notice that it's set inside get value and interest inside the method, because that's where the interest is calculated. It doesn't have to be set here. All right, at the next stage, we're going to say the following here. Get value and interest, and then pass in the quantities of interest. So out interest, and then also the next thing is ref principal. So notice that principal, because it's going in with the ref keyword over here, has to be modified in the sense that its value is set. So when you use the ref keyword, the value has to be set. After that, ref and out pretty much behave the same way. At this level of explanation, that's sufficient. So remember, let's add a comment here. I'll renumber them in a second. So This goes in with ref keyword, so its value has to be set here. The next one where it says this is our out value, it does not have to be set here, not the out one. Alright, let me remember the comment. Alright, so you pass interest and principal, basically one by out and one by ref, into get value and interest. Their values are set and now they become available for us in button 1 underscore click, so you can display them. Label 1.text, alright, equals, and then display some message here. So dollar symbols for string interpolation. I'll say the following here. The final amount is, and remember, the final amount is the principal. So I'm going to type principal and close this to semicolon. Why does that work? Why can I type principal? Because the reason is this. When I typed ref principal, that went into the method, it got updated, and then that change that is made in the method becomes visible down below right here. See that? So principal actually represents the new updated value, not the old one. That's why this is the final amount. Alright, so this here is a common prints updated value. Obviously these things are somewhat subtle and you have to practice them a little more to understand them thoroughly, but first you've got to begin by becoming aware of their existence. Label 1, and then you'll say that text plus equals to append. Alright, dollar symbol, double quotes, and then we'll say this BR to push down to the next line, and then interest is, and then put in the interest, so interest. And format that as currency, so colon C. Same thing up here, principal, colon C to format as currency. Alright, and again, this here now prints interest to screen. Alright, let's observe all of this in action. So hit it Google Chrome, give it a second to load. Show summary, and it says final amount is 4725 and interest is 225. That is correct. There you go. So these are some of the basics of using the ref keyword and the out keyword. And remember, in some sense they are the same, but in an important sense they are not the same. With the out, the value doesn't have to be set right here. Interest doesn't have to be set. With the ref, essentially the value does have to be set right there. But in either case, what is true essentially is whether you use out or ref, down below right here, the principal is now the updated value, and interest is also the result of using our method up there, you see? There you go. So whatever changes essentially for our purposes are made within the body of the method, those changes become communicated or are communicated down to these lines also. There you go. So keep that in mind. That is it. I'll see you next video. Welcome friends. In this video we're going to talk about two-dimensional arrays. A two-dimensional array, in more familiar terms, is nothing but an Excel table like this. In Excel, for example, the address of that little cell is A1. The address of that cell is B1, you see? And then that would be A2, and that there would be B2. But in C#, as in other programming languages, things are a little different. That cell would have the address 0, 0, and that would have the address 0, 1. So the first number, let me enlarge the writing here. That's 0 right there. That represents the row number, okay, the row index. So row 1 means 0 index. That number represents the column. So in other words, the first column has an index of 0. Then you move over, so that there represents, as you can see, still the first row, which has an index of 0, not 1. And then the 1 represents the second column, which in Excel is called B. Alright, and then over here you would switch down to a new row, so that would be, for example, 1, 0, and then that would be 1, 1. So keep in mind, as with regular arrays, there's an offset of 1. In other words, you don't begin with an index of 1, you begin always with an index of 0 in C#. So those are the addresses of the cells, keep that in mind. Okay, now let's actually express this in C#. So in source view, all I have to keep things as efficient as possible is the following. I have a button, and then I have a label under the button. In design view, it looks like this, a button and a label. Alright, then left to double click and show calculations. That brings up the event handler. And remember, make sure that when you do that, over here you have onClick equals button1 underscore click right there. That's the connection between the markup and the C#. All right. So now type the following code. He will say double. That's a data type. Then use brackets, then you separate them with a comma. And then you type ARR. And then you type, for example, a new double, and to specify its size, you put, for example, 2 by 2. Close with a semicolon. So this is just like a table in Excel that has 2 rows and 2 columns. In that sense, it's nothing new. So here we're going to say basically declares and sets 2 by 2 array, which remember means the following. 2 times 2 is 4. So array has 4 cells, in other words. 4 cells to be filled, for example. Let's fill the cells next. So you'll say R, the name of the array, and then you specify the index. So for the first cell, remember it's 0, 0. That means the first row, the first column in C#, index 0 for the row, index 0 for the column. All right, set a value there to, for example, like 45. That doesn't really matter that much, obviously. Okay. Now, because this gets a little more complex, even the way you write the code makes a difference. So here it's helpful if you place the adjacent cell on the same row within your code. So I'll type R, and then I will type, again, row 0, column, like that, close with a semicolon. There you go. So here, basically, what we are doing is the following. Filling the first row, which has an index of 0. But the column indexes go from 0 to 1. That's what it means. All right? And notice if you leave it unassigned, you get an error. And specifically there it says only assignment, call, increment, decrement, and new object expressions can be used as a statement. So now you have a more clear definition of what a statement is, correctly formatted in C#. So here let's assign a value. That's an assignment, for example, 34. Okay. Now it's as if we were moving to the next row. We'll say R, and then the row index 1, remember, really means second row. And then you will put here, for example, column index 0 really means the first column. Set some value to there, it doesn't really matter. 23, semicolon, and let's fill the last cell. R, and then type here again, row with index 1, which really means second row, and then column with index 1, which really means the second column. And then fill that with some value, for example, 78. All right, so here let's add a comment, filling second row, which has index 1. Column indexes go from 0 to 1 again. So here, remember, when you look straight down, like that, you're changing the row index. When you look across, you're changing the column index. It is really just like a table in Excel. That's how you can relate it to familiar, something immediately familiar, hopefully. Okay, so what can you do with these? Well, a common thing might be, for example, how would you add up the values? So type the following. Type, for example, double sum equals 0. Like that. So begin with a sum value of 0, and that's something else. So begin with a value of 0, so the sum is not changed or is not incorrect. And then use a for each loop. Take a look. For each. And this is really nice. Even though this seems so complicated, if you want to add up the values, you can use a single for each loop. It's really nice. Okay, so for each, and then we'll say double D and R. So basically that means grab each entry and add them all together. That's what it means. So type sum plus equals D. All right, so here let's add some comments. There we go. So comment number 9 will be, this means grab each entry one at a time, essentially. And of course, this simply means add the entries together. That's it. At the end, you can print them, for example. So you can say something like label, sample label rather, that text, and then just print the sum. So $, double quotes to make a string, and then you will say sum is, within the curly braces, place the sum variable, close with a semicolon, that's it. Alright, so this of course simply prints the sum. So prints sum to web page. That means, remember, the sum of all the entries. A single loop handles all of them. It's a really nice feature. Okay, you may have learned previously about nesting loops. Well, believe it or not, you can do it this way too. Give it a second to come up and so there it is, his show calculations, and it says the sum is 180. Well, when you work with small values, of course, you should be able to confirm that they are correct. So if you take 45 and you add 23 and 34 and 78, you'll see the sum is 180. Okay. What else can we do? For example, we can find, format one of the things there. So we can say, for example, sample_label.text, and then plus equals to append this time. Alright, $ for string interpolation, double quotes to make a string. And now say, for example, the following. The value at index 0, 1 formatted as currency is, and then embedded, and type the following here. So we are looking at index 0, 1. So type R, and then 0, 1, and then colon, and then C to format that entry as currency. Why not? We can do that. It's our code. All right, set a comment. So here we'll say the following here. Line below prints entry at indexes or index 0, 1 formatted as currency. Let's take a look at that. So crank it up in Google Chrome. Give it a second to come up. Hit show calculations, and there it is. You see? $34 with the dollar symbol. So basically what you can do previously with simple numerical values and variables, you can also do now. I'll just put a BR here to move down to the next line, and that's it. And of course, if you want, you can combine individual entries using various kinds of math. You can add them, subtract, multiply, and divide as usual. And that is it for this one.
We're going to learn about the dynamic keyword and the var keyword. Alright, so you have a project. And let's get rid of the divs here. We're not going to keep that. We don't need that. Alright, and then here we're going to put two text boxes. So type TX, drag and drop that in there. Alright, put the BR to break down to the next line, highlight the code. Control C, and then Control V down below. So we've got two boxes. Alright. And first remember the IDs are changed automatically from 1 to 2 when you copy and paste. Right. Now, first let's take a look at the dynamic keyword. So go to the C# file. default.aspx.cs. Alright, right here. And let's also add a button. That would be helpful here. So type BUTT. Drag and drop that button in there. Put that right here, you see? There you go. Alright, put the BR after the button. Change the text on the button to say increase, like this. And now take a look at the results here. When I go to design, it looks like this. So now let's left double click on the button. Alright, get rid of the page load here. And now, you're going to type private, which you've seen before, accessible only here. Static means they're called directly to the name. Now you're going to type dynamic, like this. Right, private static dynamic, and then you're going to say increase as the name of the function, and then you're going to say dynamic x, and then you'll say return x multiplied by 1.1. Alright, here we will be restricting our attention to numerical values, but the dynamic keyword is powerful. It can accommodate pretty much any data type. Alright, so in our case, this is what we're going to do. We'll say dynamic like this, alright, and then we will say, for example, Z, and then you're going to say the following here: convert to double, and then text box 1, the text, and closes the semicolon. Now, hover your mouse over dynamic, and it says represents an object whose operations will be resolved at runtime, so not now, when the program runs. Alright, so take a look. Sample_label.text. Alright, let's display the results. $symbol for string interpolation. Double quotes, and now we will say Z increased by 10% is, and now we write Z times 1. Well, rather increase Z. like this. All right, and this will work perfectly finely. Okay, perfectly well. Now look very carefully. I'm going to type z equals, and now we'll type convert to, and not double again, but I'll choose int32. That's an integer type. Now we'll say text box 2 dot text. Now here, the dynamic, if you have your mouse over it, right? Remember, an object whose operations will be resolved at runtime when the program runs. All right. Same thing with the function. So here, z equals this. Now z will represent an integer. First z will represent a double data type, and then z will represent an integer. See? And the system with the dynamic keyword is smart enough to be able to switch from one type to another easily. Right? So, more flexible code essentially. And then you can call. Remember, we have one single method, a single function, right? We don't need a function with like doubles or integers and so on. Right, then we can call this. So take a look. Put the plus equals, and z increased by 10% is, and again, exactly the same code. The rest of it is the same. The only difference is in the first case z will be treated as a double, and in the second case as an integer, and both of them z can accommodate easily. See? You can switch the data type from one to another within your code pretty easily and elegantly. So here, don't forget the BR, like that. Let's give this a go on Edge so we can visualize the results thus far. Alright, let me enlarge the size of the boxes. Here I'll put a 10. Alright, the next box I'll put a 10 also. There you go, see? Now keep in mind, yes, it's true that they look the same to the eye, right? But the first box converts that to a double, the second one to an integer, so they're not quite the same internally. Keep that in mind, right? Like here I can put that. Correct? Here, you see it generates an error. I cannot do that, so keep in mind that difference there, right? There you go. And there are ways of handling, you can do that with try parse and so on to make it superior, and some other try catch and so on. We'll learn about those eventually. But keep in mind, so the big idea so far is a single variable can represent different data types equally well. Now, take a look at this one here. I'm going to type var like this. Title equals welcome like this, and close this with a semicolon. Hover your mouse over var and it says class system.string. Whereas with dynamic, it's not known until the runtime, see? So the var and the dynamic do not serve the same function. Now take a look. I'm going to say page the title equals the title that we have created. So set page title. And now what I will try to do is assign a new data type to the word title. Imagine I type title and I say something like, for example, here 25. You see where it says here, cannot implicitly convert type integer to string? That's it. That means with the var keyword, the type of data is already known right now. And that's it. You cannot change it. Right? So this line over here does not run. Let me comment it out and make a note here that this is not possible because title is already like this, recognized as a string. That's it. You cannot change the type. Whereas over here, right, z, the type of variable z is, can be changed, right? First, z is basically given a double, and then z is given an integer. Z is given an integer like this. All right, and z can be given a string, and it can be given a great number of different things. Right, I'm just doing this with numerical ones that are fairly easy to understand at first. All right. So now let's do this. Now the word var is very powerful because it basically means you have less to remember as a programmer, because the system is smart enough to recognize what the data type is, right? On the right side it looks at the string here, all right, and it's on the left side, if you have your mouse over var, it says the string. That's it, you see? Now take a look. It can also be used in many different expressions. You can, for example, type for each and then var c in page.title. See? Basically for each character in the title of the page. Let's do some action. We'll just make up some action. Same label.text plus equals to append to the previous results. Alright. And then here we will put the double, and then we'll say here following C. Let's put in the dollar symbol for string interpolation, and then C to string dot to upper. See? So you can do things like this. There you go. Alright? So the number of things that can be done is great. There you go. So in this case, I took each character, I converted it to a string because strings and characters are not the same. Right? And then you can convert it to uppercase also, you see? If you want, try this, try it this way, right? Try calling this. You see where it says C? Hover your mouse over C. You see where it says system.car? So in this case, the system is smart enough to recognize that C is a character. So when you try to call to upper on the character, right, it doesn't quite work. So to make that happen, you can type to string, and now this works like this. First you get the character, then you convert it to a string, then you convert it to uppercase. Then you can display the character. Alright? This is a way of doing it. So let's take a look at the results here. There you go. So then put some 1 and some 5. Increase. So there you go. 1 increased by 10% is this, 50 increased by 10% is 55. And then at the end, you see how this is like W-E-L-C-O-M-E, right? Lowercase and so on. Now the word welcome is spelled all uppercase. There you go. And the only thing that's needed is at the end put a BR, this phrase here, like that. So let's take a look again, make sure it's working as expected. And put in a 1, put in a 5 or something like that. Hit increase, there you go. Alright? So, the big idea here, don't forget, is with the dynamic keyword you can assign multiple data types to a single variable. With the var keyword you cannot do that. Once you assign a data type, it's recognized, and after that the data type cannot be changed. And the dynamic here can be used in many different ways, right? For example, to return type of data from a function, the parameter type. Same thing with the var. You see, you can declare something to be var. You can also use it in a for each loop and in similar contexts. Welcome friends, in this video we're going to talk about creating classes, and here we are going to imagine classes as templates for making objects. That's all. So I begin with this very simple markup, and if I switch over to design view, all we have is a button that says show balance, and then we have under it a label where the balance can actually be displayed. In source view it looks like this. So this is our markup. I've already made it so as to save time. So go into design view and then left to double click and show balance. And what we're going to do is create a class that represents bank accounts. Alright, so let's add a comment here. And I can delete this one essentially for our purposes. So let me delete this, and then we'll type class and then bank account. Like that. And now, class is a keyword, it's blue of course, and bank account is an identifier, it's a name you make up. So in other words, that means if I wanted to, I could put Bob. And there you go, and so on, right? Or video game character, like that. Whatever I need to represent. So that's what I put there. So in my case, bank account. Okay, so let's add a comment here. In the context of what we are creating, this line has the following purpose. Class functions as a template for creating bank accounts. That's all it is. Bank account objects. Okay, at the next stage you create, the actual structure with curly braces. And then you start defining the things that define a bank account. So for example, you might say private and then decimal and then balance. So what is the purpose here? Private means this variable is accessible only within the bank account class. So private means this variable is reachable only within the bank account class.
Okay, decimal is just the data type, so decimal is the data type, and then balance is the name of it. So we'll say the following here. Balance is the name of our variable, like this. Now, in the context of classes, this thing is not just called a variable, but it's also called an instance variable, like that. Or as some people call it, a field. And the purpose is to store information. Okay, so comment number 8. In other words, balance stores information about basically each bank account. So you have a value in your balance, another person has a different value, another person has a different value. It's a changing quantity, so we call it an instance variable. All right, now what is an instance? An instance is just, for example, one specific bank account. How do we actually make bank accounts? This is what you type. You type public and then bank account. And then you specify a parameter, just the same as with regular methods. So you'll say, for example, here decimal and then bal. And then within the body of it, you set the balance. So you type balance equals bal. So bank account right here, notice this is public, which means this code can be accessed outside the bank account class because it's public, and it specifically has the name constructor. So let's add a comment here, comment number 9. So this is the constructor which runs when a bank account is made. That's the code that executes. All right, and then within here, it's common to do this. You set the value of an instance variable within the body of the constructor. So type this line sets the value of instance variables, of our instance variable, of the balance instance variable, okay, whenever a new bank account is created. That's the purpose of it. So it's like going to a bank basically, right? When you open an account, you give them some initial amount of money, assume that's the case. This is exactly the same thing, the same logic. Okay, expressed obviously in code. Now, besides that, imagine if you go to a machine, for example, you need to be able to display your balance. We need a similar action or a mechanism here. So we create a method. So type public string, and then you will say get balance. So we're creating a method. A method in the context of a class like this, you can imagine it as an action that something can perform. Well, if you have a bank account, then the action it can perform is display your balance to you. So there you go. Or an action. Of course, you could do other things, right? Increase your balance, decrease your balance, depending on what you're doing. But for our purposes, a basic thing is display the balance. So we'll say public string get balance, and then close. All right, within here, because this thing is a string, it represents a string when it runs. Because this returns a string when it runs, we have to add code that does that. So we'll say return. All right, $symbol for double, and then double quotes to make a string. Now you'll say balance, colon, and then stick the balance instance variable, and then put a :C to format as currency. Close with a semicolon. All right, precision of language matters very much so. So here, notice that the balance instance variable, when I highlight it, it gets highlighted in several places. All the occurrences of it are highlighted. And then the C, of course, over here formats this result, the output here. Comment 11 will say the following here. This method is public and simply gets the balance formatted as a string. So not just a number, but it gets this whole string right here. See that? And remember, in this context, the $symbol, as before, is used for string interpolation. It has nothing to do with money. The C is what is responsible for showing the balance formatted as currency. Two different functions. I set a comment here, so simply shows balance formatted as currency. That's it. So to break down what we have created thus far, we have basically a template. The template is the class, is this entire big thing. See? All right, it's got a private instance variable, that's this bit right here, and this stores information about each bank account. It's also got a constructor, which runs when a bank account is actually created. And now we have a method called getBalance, which essentially is an action that a bank account can perform, like that. So template for creating bank accounts. That's what we are creating. Now to actually make a bank account object, type this. Within button1 score click, okay, underscore click, type bank account BK or BA, doesn't matter, equals a new bank account. So this is going to create a bank account in memory so that it actually exists. Now keep in mind, because of where I'm placing this, it will be created, right, every time you click button1 underscore click, right, the whole process will go every time. And now it says decimal bal, so you specify the balance, say 4,500, and then close the semicolon. So this line right here, comment number 13, creates a new bank account. That's all it's doing. So on the left side, we have our data type called bank account. Then the name of a variable like BA, then equals, which is the assignment operator. On the right side is where we actually make the object live in memory so that it exists with the new keyword, so new bank account. And notice that new is blue, it's a keyword. And then you pass in an argument like 45, and that is used to set the value of the instance variable for each bank account. And after that, we'll say label1.text and set it equal to the following. Type BA, which is the name of our object, of our bank account, dot, like that, and that brings up a list of methods that can be executed on the bank account object, so the actions that it can perform. One of those actions, of course, is getBalance, close with a semicolon. Now remember, this is okay because if you hover your mouse over getBalance, we designed it so that it gives back a string. And remember, this here is also a string that it can hold, so the data types are matched as usual. When you see bank account.getBalance, what that means is the following. This is your bank account, and within there is a method called getBalance right here. So that is what that means. When you hover your mouse over it, you see the dot notation. So string is what is produced. Bank account is the class that we have created. The dot between bank account and getBalance is member access. And the member to be accessed, the member is a thing like a method. So in our case, the member is called getBalance. Right, so return type, data type, name of class, period, and then getBalance. I set a comment 14 that runs getBalance method on the bank account object. That's it. I've given a huge number of comments here to try to be as thorough as possible. Hit Google Chrome. There it's loaded, so hit show balance, and it says balance is 4,500 with a dollar symbol. So everything's working as expected. Regardless of how sophisticated this looks, if you right click and view page source, remember all of this is auto-generated. Don't even worry about it, but really the thing that, right here, see that? Balance 4,500. That there is returned by our method. It comes from calling our methods specifically right here. See that? That there is what goes basically into the web page, the balance. There you go. So again, remember, when it comes to fields and storing information, you make the fields in general private so that they cannot be altered willy-nilly by code that could be unfriendly. Methods like this usually are public, so they can be accessed. Otherwise, I would not be able to, for example, get the balance. Imagine I type private. Now it says that method is inaccessible due to its protection level. It's not useful anymore. Now you cannot get the balance. For our simple purposes, you make them public. Now imagine you have this constructor, and again, imagine you make that private. And now it says here, is inaccessible due to its protection level. Now you cannot actually make a new bank account. You make that public also, so you can make a new bank account. But if you change the field here to public, that would be a problem, right? Because now, take a look. Down below, you could type BA dot, and notice that the balance field shows up in IntelliSense, that list of features you can use. And now you can set it to a new value that you want. In other words, code from other applications would come along and change the balance. That would obviously be a severe problem for people. So that's not the way to do it. Keep fields, as a general rule, private and secure, and then access them securely in controlled fashion with a method like this one. In this video, we're going to learn about creating and using static classes. So crank up a project, and into the form element, we're going to place a couple visual things. So first of all, you can put a text box. We will create a class that basically collects some methods that perform definite operations like reversing the sequence of characters in a string, and so on. So here's a text box. This is for user input on the page. Alright, at the next stage we'll add a button so that the user can click, for example, reverse. So here, put a button. Drag and drop that inside. Alright, after the button, let's also add a label so we can show the string reversed. Put a label. There it goes. Alright, there's a label. Let me close the toolbox here. And that's a simple interface. Switch over to design view, and it looks like this. Box, button, label. So what we can do now is remove this and, for example, make it say reverse, like that. That is all that we are going to do. And get rid of the text attribute on the label also. That is it. You have the box, the button that says reverse, and the label that looks like that. Switch over to design view now. And left double click on the reverse button. And above it, we're going to create a new kind of class. So here's the language. We'll say static class and then string util, short for utilities. Okay, let's add a comment here. So comment number 4. This class that I'm making here, class represents a collection of operations or methods only. Because that is so, it's a static class. In other words, to say it in other words, you would not make a string util object. Remember in the previous lesson, we created an object using the new keyword. String utilities is basically a collection of operations or methods. You would not make an object of type string utility. What would that be? That's difficult to imagine. If you have, for example, a person class, you can imagine writing new person. You can describe a new person very easily. Hair color speaks some language, height, and so on. So this here functions only as a container for collecting methods that operate on strings. That's all it's doing. There are no fields, in other words. No fields like, for example, you might have for a person, like ID, or name, or social security number, and so on. There are no fields, no information, just operations. Okay, so class represents a collection of operations or methods only. Within the curly braces, we're going to create one method. So type public, and then static, and then string, and reverse. So the name of our method is reverse. It produces a string when it operates. It's static, which means we'll be able to call it by writing the name of the class and then the name of the method. We'll see that momentarily. And public, of course, means it's accessible in code outside the class. Alright, so then you're going to say string s. So let's add a comment here so you understand what we've created here. So again, public means reachable anywhere. Public means reachable anywhere, essentially. Okay, comment 6, essentially. Static means we can call the method by writing the following. String util, which is the name of the class, dot, and then the name of the method to be called, like reverse. That's what it means in this context. Okay, 7, simply string here is what we are going to produce, and the name of the method and method name is reverse. String s is the data type and name of the parameter. 8, so string s is the data type and the name of parameter. Alright, so below here, within the curly braces, we're going to write our code that reverses a string. Now we can do this in various ways, but a way is to type var, which remember is a handy way of replacing, for example, decimal, double, integer array, and so on. Just type var instead. I'll call it cars, short for characters. And I'm going to take the string that we pass in, which is called s, dot, and among many different things that you can do to it, you can convert it to an array. So you can say to-car array, and close with a semicolon. So here when you hover your mouse over this thing, it says copies the characters of this instance to a Unicode character array. So basically, it takes our string and converts it to an array of characters. So let's add a comment here so we understand the purpose. So it converts string to array of characters like that and saves 2 cars. So now when you have your mouse over var, you see where it says car and then 2 brackets, one opening, one closing. So that indicates we have created an array that holds the individual characters of the string we have passed in. At the next stage, we will reverse the array. So type array, come up here and add back using system. And now array, as you can see, is back. So that confirms that it's stored within system also. Dot, and then type reverse, and then the array you want to reverse. So in our case, it's called cars. Close with a semicolon. So what does this do here? This has the action of reversing the array. So in other words, if we begin, for example, with an array that looks like this, say 1, 2, 3, then after reversing, it's 3, 2, 1. So you're switching the order of things. Okay, and the last bit then, once you have the letters reversed, send them back as a new string. To accomplish that, type return, and then a new, and then string, and then type cars. So this has this following action here. This creates a new string from the reversed array and sends it back to the calling code. That's what it's doing for us. To make use of all of this, and again, I've tried to be as detailed with the comments as possible. Let me change that. There we go. Down below here, we'll type very easily and quickly label1.text equals, and we have to read the value from the box and then hit it with the reverse method and then display it back to the user. So to accomplish this in one fell swoop, we'll say string util, or remember this is string utilities, the reverse textbox1.text. That's it. So here let's add some comments nonetheless. 12 is basically, so textbox1.text, remember, reads the value from the box, is value from box. And then next comment essentially is the value is passed into a reverse method, which after reversing it produces a string. So comment number 14, after reverse runs, it produces a string back to the user. So let's run this. Google Chrome, enter a couple words like hello, and reverse. Now it says ole. If you enter 1, 2, 3, and you hit reverse, now it says 3, 2, 1, and so on. So it's working as expected. Now remember, even if you input 1, 2, 3, it looks like numbers to you, but it's not. Behind the scenes, this is treated as a string. It's stored internally as a string. There you go. So these are the basics here of making, remember, a static class is used to basically collect methods that have very definite definitions, that do definite things, but you would not think of making a new string utility object. It wouldn't be sensible to do so. You're just collecting functionality, operations together. This is also used commonly, for example, with the math class and other classes like that. Welcome friends, in this video we're going to talk about properties. So begin with a very simple markup page like this one. All we have here is a text box, and then we have a label after the text box. It's a very simple interface. We will collect a value, which will be the radius of a circle, and then we'll display some relevant information about the circle. So really easy stuff. Okay, go over to design view, and this is what I have. So again, a box and a label. And now what we will do is left double click on the box to bring up the event handling code. Do that next. And that looks like this. So the first thing to do is create a class. We will say the following here. Class circle open close curly braces. So remember, the purpose here is to model circles. That's the objective. Set a comment. So this class functions as a template for making circle objects. There you go. At the next stage, we're going to add an instance variable or a field. So we'll say private, like that, and then double radius. Close with a semicolon. So this here is a field or an instance variable. So this is the instance variable that defines each circle object. The radius is simply the distance from the center of the circle to a point on the circle. So from the center to a point on a circumference. Okay, so at the next stage we're going to say the following here. Public double and then radius. So this means something else here. And that is the following here. Let me add a comment. Comment 6. Radius, that is the one with the big R, is the property that represents the radius of a circle. A property is basically a mechanism for reading the value of a field, of a backing field, or setting its value in an intelligent way. So what I mean by that? Here we can say, for example, get, and just read the value. So you will say little r, radius, like that, you see? So return radius. So here, this is used to retrieve the value of the radius. This line retrieves the value of a circle radius. Now, why a property is different? Because they can be intelligent. There's a portion called set. And by intelligent, I mean you can create code that controls access to the backing field. In the context of what we are creating here, radius with the little r, right here is the backing field for the property. So big R means property in our case. That little r is the backing field. The little radius is the backing field. So here at the next stage, we're going to say the following here. If, and now you will say this, value, for example, is greater than or equal to 0, then set the radius. Value exists because of the way properties have been defined in C#. It's a keyword, it's blue. It just exists. It's available already. It's not something we introduce. Okay, so you will say value is greater than or equal to 0. So this here does the following. Checks whether the value we're attempting to set is more than or equal to 0, which is reasonable for a radius. A radius goes from the center to a point on the circle. It can be 0, which is really a point itself, or something more than 0, which means then you have a circle. So if the value there is greater than or equal to 0, then we can say the following. The radius equals the value. That's it. So this runs if the value being set is okay, in other words, as we have defined it in terms of being greater than or equal to 0. On the other hand, you type else. If somebody attempts, for example, to input -10, that is not an acceptable value for a radius. Radii are 0 basically, which really means you have a point in that case. Some people call that a degenerate circle, or they're more than 0, like 5, 10, 15, not -10. So here we will say the following here, radius equals 0, that's it. Is that a comment? The radius field gets the value 0 when a user attempts, for example, to assign a value like, a value like, say, -5. That is not a reasonable quantity for something that can be measured with a ruler. -5 does not work. Okay, let me decrease the size of the writing a little bit so it fits a little better. Now, the next stage, what we do is make use of this class. So go down into here, textbox1 underscore text changed. And now we will say the following here, circle equals a new circle object. So we create a new circle object. Now remember, because this is going into textbox1 underscore text changed, every time you basically press enter, this will run again and again and again. Okay, keep that in mind. But that's okay for us. It doesn't really matter very much. We're just illustrating some basic concepts. So here we will say the following here, 11, and then it will say makes a new circle object. And then what we will do is the following. We'll set something. So to set the radius, you type the name of the object, dot, and then notice that a little wrench shows together with the word radius, and it says get and set in a tooltip. So this indicates we're working with a property. And then set that equals follows, double.parse, and then textbox1.text. Now in real life you would use try-parse. The problems with text boxes, somebody could input, for example, hello, which cannot be obviously converted to numerical form. So in real life you would add try-parse and make the code more sophisticated, more powerful, as a way of obviously writing a more professional application. Okay, so here this is sufficient for our purposes. We'll say parses the value from the box and saves to radius property. Notice that on the left side I have the name of an object, then I have a period, which again is member access, and then radius, which is the name of our property. And notice that when I highlight it down below, if you look very carefully, if I highlight it down below, and if you look all the way up, it's also highlighted there to indicate that you're talking about the same thing. At the next stage here, we'll say the following: label1.text, and then we'll say this dollar symbol for string interpolation. Then we'll say circumference is, and then within the curly braces, we put the circumference of the circle, which is obtained as follows. You type 2 times math.pi. Math is a class, and it's got a constant within it called pi, a value that never changes called pi. It's about 3.14, and then you multiply that by the radius. So to read the value of the property for our circle object, you type the name of the object, dot, and then the name of the property again, you see? And close this with a semicolon. So here let's add a meaningful comment so that you understand why things are as they are. I'll change the numbers in a second. So line below uses circ.radius, which means that the following holds, which means that the set portion of the property is cold. So up here, remember we had set. You see that? That was the block that is cold when you set the value. On the other hand, let me move that down a line. We'll say this. That's comment number 13. At this stage, the get portion is cold. So in this case, we'll say this. Because circ.radius is used and not set, it's not being set, it's already been set. You are just making use of an existing value. The get portion of the radius property is cold. That's why you need the get and the set. You need both. This is the get block, so to speak, the getter, and then this is the setter, as some people will call it, right here. You need both, and each one serves a definite purpose that is different. Okay, let's observe this in action now. Chrome. So here's the page loaded, and the first thing I will do is input, for example, 50 or just 5 and hit enter, and it says circumferences as given. That's it. And that's okay, that's not a problem. If you try to input -5 and it says circumference is 0, that is correct. You cannot have a negative value as the values of a radius. It's not physically possible. But if you input a word like hello, then give it a second, you see an app crashes. And this is as it must be. You can correct it, of course, by implementing try parse instead, as an example. So please remember the code is available. If you click under resources, I put a link there, and then you can just copy and paste this because it's a lot. Although I would suggest, again, if you've gotten to this point in the course, it's extremely important to type all the code just as I do, line by line. It really does make a big difference.
In this video, we're going to learn about static fields and then static properties that can be used to access those fields. And we will learn also what happens when we shut down IIS Express. Okay? So let's take a look. Now remember, IIS Express is Internet Information Services Express. It's the one that comes by default with the Visual Studio. It's the web server. Alright? So here, crank up a project. All we are going to do is put a box in here. I will say your truck name like this. We'll make trucks. Alright, so put a text box in there. Like this, that's it. Alright. And now, below this we will place a button. So, put a button in there. And when somebody clicks, the button will count the number of trucks that have been made. That's what we're going to do. So change the text here on the button to something more meaningful like count, like this. Alright? You can get rid of this here. We don't need that. Delete that. There we go. Now, do add the BRs there to stack the content here vertically. Like that. So design view, box, truck name, count, and that's it. Simple user interface. Now, at the next stage, we are going to do is this. right click, go to add, and then class. Call this class truck, and then click OK. Click yes. We are going to learn about the static concept. So, you see where it says public class truck? You're going to type the following. We'll say private string and then say make, so the make of the truck, like whether it's a Honda, a Ford, or a Dodge. Okay, so private string make and then private int, and make it this way, static int count, like this. So now when you make the trucks, I want you to make an observation. When you make the trucks, we will make two things happen. We'll set the name of the truck and then increase the count of the trucks. So we'll say here is string name, and now you will say here make equals name, and then you're going to type count plus plus. That means every time a new truck is made, the count is increased. That is what the plus plus means. Alright? Now we want access to the count variable here like this, which is static, so it acts at the class level. So we want secure access to it. Notice that right now it's private. That means it's accessible only here and not anywhere else. So to make it securely accessible, let's make a public static integer truck count property. See? Open close, and now you're going to say here get, open close, and you will say return like this, and then count. There you go. Notice that now because this count field is static, the property that goes with it is also static, and it acts at the class level, which means you can write name of class, period, name of static property, right? Which is backed by this static integer count, like this. Alright, that's it for the class. So right click here, organize usings, remove the unnecessary ones. Let's say we don't need them, see? Okay, so this is the heart of our application, nothing else, that's it. Alright, now in default today is PX. Right, go to design view, and then double click on count. That brings up the event handler for the count button. And now to make this happen, and make it do something, we will do this. We will say this. We'll say truck, like this. TR equals a new truck. And then you get the name of the truck from the box. Textbox1.text. So this is initializing the constructor here using the value in the text box. Alright. And now you're going to do sampleable.text. And to make use of that static property, you can put a dollar symbol, double quotes, and now you will say, for example, there are. And then you're going to type the name of the class, truck dot, and notice that truck count shows up as a static property. See? And then truck. And sometimes people put like an S within parentheses to indicate that the first one would be singular, but after that it would be plural, right? You either have one truck or multiple trucks. See that? Alright. Now to make use of this, take a look. You're going to go to Edge, launch Edge. There you go. Let me enlarge the view here so you can see everything clearly. Alright, so first if I enter, we're not going to display the name of anything. Okay? Let's hit count. You see there are one truck. Alright, so just keep hitting count. You see this now 2, 3, 4, 5, 6. You see that? So that's coming from a static property. It's keeping track of the total number of trucks, right? So it's smart enough to realize that 17 truck objects have been made, and that static property keeps track of those objects, you see? There you go. Now here, take a look. If you do this, right? If you just come here and you unload this from memory with the brown button, right? Notice that over here in Windows, that icon there, IS Express, is still there. See that? So if I launch this again, right, I've launched the application, I enter some, Honda, and I hit count. Notice that it's keeping track of them between page loads. You see that? Alright? So be aware of that. So to clear that, so that is back down to 1. This is what you do. You unload this, and then see where it says that icon there? Click it, and you see where it says stop the site, or you can just exit it completely. Alright, once you exit this, the Internet Information Services stuff is shut down, and when you launch this, and you go through this process again, right, so enter some Honda and hit count, so now it's back down to 1. See? Like that. Alright, so keep that in mind. That's how you can clear that so that you start back down from 1 if that's what your objective. Alright, so these are the basics. So remember what we have made here. Okay, we have a truck class, but then we have a private string make, so make of truck, for example. Then we have a class level field. Alright, that means you call it directly through the class name. So class level field. In this case, it keeps track of the total number of instances of a class, right? The total number of trucks that have been made. All right. So this means here set instance field. This means increment class count, instance count, in number of trucks that have been made. This is a static property. So purpose is control access to static field with static property, like this. All right, and then here, of course, you're gonna make a new truck like this, and then use static property below with truck, which is the name of the class, dot, which is member access, and then truck count. So the basic logic is name of class, dot, and then name of static property. You can also do this with fields, but fields are usually protected. So fields are private, properties are used to control access to the fields. And these are the basics of these concepts. In this video, we're going to learn about the basics of inheritance. We're focusing solely on the concept of is A as a relationship between a parent class and a child class, and then also but the concept of centralizing code so it does not have to be written multiple times. Alright, so here we can up a project, and this is the basic HTML. So the first thing that we're going to do is add files. Go to the Solution Explorer, right click the name of the website, go to add, and then class, and then here we'll call this vehicles like this. Alright, and then click OK. When this comes up, click yes. So we have a basic class called vehicles, all right? And every vehicle virtually has two things, a make, which is whether it's a Honda or a Ford, and a model, for example, Accord and so on, okay? So Honda Accord, make, model. So here we're going to say here the following. Private, like this, string make, and then also private string model, like this. So these are two instance variables, and I'm placing this inside the vehicles class. All right, let's make the constructor here. So now you're going to say here's string mk and string mod. So this is a parameterized constructor. We have to set the instance variables inside it. So type make equals mk and model equals mod. So here, to review again, these are two instance variables like this, right? And inside the constructor, you set the instance variables. So set instance variables inside constructor like this. All right, next stage. Next, what we are going to do is write a function. So now you're going to say public string and then get make. This is going to get the make of a vehicle. And now you'll say here return make. That's it. All right, so this is a function. It's public, accessible anywhere. So make function to get vehicle like this, make. Okay. All right, so that's our basic code. Now, this is a vehicle class. What we are going to do is this. Let's clean this up. So click here, remove unnecessary usings. And now we're going to make a class called truck. So you'll say class truck colon. And because a truck is a kind of vehicle, it possesses the essential features of a vehicle like wheels and is drivable, and stoppable, and so on. Let's say that class truck here inherits. Here in this context, that symbol within the blue box means inherits. All right? So truck inherits from vehicle, like this. Okay, so truck is a kind of vehicle. So now within the body here, let's also make it here public class truck. Make it inherit from vehicles like this. All right? So here, notice that it says here, we have to now make a constructor. So to that, you're going to say public truck, and then you're going to say here string mk and then string mod. Now, the big idea is centralization, because a class truck here, a truck is a kind of vehicle. These fields right here that are defined up here, also accessible down below, we can make use of them. So you're going to put a colon, you're going to call, say, base, and then you can say mk and then period mod. So what this will have the effect of doing is calling the base class constructor. In other words, truck is a kind of vehicle. So when I make a truck, I don't have to write this line right here. See this? I can make use of it as it's defined inside vehicle. Right? So I'm reusing this block right here. I'm reusing this block of code. Okay? It's written one time and I don't have to create it again. Right? That's the benefit of inheritance. A benefit of inheritance. All right. So at the next stage, let me enlarge the code. We also want to make use of this get make like this. So a way of doing it, not the way, but a way. You can say type, for example, public string get truck make. And again, we don't have to recreate the code. We'll just say base dot get make like this. So again, we're calling the base class make function like this, get make function, okay? If you want, and here we will say return like this. There you go. Right, if you want, you see where it says simplify, so click the light bulb. See, that's it. You don't even need the base. You can just call it directly without it, get make. See that? All right, so remember again, now we are reusing this get make function here. So we don't have to code it separately inside class truck. Now to emphasize these points, let's add one more class called sedan, like this. So Control C and then Control V down below. All right, public class. And notice that, of course, this is instructive too, because it says the namespace, global namespace. That means this file here basically already contains a definition for truck. So you're going to have multiple ones, no multiple classes with the same name. That's what it says. So we'll call our sedan. And again, public class sedan. This means inherits, and it's a vehicle, so from the vehicles class. All right. Next, public sedan here. Like this. I probably should have called this class vehicle, not vehicles, but that's okay, it doesn't matter. And notice that after I changed this here, sedan, that's it. The rest of it is exactly the same, except get sedan make. That's it. The rest of it is exactly the same code. You see? That's it. So here to review, remember the big idea. We have a class called vehicles, two instance variables, make and model, a constructor, and a function. Okay, this specifically is what we call an accessor function because it accesses, it reads the value of the make. All right, then we have a class truck, which makes use of the base class constructor and it makes use of the base class make function, get make function. Then we have a class called sedan, which makes use of the base class constructor, and we have a get sedan make, which makes use of the get make in the base class vehicles. Okay. So please understand why we have designed this structure here. Vehicles is a class. We've got a lot of stuff here, two instance variables, a constructor, and a function. And those features can be reused in the child classes. All right, they don't have to be recoded. So now if you go to Solution Explorer, right, and if you right-click Vehicles and View Class Diagram, this is kind of instructive here. Here we can visualize the relationship. You see, vehicles is at the top, and then sedan inherits from it, so it looks like this, and then truck inherits from it, so it looks like this. You see? So these are little inheritance lines. Whatever is defined up here, take a look. Make, you see, model, and so on, right? There you go. And that's what's inside those. And these things here, as you can see, can also be called through the base class using the base keyword. All right, because the code is centralized inside vehicles. All right, so with that in place, to make use of this structure, we're going to go to default.aspx. And what we're going to do is this. First, you're going to put a text box. All right, so you're going to put a box in here. You're going to say enter sedan make and model. Trying to show as many useful things as possible. So here now, you're going to put a text box like this, and then put a BR at the end. See? Now I repeat this for the truck. So enter truck make and model, and then repeat this for that one. That's it. Put the BR in there to break down to the next line. All right, now you're going to put a button in here. Okay. And now the function of the button would be to get only the make. So you're going to type get, basically get make, like this. Okay. And here we'll input stuff into the box with commas, separating the inputs. So make and model inside one box. For the sedan, make and model inside one box for the truck. All right, so let's go to design view. This is the basic interface. Yeah, let's get rid of the centering here. Don't need it that much. Doesn't matter for us. All right, go to design view now. And if you left double click on get make, also add the BR here. See, there's always a little thing that has to be done, right? So this is the basic code of the user interface. And design view, here's the output. All right, so left double click get make. And now, we don't need the page load here. Take a look. This is where we will make use of everything. So the first thing to be done is this. I'm going to make a string, an array of strings, like this. String, like this. All right, and this will be here sedan. Let me make sure we keep this consistent. So the first and source view, this here is sedan, right? So the first box goes with the sedan. All right. If you wanted to, of course, you can rename this. You can say here sedan box. It's more meaningful, and then say here we'll say truck box. There you go. All right. So sedan, and then we'll say make model equals, and now to get that, you're going to do this. You're going to type sedan box dot text dot split, and then you're going to split this. So you're going to type new car, and then you're going to put curly braces, and then within single quotes put a comma. This will have the effect of splitting the input in the box into separate words, because we're going to put the make and the model inside one box with a comma separating them. So this will split into a string array. All right, let's repeat this. So we can also do this for, of course, string like this, and then truck make model equals, and now you repeat this. So truck box dot text dot split, and then new car, and then specify the list of the items used for splitting. That means single quote, comma in our case, and close with a semicolon. That's it. All right. So this is splitted, and now you can make use of it. So to make use of it means the following. And display it, for example, to the user. So you can say you have to make the objects and display them, right? So you're going to say now truck like this, tr equals a new truck. And we want to initialize the make and the model. So we're going to say sedan make model at index 0, and then, I'm sorry, this should be the truck. You see that? There's a lot here. There you go. Truck make model index 0, and then truck make model at index 1, and close this with a semicolon. See? That's it. So it's going to initialize the truck. And then you repeat this for the sedan. So basically it's the same code, right? Just change where it's appropriate to, make sure it says sedan here. Now you're going to make a new sedan like this, and you're going to say here sedan make model at index 0, and then sedan make model at index 1. So again, this will get the make and the model for each vehicle. All right, and let's rename this also from TR to SD or SCD, something like that. All right, and now to display them, you can type sample label.text, and again, double dollar symbol, double quotes, and now you can say something like your sedan is a, and then get the sedan. So you're going to type sed dot, and then one of the members now, as you can see, is called get make. If you want, you can do it that way, you see, and it comes from the vehicles class like this, or if you want, you can get sedan make also. You see, so both of them in fact are available. There you go. So it looks like this, and then you can repeat this. Oh, make sure you put plus equals and put a BR here also to break down to the next line. So remember, the plus equals accumulates, and the BR pushes down to the next line, and now we will say your truck is, and now you're going to type here truck make model, or add the TR, and then you're going to say get truck make. There you go. Okay, so these are the basics. Now when you launch this, take a look at the results. Trying to show as many useful, potentially practically valuable things as possible. So here you're going to now type, say, Honda Accord, right, and then Ford, say, Explorer, and then get make, and you see your sedan is a Honda and your truck is a Ford, like this. All right, that's it. That's working as expected. There you go. So these are the basics of this concept. In this video, we're going to learn about virtual functions. All right, so crank up a project. This is the basic HTML. So we're going to talk about vehicles and, for example, sedans. So here what I want you to do is this. Go to Solution Explorer, right-click, add a new file, a new class file, like this, and then call it, say, vehicle, and then click OK. Click yes, add the app code folder. Bring that in there. Now, first, for every vehicle, imagine there's a make. All right, so we'll say here private string make. That's it. I'm putting this here inside the vehicle class because every vehicle has a make. All right, so there's a Honda and so on. We are going to initialize it in the constructor. So type now string mk, set the value of the variable inside. So we'll say here make equals mk. Now, this is an instance variable on line 11. Then you have the constructor from lines 12 to 15. Right, line 14 is like the instance variable setting. And now we're going to write public virtual string show information like this. Okay. Open close curly braces. So public means accessible anywhere. String means returns a string. The name is show information. But see where it says virtual? That's a new keyword. This keyword indicates that this function here provides some default functionality, and we can make use of this default functionality. But also, in child classes, this function can be refined. Okay, so public virtual string show information, and here we will simply say something like return, and all we will say dollar symbol double quote, and now we will say make, and then within the curlies put make. So this will just get you the make of a vehicle. That's it. All right. Now, to make use of this virtual function, we have to make a new class, and here we can right-click and remove the unnecessary usings. And here now we will say public class, say sedan, like this, and then colon, and then let's inherit from vehicle, so type vehicle after the colon, open close curly braces. Now, let's think about sedans. They do have a make and a model and so on, right? But they perhaps have some more specific information, all right? For example, like number of doors. Some sedans have like a hatchback, so maybe it's 4 doors, or maybe it's a 5-door, and so on, okay? There you go. So here, just to keep things simple, we'll say private int number of doors, like this. And now we're going to type the following. We'll say here public sedan, and now you're going to say this. You want to initialize the make of the sedan, for example, whether it's a Honda, okay, or a Subaru or something like that. And so to do that, you're going to type this. You type string mk, comma, and then int doors. And now to show you that you can do this, you can split the initialization. So take a look. That means the following. You can first you can write base and then pass in the make to be initialized. And then the number of doors can be initialized within this constructor. So you can say number of doors equals doors like this, you see? So this is splitting the initialization of the sedan, because the sedan constructor, as you can see, first we'll call the base class constructor with the make to set that value, and then the number of doors is set within this body, so it's being split. All right, and now we're going to override or refine. So take a look at the meaning of show information. You will say public override string, and notice show information shows up by default. So you selected, and in this case, you see where it says return base that show information. Yes, we do want to make use of this, right? We want to use this. So we want to call the base class version of show information, because we do want to show the make. But then we want to make a refinement. So you're going to put plus and then double quotes to indicate, we're making a string, and then plus and dollar symbol, something like this, for example, you see? And now you can also say number of doors and stick in that variable, number of doors. Close this with a semicolon and a double quote at the end. See? That's it. So here again, notice that this virtual function as defined has some basic information provided that would be useful for virtually all vehicles. And this one on line 24, the overridden version, calls the base class one because it makes sense to do so, right? So you want to show the make of the vehicle, but then also adds a touch of refinement by showing the number of doors. You see? So really override like this here, see that? This virtual function. The virtual function then provides some basic functionality that might be applicable in many cases, and then in the overridden version add a touch of refinement. There you go. All right, sounds like this. And again, to call a base class function, write base dot and then the name of the function, just as I've shown you here, to make use of all of this, of this class hierarchy. All right. Well, first, it's also useful if you right-click vehicle and you view class diagram. See that? So there's a relationship between the two, and also something that you should be aware of course, is this. Take a look. We made class vehicle as the parent class of sedan, and now further take a look. If I right-click on vehicle and I choose show base class, object is the base class. In fact, object is the base class at the root of the entire .NET hierarchy. What does object provide? Expanded. See all of these features that it provides here? Okay, these are accessible to us also. When you type toString in a variable, for example, it's coming from here. Okay, it's coming from a definite place, like this, toString. All right, but many times we don't talk about it, but it's present. It's the parent class. It's the root of the entire .NET hierarchy. So object, in this case, then vehicle derives from it, and then sedan derives from vehicle. There you go. So here, on the next stage, we are going to make use of this as follows: Solution Explorer and default.aspx. Let's make a user interface. So toolbox, and you're going to type text box. So 2 text boxes will be added here. One for the make, one for the number of wheels. So another one, drag that in there. Separate with a BR. Delete that. Delete that one. Let's put here now make, and now the next one we'll put wheel number or count or something like that. Doesn't matter. There you go. And now let's put a button in there, like this. Now we're going to make the vehicle. So change the text on the button to something more meaningful, like, I don't know, make a vehicle or something like that. There you go. So that's the basic user interface. In design view, text box, text box, and the make vehicle button. And of course, you still need the BR at the end. There you go. Looks like this, and now everything is tagged vertically. So now left double click make vehicle. Then we're going to make a vehicle. So now you're going to type, for example, sedan. See? And again, here, if you go to vehicle, right, and if you make this class sedan, not public, all right. See, sedan is a type which is not valid in a given context. And now take a look. It's inaccessible due to its protection level. So that's why over here I have this declared as public. Okay. So now it's accessible inside other files, other code. So you're going to say sedan. Then we'll make it sed equals a new sedan. Make it, right? On the left side you declare, on the right side you actually make it. Bring it into memory, right? Reserve memory and make it. So string we make, say, will be Honda. We'll get that from the first box. And then the number of doors, say, will be from the second box. So we have to parse that. We'll say int.parse. And then text box to the text. So this will simply make our vehicle. And remember, whenever you have nested code, from the inside to the outside. So text box 2, get the text, convert to a number, pass into the constructor. Same thing with text box 1. That's a string already. So that will just be passed into the constructor for the sedan class. All right, and with that in place, now you can display it. It's the same label the text, and then you're going to say sed.show information. And that's it. See? That's allowed, remember, because text is of type string. Show information also returns a string. That's why this is matched correctly in terms of data types. So now let's launch it in Chrome or Edge. Some browser, doesn't matter very much which one. Basic functionality should be consistent across browsers. All right, so put in some make like a Honda and say it's a 4-wheel make vehicle. So Honda, number of doors 4. You see? That's it. Now, if you want to show you that you can, let me close this. And here, what you can do is in vehicle. If you put, you imagine you want them broken over multiple lines. So in that case, let me reverse that operation. Here, put a BR like this, you see? That's it. So now when you run it, and of course the code is always in the sidebar as a PDF. All right, so say Honda, and then I really meant to say door number, not wheel number. So make vehicles, you see this? That's the number of doors is 5. I just need to change the wheel number there, but that's a trivial thing. All right, and that is it. So these are the basics of using a virtual function in somewhat realistic context. And here the only thing that remains is change this to door number. Okay, so remember to review at this point, because this is a somewhat realistic example. In the Solution Explorer, when you look at your files, you should have, right, again, the solution file, the website, the app code folder. Within that we have a class diagram. You have vehicle.cs, that's our C# code. Then we have the bin folder, then default.aspx, and then the other files that are provided by default, right, that we don't really have to touch. In this video, we're going to learn about abstract classes. So these are classes that represent abstract concepts. All right, let's take a look at the implementation. So here's our basic HTML file. So first of all, let's add something to the Solution Explorer. So right-click, go to Add, and then a class. All right, so here we will now say the following. We'll call this one called Shapes. Make it more specific, 3D shapes like this. All right, and click OK. Click Yes. There you go. So we have public class 3D shapes. We're going to make this an abstract class because there is the concept of a 3-dimensional shape like a cube or a cylinder or a sphere. But these shapes are very different. Okay, specifically the way you calculate the volume of these shapes differs drastically from shape to shape to shape. So there is a concept of a 3-dimensional object, but the specifics, the calculational specifics vary very widely. So it's a concept, we're going to make it abstract. All right? So here where it says public class, you're going to say public abstract class like this, 3D shape. We don't even need the constructor here for our purposes. All right, and there's more to this always, but I'll show you the basics. Public abstract class 3D shape, and now you're going to type here public like this abstract. All right, double get volume like this. Abstract, as you can see, means no implementation is provided. So this makes sense. All right. After all, when you go, for example, from a sphere to a cube to a cylinder and so on, the way that the volumes are found vary. The ways vary very drastically. Okay, so it doesn't make sense to provide any default implementation. If you can't think of some default code that's sensible, you go with a virtual function. If you can't, then you go with an abstract one like this. All right? So here, public abstract double get volume. There you go. And now to make use, this is our simple abstract class. We're going to make use of it in the context of two of the classes. First, let's also remove the usings. So here. And add only this one. I'll even delete this. We don't need that. Add only this. Using static system.math. All right? That's it. So using static system.math. Notice that at first it's grayed out because it's not being used yet, but it will be used momentarily. All right, and then it will be darker. So now we're going to say here public class like this, and then we will say sphere. And then sphere inherits from 3D shapes. We're going to say 3D shapes, open close curlies. And one of the defining characteristics of a sphere is the radius, the distance between the center and the point on the surface. So you're going to say here private double radius, and then you can initialize this. So you can say public sphere like this, and then double R. And within the body, you can set the value of the radius. So type radius equals R like this. So this sets the instance variable for this particular sphere. And notice this is underlined. If you hover your mouse over it, it states sphere does not implement inherited abstract member get volume. Show potential fixes. You see this? It will even show you what to do. You see? There you go. So we click that there. It provides an override. You see that? Get volume. Of course, we don't want this. We want to actually provide an implementation that's useful that returns a result. So we will say return. And for a sphere, the volume is calculated as follows: 4.00 divided by 3.00 times pi. So you put pi. If up here I did not have using static system.math, then I could not down here type pi. I would have to type math.pi like this, you see? But because up here I have using static system.math, I don't need the math in front of it. I can just write pi. See? All right, and then times pow, which is short for the power function. And in this case, you're going to take the radius of the sphere and cube it. That means radius, comma 3. This means radius raised to the third power, or multiplied by itself 3 times. All right? Now, we can extend this. Besides, of course, a sphere, we can easily visualize, this feels like a basketball. So a cube is like a box with all the edges the same length. So here we are going to say here public class cube. And then here we will say 3D shape, right? Because it is a kind of 3-dimensional object. Like that. And now here we will say private double edge like that. Now we can configure it. So we will say public cube and then double edge length as the name of the parameter, and then set the value. So you will say edge equals edge length. See? And now we have to implement get volume for cubes. So to do that, you're going to type, of course, public override get volume. See, and that provides a default implementation, not implemented exception. We'll talk about those later. So for our purposes, you're going to say return, and now you will say pow, and then double x double y. So in our case, that means edge comma 3. All right, to find the volume of a cube, what you do is you multiply the edge by itself 3 times. All right, in other words, it's like edge cubed. All right. That's it. So this is our basic class hierarchy. And here, if you wanted really to, you could do this without an abstract class there, like that. But the abstract class is more application specific, right? So abstract classes are fairly application specific, but they help to bind your code into a more hierarchically logically connected structure. All right, like this. All right. Notice that you see using system is still grayed out. So right click it and remove that one too. See? That's it. So using static system.math is necessary. There's the abstract class because it represents an abstract concept. And then sphere inherits from 3D shape because it is a kind of 3D shape. The defining characteristic for spheres is the radius. So you set the radius in inside the constructor. Then you override get volume to provide a concrete implementation. That means specific mathematical detail like this. All right? And then you repeat this in the code down below for cubes. Same logic. All right, good. Now, to make use of this, we're going to go to default.aspx. And then over here, let's delete this. And what we are going to do is read some inputs. So we'll say here, enter sphere radius, like this. And put a text box in there, of course, to read the value from the user. All right, drag and drop that in there. Put a BR in here. There you go. All right, and now enter cube edge length. Again, text box. And then put a BR in here. And then put a button that will calculate that when you click it. So button. Change the text on a button to something more meaningful, like find volumes. Put a BR after that, and that's it. So you got two text boxes with a little bit of text, a button, and a label. So in design view, this is our simple user interface. Now left double click the find volumes button. And that looks like this. And now, let me delete this. We don't need that, right? We're going to do this. So let's make a sphere. So type the name sphere. We'll call it sp equals a new sphere. And now we have to initialize the radius of the sphere. So according to our labels on the boxes over here in default.aspx, and the sphere radius, that will be text box 1. So we're going to say double.parse and then text box 1. That text. All right, close with a semicolon. So remember, for text box 1, that text means get the text. Parse means convert it into a numerical value. New sphere means actually make a new sphere object. All right? And then you can repeat this for the cube using the same logic. So we'll just Control-C that code and Control-V down below. So here let's replace sphere with the cube. And not a new sphere, but a new cube. Like this. And then text box 2, that's it. All right? And now, to display the results, we also want to rename this. So CB, for example. We're going to type sampleLabel.text equals and volume of the sphere is, and attach the volume by typing plus, and I will type sp dot. And notice get volume shows up as a function member. So selected, close with a semicolon. Then continue, sampleLabel.text. Now, because this is a new line of writing in a label, remember, plus equals, and then further, make sure you put a BR in there, correct? So plus equals appends to existing text. The BR pushes you down to the next line. All right, and then volume of cube is, and then plus, and I will say cb.getVolume. Close with a semicolon, you see? That's it. So let's do this now. In default.aspx, Microsoft Edge. That's the fastest one, I think. Give it a go here. All right, let it load as it has. So now let's enlarge this a little bit. There you go. So sphere radius say is 4, cube length say is 5. Find volume. And you see this volume of sphere is given as that, and volume of cube is 125, so it's working as expected. There you go. And that's it. So these are the basics. Remember, abstract classes represent abstract concepts, something that everybody agrees kind of exists. But here, I chose sphere and cube and so on to be the more concrete classes because a sphere has a specific way of finding a volume. A cube also has a specific way of finding a volume, and likewise for a cylinder, for example, or for a cone and so on. In this video, we're going to learn how we can return a data type from a function, and this is a data type that we have made. We'll take a look at some other things along the way. So crank up a project, and here within the HTML, we're going to place the following code that will say title1. We're going to make a little library for music, okay, a song library. This will be title1, like this, and next to it you're going to put a text box by collecting the name of the song, for example, from the user or something like that. There you go. Now let's do title2. This will be a really simple library consisting of only 2 songs, like that, then a BR. And of course, one thing that you can do once you have a library of whatever, sort, for example. So now you're going to put a button in there. And here it says button, we'll say sort, like this. Alright? Put a BR after the button also. That's it. We don't need the div. It's gone. That's it. So this is our simple user interface and design view. Title1, title2, and a sort button. Alright, so now we're going to make the song library class in C#. So as an example, go to Solution Explorer, and this, and then right click, go to add, of course, and then class, and then here we will say song library, and then click OK. Click yes to add the code folder. Alright, so that looks like this. Now, because this code is somewhat sophisticated, we're going to do the following. The code that I made earlier, I'll put that in here. Alright, it's highlighted so I can comment it out by hitting that button. Alright, and I'll go through the creation of this code line by line. I'll just delete all of the default code that we get here, like this. Alright, and let's create it line by line. So the only thing that we need on top is using system. It's the only namespace that we need. Alright, and then we're going to make the class. So you'll say now public class song library, like this, open close curly braces, and we're going to make an instance variable which is an array of strings. So you can say private string and then songs, like this. You see, let's initialize this. You can say public song library and then string and then tunes, open close curly braces, and then the songs, so that equal to the tunes. You see, so we have an instance variable that's an array of strings, the titles of the songs, and the constructor of the library here that makes the library simply sets that. Alright, now that's that step. At the next stage, let's do this. We're going to make a function that sorts the library. So we're going to say public, and I will type song library, sort library, like this. Alright, so in this case, notice that the return type of this function is a song library. So it operates and then returns a song library back. Okay, that's been sorted some way. Right, so to do that, we are simulating this. We'll say array dot sort, and notice that here the songs array is accessible. You see, and then you're going to type return and then this. That means the current object. All right, the current object, the current instance of the song library class has the songs array accessible. All right, and that's why over here it says songs, like this. And when I say this, that means the current song library object. And return it like that. All right, so this here, hover your mouse over and it tells you song library, so it matches the return type up here over song library. You see, let's add one more function here. So besides sorting the library, we can also of course display. We'll make a function that displays stuff here. We'll call it display songs, like this. So we'll say following public string display songs, and then open close curly braces, and now we will say string list equals null. So we'll make a string as follows, okay? We will do this. We will take for each here, and then the variable str in songs, like this. And again, notice that songs is accessible, like that, you see? So for each variable string in the songs array, basically for each song, what we want to do is build up a display. So to do that, we're going to type the following. We'll say list plus equals, and you can put a dollar symbol, double quotes, and then br, and then within the curly braces, str. And then you close this with a semicolon, see? This will build up a string that represents all of the things inside the songs array. At the end, you can return it, so you're going to say return list, like this. That's it. Alright, so that's that. Now, the next stage. So this is our song library, really basic one, right? With a constructor and a couple of functions. Of course, you can create other ones and so on, like a one that would search for example, a song, search for a certain sequence of characters within the song title, and so on. Right? But this is the basic code. So what we are going to do next, and also, if you have some experience with C#, there are things called lists that are more flexible than arrays, but we haven't looked at those in the context of the course thus far. Now that we have this, we will go to default.aspx, right? That looks like this. I'm going to double click the sort button. We can get rid of the event handler here. And at the next stage, what we're going to do is I'll drag in the button click code that I made earlier. Alright, I'll highlight it. And then over here, I will reproduce it line by line so we can follow along clearly. So stage number 1 will be to make an array of strings, which are the song titles. String like this, songs. Equals, and I will say new string. See? And then you're going to put here text box 1 dot text and text box 2 dot text. That looks like this. Then you're going to make a new song library. So s song lib equals a new song library, and to initialize it, you pass in the array songs. See? Now let's sort the library. So you're going to type song lib dot sort library. Notice that sort library is a member, so it shows in the list. And also now to display, you're going to type sampleable.text, and I will say here songlib dot display songs, close with a semicolon. You see? Alright, so that looks like this. Alright, so sort the library and display the songs. So in other words, I've offloaded the displaying of the songs, the building of the string that represents that, into the song library class where it really belongs, right? Because we've written some custom code here to accomplish that. There you go. So let's view this. Let's go to Microsoft Edge now. Take a look at the results. Let it load. Alright, so here, let's take a look. We have the following. Title 1. So I'll just put in some Wake Me Up as a title song by Avicii, for example, and then Cry Cry Baby, and I hit sort, and you see it shows Cry Cry Baby first now, and then Wake Me Up. See? There you go. So it's acting as expected. It's sorting the music. Alright, let me exit off the screen. There you go. So these are the basics. So remember now we have the default.aspx.cs code that looks like this. We have the song library code that looks like this. And then we have the default.aspx HTML. That looks like the code that you see here, the basic HTML. These are the basics. In this video, we're going to learn about lists. So lists are more flexible than arrays because, for example, you can size a list dynamically based on input and so on. All right, but for our purposes, we are going to do this. Make 3 boxes on the page. So type here value 1, and this is where we will put the first value. Like that, put that in there. All right, close those with a BR, of course. All right. Now, let's copy this like that. Paste it down below. Of course, the pasting renumbers the box here automatically from box 1 to box 2. A nice little feature. Change that value too. All right. Paste it down below one more time. Like that. All right. Delete that one. Delete that one. And put a button here so somebody can click to summarize the values in a list. The summarize we will define here as, for example, finding the maximum, the minimum, the average, the sum, and so on, just to illustrate some of the functions that can be applied to lists very easily. All right, and now here, where it says text, let's change that to summarize, like that. All right, put a BR here also. So this is the basic user interface. As you can see, 3 boxes for collecting values and a summarize button. Let's change the last thing here to value 3. So it looks like this, you see, simple interface. I left double click here. All right, and then here's delete this. For our purposes, it doesn't matter. So to make use of lists, we have to introduce a new namespace. So the one that concerns us is this one, using system.collections.generic, like this. So now within void button1 underscore click, we can type the following list. And then you see where it says list and T, and it says T is the type of elements in a list. So in our case, we'll make a list of doubles. That's it. So we see it's a new notation, but it's fine. It's a list of doubles. That's what it means. Okay, we'll call it, say, D equals, and now on the right side, we will write new list of doubles like this. You see? Notice that the size is not specified. So one nice thing about lists is they can grow, automatically to accommodate new values. That's a nice feature. All right, so for our purposes, next, to fill the list, we will write D dot and then add. You see? And in our case now, we're going to add a double. So to make that happen, you're going to type convert to double, and then next you will write text box 1.text. All right, so this will convert, of course, remember, from the inside to the outside. So you get the text, convert to a double, add to the list. From the inside to the outside. Same logic every single time. Control C. All right, and then Control V down below. Then repeat this for the other boxes. See? That's it. All right. So this will just make the list for us using the add function, like that. Next, we're going to display some useful results. The max, the min, the average, the sum. All right. Take a look at how easy all of this can be. So first thing you can type, for example, is this. Sample label, text equals, and now you'll say here, sum equals, and to find the sum of the list, put the curly braces and then D dot, and then sum. Notice that sum doesn't show up. All right, so to make use of the list, we need a generic namespace. To make use of sum, we're going to introduce a new one called link. So using system.link, language integrated query. We'll learn more about that later. This is just the basics. And now, when I type this, notice that sum shows up. You see this? So you can select it. And that's it. That will find the sum of the list. Really easy. No more loops of any kind. Then we can repeat this, for example, for some other quantities that might be concern a list. So for example, the average of the list. All right, so again, to do that, you're going to type d.average. See this? And it's automatically done for you for the average function. There you go. Let's do a couple more just to see some of the things that are possible. Let's also do, of course, the min, the minimum value. The min value would be this one. See that? The min function. All right, let's do one more. All right, and that would be the max, for example. And now you're going to type here max. See? So easy. Now remember, because after the first line we have to accumulate and move down, we got to stick in BRs like that. Like that. Put the BRs in there. All right. So that's that. Now, let's give this a run just to see the results so far, make sure everything is working as expected. Let's launch it. Alright, so there are the 3 boxes. And here, let's go with some easy values, 1, 2, and 3, right? And hit summarize, and it says the sum is 6, we'll count them. 1 and 2 is 3, 3 and 3 is 6, the average is 2, the value in the middle, the minimum is 1, and the maximum is 3. And as you can see, you've been able to do all of this very elegantly and quickly and efficiently. Alright, so clearly this is superior to sitting there and writing your own routines, right? Now, other things that can be done look like this. You can also do stuff like this. Imagine you want to perform an action of some kind on each value in the list. Alright? Maybe you want to display the square of the value or subtract it from the average. You do that commonly in statistics, for example. So to that, you can type the following. You're going to type d dot and then for each. And then there's a particular syntax that says action like this. So the action is something that you do basically. Alright, so you're going to put x, that. This is a bit of a new notation. It's an equals with an arrow like this. Alright, so you're going to perform some action on each x basically. In our case, what we can do is this. We'll say samplabel.text plus equals again within a double quotes, build up a string. This is like really tight code, but it works nicely. See that? And then you're going to stick in there x times x to display the square of x. See? So let's put this here as x and then squared equals. Remember, if it's brown, that means it shows exactly that way on the screen. If it's within those black curly braces, that is rendered as the actual value at runtime. There you go. So the for each here, x, that means grab each x from the list and then perform this action. That means display it. Display the x and then the square of x, like that. So let's take a look at this. All right, and put some values, 1, 2, 3. You see, 1 squared is 1, 2 squared is 4, 3 squared is 9, so that's working as expected. All right, and if you want, you can of course nest things. All right, so there's another thing that you can do, something like this. D dot for each. Imagine you want to display the value of x minus the average or something like that. So x like that. And then you're going to say samplabel.text plus equals so that it continues to append $symbol. And then you're going to put here BR. And then you'll say something like x minus the average. So to find the average, you're going to say d.average. Right, so this here, remember, it will show the x separately, it will show the average separately. And then because that negative is brown, that will show on the screen as the value minus the average. To actually do the computation, we're going to put within single curly braces x minus d times the average, well, of the average, you see? And then close this with a semicolon. There you go, so you can also nest these things. This code, as you can see, is very tight. It's extremely expressive, and it does a lot without, too many lines. So 1, 2, and 3, and then hit summarize. There you go. See that? So the sum, the average, the min, the max. 1 squared, 2 squared, 3 squared, and then 1 minus 2 is -1, 2 minus 2 is 0, and 3 minus 2 is 1. So those are the deviations of these values from the average. Alright, let me exit off the screen, and these are some of the basics of what you can do with lists. In this video, we're going to learn about polymorphism. This word means having many forms. So we will focus on 2 kinds of polymorphism, or objects being treated as different forms depending on the context. And the practical benefit is that you write less code. Alright, so here click up a project and go to the Solution Explorer, right click, go to Add, Let's add a class. Call it the products class like this. Okay, and then click OK. Click yes. All right, this is sufficient for our purposes. Now, what is true about every product is that, for example, you have a price or you have a name and so on. All right. So for our purposes, we'll say here private string name of the product, whatever it happens to be. All right. Or if you want, let's do it this way: private decimal price. It doesn't really matter that much. There you go. Now public products, fine. So here, let's rename this to product, this class, like that. And I'm making this the product file, but product is this parent class. So here you're going to say now decimal PRI, like that. And of course, the only thing we will do within the body of the constructor here is type the price equals PRI. So set the value of the instance variable. Now, let's make a virtual function. So public virtual, say, string get description, open close curly braces. Now we can say return. I put a dollar symbol in it, double quotes, and now we will say price, colon, and then price closes with a semicolon. Remember, the brown bits are displayed on the screen exactly as they appear between the double quotes. Anything that is black within the curlies is replaced at runtime with a specific value. All right, that's it. Now, another thing, we're going to make two classes that derive from the product class. So here we will say the following. I will say public class like this, and we'll say book, and then colon, and then make it derive from product, because a book is a kind of product after all, correct? There you go. It's got all the essential characteristics of a product. So we will define for the book as an instance variable that will be private string title. That's an important characteristic of a book, right? But it's not necessarily the case that every product has a title, right? Books have titles. That's why I'm making it more specific to the book class. And let's initialize this. You will say public book, and then you will say string t and comma, and then you will say here decimal p. Initialize that to the base class. So after this, type of base p like this. All right. And then the title, let's initialize in here like that. See? There you go. So we're splitting the initialization of the book object here basically by doing the common portion of it, which is the price inside the product class, but then the title, the more refined part, inside the book class. Further, let's also override the function that you see up there. So we will now say public override, and of course get desk description shows up. See? And leave that bit, it's fine, right? Because every book does have a price, so you can display that there, right? So leave that bit. But who would now add, right? Put a, like this, right? Put a BR in there. Put the dollar symbol in front of it. Put a BR in there, so it pushes down to the next line. And then we'll display the title. So I have a title like this, colon, and then title within the black curly braces. And then it looks like this, you see? So remember, at runtime, base.getDescription will be called. That means we're going to get the price of the book. And also, let's go back to the price there. Let's format that as currency, you see? There you go. And then the title will be showed also. All right, so this is for the book class. All right? Now we can repeat this, say, for a shoe class, right? Take this, Control-C, and let's repeat this block of code down below, and we'll call our class shoe. It is a kind of product. Shoes don't really have titles, but they do have, for example, like a make, right? Whether it's a Nike or a Reebok or what have you. So we'll call this shoe. And again, here we can change this to MK. Set that inside the body there, so MK will be equal to the make. But in order to use inheritance, right, the base class constructor will be called to set the price, because that field, the price field, is shared. All right, and then down below, that's the same code to override getDescription. Just change where it says title to make, and then change this to make. That's it. So we've created a relatively easy hierarchy. So to review, we have a product class. We don't even need this stuff up here. For our purposes, not necessary. There you go. So we have a product class. It defines an instance variable, which is set. Also defines a virtual function. Remember, the virtual ones are the ones that provide some, sensible default functionality, right? That we can use them below. That's why in the overridden versions, I first write return base.getDescription, because, it's a common thing that every product has a price. That's why I put it there inside the product class. So you only reuse that code. No need to, keep writing it separately, right? All right, so it looks like this. And likewise for the shoe, same logic, just a different object. All right, so with that in place, we have a parent class to derived classes. And now we're going to this. Go to Solution Explorer, open default.aspx, like that. All right, here we're going to add some stuff. So you're going to say book title, and let's also do book price like this. And then we'll repeat that. So we'll say shoe make, and then we'll also say shoe price. Okay, please bear in mind that I'm doing this all from memory. So now the book titles, put a text box in there. You see, like that. And then for the book price, another box, another box, another box. There you go. So I'll put the BRs in there to stack the little controls vertically on the page, like that. That. All right, you can delete this one here. And we haven't focused much recently on HTML, what have you, but if you do want to separate, you can do it this way with a horizontal rule. You see that? HR, that's a horizontal rule. All right, let's do that one more time. Put that in there. There you go. So now in design view, this is what we have. Book title, book price, shoe make, shoe price. And we need to get a button in there also to display the results of the values in the boxes. So here, BUTT, like this. And here to display simply means to show like a more nicely formatted input. Okay, so we'll say show formatted like this. All right, like this. So with that in place, now that we have this, the next stage, go to design view. Of course, it looks like this. Put a BR after the button. There's always a little thing, right? You got to do. And now left to double click on show formatted. And now imagine we have to make a list of shoes and a list of books. Okay, we don't have to want to make separate lists. So the better way is to use polymorphism as follows. You're going to say using system.collections.generic like this. And then here you will say this. You will say list and then product. So you're going to make a list of products. We'll call it LP equals a new list of products. And now, because product is the parent class of shoe and book and what have you, you can type the following: lp.add. And now, take a look. You can type new book. See that? You can stick a new book into a list of products because books are derived from products. All right? This is polymorphism. Because the book class derives from the product class, you can stick a book into a list of products. That's polymorphism. That book is both a book, but it's also a product, so it's got multiple forms. You see? Polymorphism means having many forms. So here, to get the title of the book, we'll take it from, say, box 1, like this. And to get the price of the book, we'll type decimal.parse, and then text box 2.text, like this. Close with a semicolon, you see? All right, so now let's repeat this. Take it, paste it down below, and change this to box 3 to get the make of the shoe. So change this from book to shoe. You see that? And now change this box 4 like that. All right? Now let's confirm that this is correct. So go back to default.aspx to the source view. Right, so book title and book price, box 1 and box 2. That's right. And then box 3 and box 4, the make and price of the shoe. And that's also right. You see that? Now again, notice that a shoe can be stuck into a list of products because a shoe is a kind of product. You see that? That's again polymorphism. That shoe class object is being treated, it's a shoe, but it derives from the product list, so it can be stuck into a list of products. So it has two forms in that sense. It's polymorphism in action. All right, now, one thing that we can do, of course, is display the results. So I'll show you a way of displaying the results. And that will be another example of polymorphism. You're going to type samp, let's do it this way. lp.forEach, all right? So we saw that in the previous video. All right, so you're going to type x like this. Now remember, here x means the book and the shoe. Okay, it's not a number like 2 or 4, but an object, a complex object. All right, so you're going to put x, which will present objects, and you're going to put that symbol to indicate an action should be taken. And then you're going to type samp label.text plus equals, like that. Right, you're going to put a BR to break down one line, like that. And then put a dollar symbol in there. In our case, what we're going to do is just display. So that means specifically we're going to call get description from each class. All right, so within here, take a look. Let's do it this way for now to keep it simple. You're going to type x.getDescription. Close this with a semicolon. You see? Now, hover your mouse over get disk. You see where it says product.getDescription? But then the question is, at runtime, this is the question. At runtime, will this version of getDescription get called from the product class? Or is the system smart enough to realize that the more correct version to be called is this one, from the book class and then from the shoe class? And this is another instance of polymorphism. All right? At runtime, when the program runs, that x, like this, will represent a book or a shoe more concretely, and the call will be resolved to the child class. So the correct derived version of getDescription will be called. Take a look. All right. Polymorphism, as you can see, is an interesting but subtle concept. Let it go, build the app. All right, put the book title in there, say Amazing Tales, right? Imagine the book price is something like that. Right, shoe makes a Nike price, something like that. Show formatted. And you see this? Price, that, title, Amazing Tales, the price is $87.99, and then the make is Nike, like that. All right, I should have put the little BR in there. That's okay for our purposes, doesn't matter. But the point is that this confirms that the correct derived version of get DESC, get the description, has been called. All right, so again, to stress this point, the benefit is you made a single list. The single list of products can accommodate many different kinds of products, so you're writing less code. The fact that a book, a shoe, or what have you, can be stuck into a list of products is polymorphism. And the fact that at runtime the correct version of getDescription is called is another form of polymorphism, because that x, which represents the book and the shoe, then is correctly resolved to the child class. So two forms of polymorphism. In this video, we're going to learn about interfaces. Interfaces are contracts, and these contracts are widely applicable, meaning many different kinds of classes can implement an interface. All right, so let's build a hierarchy. Pick up a project. This is the HTML given by default. Let's go to Solution Explorer. So right click here, go to add, and then let's add a class. And then we'll call this class here printable objects like this. Click OK. Click yes. We really want to just get the C# file more than anything else. So with this in place, I can basically take all this default code here and delete it. And we're going to say this: public interface iPrintable, like this. All right. So public means accessible anywhere. Interface is a keyword, and then iPrintable is the name of it. And many interfaces have ABLE at the end. And the reason is that we think of the relationship between classes and interfaces as can be used as. So for example, a document is a printable thing, right? It can be used as a printable thing. But so can a person. A person can also be printable and so on. It can be used as a printable object. All right, depending how you choose to define things. So public interface iPrintable. And here, all we are going to do is declare the following. You'll say here string print. That's it. So a simple method signature. That's what that is. And remember here, if you go to Solution Explorer, say it looks like this. All right. Now, to make use of this iPrintable, we're going to type public person. Let's do it this way: public class person colon and then iPrintable. See? This is the printable interface. That means this person cannot be treated as a printable object. All right, so to do that, we're going to do this. And notice that once you do this, because this is the interface and it's a contract, its members have to be implemented in the classes that use that interface. So here, you see where it says right click, quick actions, implement interface. So it provides a little bit of a code for you. Public string print. We don't want this one here, so we're not going to worry about this. Let's delete that. And in our case, to print a person will be the following. First is define a person. Very simply, we'll say private, like this. Right? String name. Now let's set that name. So you can say public person string NAM. And then set the value. So we will say name equals NAM. That's it. So you have a class person which implements the printable interface. That means that a person can be used as a printable object, like that. And now here we have the print method. So now we will say here return and then $, double quotes, and here we will say name colon and then put the name in there. That's it. All right. Now, with that in place, let's delete this. Let's add one more. All right. And the big idea with interfaces is they are widely applicable. In other words, many completely unrelated classes can be printable. So take a look. Public class document. See this? Like that. And this also implements iPrintable. And notice again that person and document do not have much in common, correct? Completely two different constructs, but both can be treated as printable objects. There you go. So, and again, we have to implement print for document. So let's first define it. We'll say private string text like this, and then public document string t. Set the value. So in our case, we will say here text equals t. That's it. Now implement printable. So right click, quick actions implemented. See that? Print. Just change this to say return and then the text like this. Yeah, just return the text, all right? But let's also make sure that, put a BR in there so everything gets pushed down one line. Do it that way. See that? Remember, if it's between double quotes, it's text, but when the browser receives it, of course, then it's seen as HTML. Same thing up here. Put a BR in there, like that. All right, so that's that. So, with these in place, now take a look. We're going to go to Solution Explorer, default.spx, like this. All right, and here, let me fix that. You're gonna put a box like this. Okay, you're gonna say text box. All right, and name. So this will be the name of the person in the box. Put a PR at the end there, like that. And then here we'll put text of the document. All right, so keep things simple. So that looks like this. Now the next stage, let me delete this. All right, and we'll get a button that will show these things. All right, so put a button in there. All right, put the BR in there after the button. There you go, and here we'll have print as the word on the button. All right, so in design view, we have a very simple interface, 2 boxes and a print button. Now left to double click on the print button, and now we're going to work with the interface inside the event handler. So to do that, we'll do the following. First, we're going to type iPrintable. See this? Notice that this shows up on the left side as a type. I'm going to type PR equals a new person. See that? And say textbox1.text like this. All right? So notice that on the left side, the type is iPrintable. On the right side, the object actually is made because the new keyword actually makes the object, right, is a person. And then you can repeat that, iPrintable. See that? Now we'll say here, I don't know, book or something equals a new document. Now it'll come from textbox2, text. You see? So this shows that you can now make printable objects, okay? Even though these are widely different, persons, books, and so on, they all have the fact that they are printable in common. Now, come up here and then type using system.collections.generic, and now take a look down below. You can write list of printable objects, and guess what? You can make a list of printable objects so you can search and so on. So take a look. All right, you can say here, we'll call this PR, and then we'll say new list of printable objects, and then to add values to the list, you can type PR.add. You see that? All of the stuff that's available on lists now becomes available here also. You see that? Operating on these printable objects. So PR, and then PR that again add another object, which will be the book. See? And later, or rather earlier, we also learned about for each applied to lists. So now we can do stuff like this, for example. PR.for each X. Now remember, the X in this context, okay, represents a printable object. So that means here you're going to say now sampleable.text plus equals, and then you can say x.print. You see? There you go. Notice that print here, as you can see when you hover your mouse over it, it says iPrintable.print. But remember, ultimately, the system is smart enough to resolve that call correctly so that this print is called, right, from the person, and then likewise from the document class. All right, there you go. So you can declare objects of type printable. You can make lists of printable objects. You can operate on these lists of printable objects using constructs like for each and so on. See? All right, so let's crank this up in Edge. All right, and now I'm going to enter some amazing tales. Name. Okay, so here, say John Smith, right? And text is say, it was a beautiful day. And to print this, hit print, and you see name John Smith, it was a beautiful day. There you go. So it's working as expected, which is good. That's it. So to review, we have an interface, which is essentially a contract. And the purpose is to bind things together to some extent, okay? And the relationship between classes and interfaces is that of can be used as, so a person can be used as a printable object, likewise as a document. Once you have an interface, when you implemented, the members have to be implemented or you're going to get an error, right? iPrintable is underlined red. And then with that in place, you can now make objects of type printable. You can make lists that store printable objects and other things. In this video, we're going to learn about indexers, which allow us to treat an object as if it were an array, essentially. All right, so pick up a project and go to Solution Explorer, of course. Right-click, go to Add a class. Call it, say, the records class, like this. So records of some kind, doesn't really matter what records you're storing. Click OK, click Yes. All right, now, one of the instance variables for this class will be an array. So public, like this, double, like that, and then you're going to say here records equals a new double array, like that, and then after you're going to throw in some values. It doesn't really matter what they are. There you go. Like that, okay? So we have some values inside an array. Now, this is the constructor for the class. Again, and for our purposes, you can delete this. There you go. Because we already have the value of the instance variable set inside the class itself. You don't have to make it. So here now you're going to make the indexer. So you'll say now public, accessible anywhere, double, so the value that it returns, and then the keyword this, and then you're going to type INTI. This is the header of the indexer. So public double, accessible anywhere, returns a double. This is a keyword int I. That's how you access the entries. So then you're going to put that, then you're going to type get, and within the get you're going to say return, and then you'll type the name of the internal array, which is records, and then the index I. See? Like that. And now I can also have a set, so type set, and I will type records at I, so equals, and I will type value. That's it. That value is blue. That's a keyword that exists by default. That's how you can assign new values to the array, like this. This is the basic class. Now we don't need a lot of this code here, so click on the light bulb, remove the unnecessary usings, and that's it. All right. Now we would like to get the length of this internal array records, so we can do that through a property, for example. You can say public int, we'll call it length, like that, and then we'll say here get, and then we'll say return records dot length. See? There you go. So we have a class called records. An instance variable for the class is this array of doubles. Now we have an indexer like this that allows us to access values and set values, and now we have a property also that can get the length of the internal array. And notice that these properties and indexers are pretty much the same structure with the get and the set. All right, so that's that. So now go to default.aspx, and the only thing I'll be able to do here is read the values back to the user. So do that, go to toolbox and put a button in there. The BR here, like that, and then change the text on the button to something more meaningful, like get records, like this. Go to home, delete that, delete that. That's all we really need, so really easy. Go to design, left double click on get records. All right, so let me delete this, and now it looks like this. All right, so we're going to make a new records object. RECS equals a new records object, like that. So this is how you make a new records object. To make use of this object, to step through it, to access their internal array, you can type the following: for INTI equals 0, I is less than RECS the length, like that, and then I like this, plus plus as we've seen before, open close curlies, and now I can display the records. So you can type sampleable.text plus equals, of course, to append, and then put in the BR to move down to the next line, and then plus, and now RECS, and then you're going to put the I like this, you see? So remember that this RECS is an object of type records, but because it has an indexer operating behind the scenes, you can write the name of the object, and then further, you can treat it almost like an array, as you can see at this instance right here. See that? This is almost like an array. There you go. All right, so let's give it a go here in default.aspx. Let's run it. Look at the results. All right, get records, and there are the records. Now, notice that this output is accumulating. To ensure that does not happen, of course, the key is to clear the label text every time. So here at the beginning, always type sampleable.text equals nothing, you see? So now when you run this, you're going to get records, and you see the records show up like this. All right, and that's it. Let me exit off the screen. And of course, I've shown you a simple example, but indexers can get quite elaborate and can be used in many contexts. But this is a very simple, straightforward example of how to use an indexer. So remember the big idea? You can make an object into an indexed construct so that you can then step through the object, because that object stores as an instance variable an array. In this video, we're going to learn about making applications more stable by handling bad conditions, but these conditions are usually of the foreseeable type, so you know that they can happen in advance. All right? So we call these exceptions. All right, let's take a look. This is the basic HTML phase. The first thing that we're going to do is get a couple of boxes in there. We'll have two boxes for entering input, and then we'll try to divide the values. That's the objective here. And put another box in there. All right, delete that. Delete that. Put a button in there also, like this. So remember the big idea here is make applications more stable, more professional. All right, so that's the reason for having exceptions. Otherwise, your stuff will be crashing all over the place, and people will get frustrated and leave. So that looks like this. And design looks like this, you see? Change the text on the button there to be more meaningful. So we'll say here, divide. And then here, this will be the box value 2. And then this will be the value 1 box, like this. So that's the basic HTML. That's it. All right, left double click the divide button. We don't need the event handler for page load. And here, let's take a look. So the first thing that we are going to do is type double XY and say quote like this. So we need these variables for basically reading input like this, okay? And the QUOT will be for the result of the division between X and Y. All right, so now further, because there's no guarantee that the input from the user can be successfully converted depending on what somebody enters, you have to type try. Any stuff that is to be tried but is not guaranteed to be successful, you can put it within the try block, like that. So now you're going to say try, X equals, and now you'll say convert to double. Now you're going to get text box 1, the text. All right? Repeat this for Y. So Y equals convert to double, and then text box 2, the text, like that. Right, at the next stage, we're going to do this. We'll say quote, like that, equals, and of course now you can put X comma Y, see? But this stage could generate errors because if Y is 0, that is not allowed in mathematics. So what we'll do is say this: if Y equals 0, then we are going to type the following: throw on new divide by 0 exception. Notice that divide by 0 is a class like this. You see that? All right. And it says initializes a new instance of the divide by 0 exception class. And to throw an exception means to pass it to code that will catch it, that will handle it, that will make some use of it. All right. Else, If that's not the case, we can do something like this, sample label the text, and then you can display it. For example, you can say $symbol, double quotes, and x divided by y is, and then you'll type here quote. Okay, or if you want, you can just do x divided by y in place like this. You don't even need a quote if you don't want it to keep things simpler. You could use it, but that's fine, doesn't matter much. There you go. All right, now let's take a look here. After the try, you're gonna put catch, and you're gonna catch the divide by 0. So you're gonna type catch divide by 0 ex. See? So over here, you're making a new divide by 0 exception object, and then you're throwing it, and it's gonna be caught down below. So to catch means to handle some of the features that are passed. So you're gonna say sample label.text, and then you will say ex.message. You see? So there's a message property that this object divided by 0 exception object carries, and you can display that message. All right. Now, that's if you have problems with division by 0. What if the input cannot be converted? We can handle that too. We can type, for example, catch and then format exception ex, open close curlies, and now you can say sample label.text, and again ex.message. There you go. So that's if somebody types, for example, the word 5, F-I-V-E, instead of entering the number 5. That's going to give a format exception. And the last block is called the finally block. And this block runs no matter what happens above. The finally block always runs. So sample label.text, and say something like this. All right. So plus equals to append, and then make sure you push down one line. Then you'll say your operation is complete. Let me close this with a semicolon. See? That's it. All right. So this is the basic code. Now, let's take this Microsoft Edge, take a look at the results. All right, so I've made this big. Enter some values like say 2 and 45, hit divide, and it says 2 divided by 45. It gives a nice numerical value, and it says your operation is complete. That's good. Now enter for the first box some letters. Okay, make it more concrete. Enter the word 5. Now it says your input string was not in the correct format, and your operation is complete always shows. See, that doesn't work. Now put a 0 in that box. And a 6 in this one. Now it says attempted to divide by 0, and the application has not crashed. There you go. See? All right. Let me close this. Let me close this. That's it. So here the benefits are: you have a try block, so code that try to run that could potentially generate errors or exceptions, exceptional situations you put within a try. Then you can put a series of catch blocks to handle the different exceptions. That usually means displaying a message, but it's not the only thing necessarily. For example, take a look here. If you want more than just a message, you want some diagnostic output, you can type sample label.text, right, plus equals to append, and then you will say a BR, and then you can type plus and then ex. This is something called stack trace. That's a property. So take a look at this one now. This one is helpful, you know, put in some stuff. You see this? Right there. So it tells you exactly where in the code the problem has occurred, specifically line 17. There you go. See that? So that's the stack trace. All right. Looks like this, that looks like this, and there you go. So these are the fundamentals. And again, remember the big idea: make applications more stable, more predictable by having try, catch, and then finally, which always runs. And further, if you are aware of certain exceptions, you can throw them like this one by typing throw and then new and then the name of the exception like this. And of course, if you want to learn about it more, then you right click the name of an exception class, you go to definition, and you see this. It looks like this. So format exception inherits from system exception. Go to the definition of that one. System exception inherits from exception. Go to the definition of that one. And there you go. See that? So there's a basic hierarchy of classes as far as exceptions go. And of course, if you wanted to, you could write your own exception class that inherits from one of the existing ones, for example. In this video, we're going to learn about several concepts. So we will learn about automatic properties, named parameters, and then also optional parameters. All right, so we'll make a little application that allows us to search, for example, as if we were searching Amazon or something like that. I'll bring up a project, and here, let's make a file. Right click, go to add, and now class, change that to book like this. So we'll make a class called book, and then click OK, click yes. All right, so it looks like this. Now, because this code is somewhat elaborate, I have it saved, so let me put that in there and then comment it out so I don't have to try to remember 500 lines of code. So I'm exaggerating, obviously. So here we're going to say the following as a first step. To make our book object, you will say the following. Public, accessible anywhere, string, and then title, like this, and then you're going to put a get and a set. This is what we call an automatic property, which means to set its values, you can set the value of the property directly inside the constructor. You don't need a backing field explicitly defined. All right, but let's set a couple of the quantities, a couple of the instance variables. So string will say book type, for example, with this traditional electronic book. All right, so that's another thing. And then let's also do the publication date. So and pub date like this, like that, right? That's the publication date. So these are the things that are going to define our book. Now, let's make a constructor. So stage number 1 inside the constructor is to make the parameter list. You can say string like this, title, and then integer, publication date. And notice that the publication date is an integer because that's the way it's measured. And then string type equals, and now you're going to say here traditional book. This is what we call a default value or an optional parameter. So by default, the value of this will be traditional book. All right? That's how you can write equals and then traditional book. Now to set the value of the title property, you're going to type the name of the property and set it equal to the parameters. That's title, you see? So this is basically saving us lines of code by not having to create an explicit title backing field. And for the pub date, like this, we'll say publication date, like that, to set that value. And then book type. So book type equals, and now you will say type like this, you see? That's it. So we have made our book object. Now, because we do have a couple fields and an automatic property, we want to override to string. So you're going to type public override to string. Remember, toString comes to us from the object class. That's where it's defined. And then the object class toString is virtual, so we are going to refine the implementation by typing the following. Right? Here, if you use the default version, it's not very useful. It doesn't produce nice results. We need more clear results. That's why I'm overriding it. So you're going to say return, and now you will say here title, like that. And then you're going to put, of course, title, the property there, like that. Okay, then you're going to put a BR, and then type. Then you're going to put the book type field, and then you're going to put another BR, and then you're going to put the publication date, like that, and then colon, and then the pub date field, and then close this with a semicolon, you see? That's it. So this will produce a nice result on each book in terms of displaying something useful to the user, right? Specifically the title, the type of book, and the publication date of the book. All right, so that's that. We don't need any of this up here. As you can see, it's all grayed out, so you can delete it. There you go. So this is our book class. So again, remember, here we have the title. That's an automatic property like this. And it's automatic because its value is set directly within the constructor. We have never done this before, like that. All right, so now also this here is what we call an optional parameter. As you can see, it says the type, the name, and then some default value assigned to it, like that. All right, So make use of it as follows. Go to default.aspx, and we are going to put a search box and then a button that says search. All right, so we'll be simulating almost having like a little database. So we'll say here search for, and then put a text box in there, and then here BR, like that. Let's also do a search button. So button. All right, put a BR in there, and now change the text here from button to search, and that's it. So this is the basic HTML interface, and design view looks like this, nothing fancy. So now left double click on the search button, that brings up the event handler for it. You can get rid of page load, and here what we're going to do is the following. Again, I have the code I prepared earlier ready, so I'll paste that in there. All right. So first thing is we're going to work with lists. So we'll say here using system.collections.generic like this, because as you can see, lists are super useful. One of the most practically useful things that you can find. There you go. Now, let's take a look at the code. So first, so that we don't accumulate output on the screen, we want to clear the label every time. So sample label.text and then set that equal to nothing. Let's make a list of books. So list and then book. See? This is a list of books. Now give it a name, book list, and then reserve memory for it. So new list of books. Then at the next stage, we are going to fill this list of books. So you're going to type a book list dot and then add, and then you'll say new book. And here, first let's use the concept of a named argument. So you can say title colon, you see that? And then you can stick in the title, say it's Moby Dick, all right? Popular book, like that. Comma. Put in the publication date, colon, and then say 1990. I don't know when it was published. Say it was published in 1950 or something, who knows? And notice that here, I'm specifying the title and the publication date, and because, and book.cs, right, the type of book, whether it's traditional electronic, is optional. I don't have to type anything here, right here, okay? It will be assigned the default value, which is the optional value there of traditional book. All right, now let's repeat this. We have to show enough variety to drive home the point. Let's do one more. Book list that I add, and now you will say here a new book like this, and then you'll say 13 steps to riches like this. All right, by Napoleon Hill, and you can say date time dot now dot year, and just to show you that you can date time dot now dot year, and imagine subtract 50. So it was published a long time ago. Maybe this is an updated version of that book. So say now ebook. Okay, like this. That's it. All right. So it's like this. And now one more thing. Notice that in this case, the ebook will override the default value, which is traditional book. All right. There you go. And just to drive home the point of name parameters, with this one here, take a look. If I take this and I add one more book to the list, and I can switch them around. So for example, if I want the publication date to come first, then I absolutely can do that, you see. This would be a new book, publication date, say some year, it doesn't really matter, 1965 or something. Like that, okay? And then let's change the title here to, there you go, something like Think and Grow Rich, all right? And I'll leave the default of traditional book. Actually, this one was first published in 1937. It's a great book, Think and Grow Rich, by Napoleon Hill. All right, now, imagine we want to be able to search this list. So you can type list of books, like that, and now you'll type search results. This is a really nice feature. And now to get results, you're going to type book list dot find all, And now we're gonna do some fancy stuff here. So book, put an arrow like this. That means apply this to every single book in the list. And you're gonna type book dot title, which is the property, dot to lower, to ensure, because people will type stuff uppercase, lowercase, a mixture of cases. You want to do everything always on an equal footing. So convert everything either to upper or lowercase, like that, to lowercase, say dot contains. And the text to be contained is the one from the text box. So type text box 1 dot text dot to lower. You see, always on equal footing. So everything is compared in terms of lowercase, like that. And now hover your mouse over find all. You see what the return type is? It says list book. So find all will get your list of books. All right, nice feature. And now to display it, of course, that's the last move here. You're going to type search results dot for each and then book. You're going to type that symbol, action to be taken on each book, which is this one, sample label dot text plus equals, and now you're going to type the name of the book and then to string to convert it to display form, like that. All right, so that's the basic logic. And delete this. So this, this is a nice little application that you've built here. Crank it up an edge. All right, load the interface. Let me enlarge it. There you go. Now remember, if I enter something like MO and I hit search, you see this title Moby Dick, type traditional book, publication date 1950. And there you go. So it's working as expected. X this off the screen. And that's it. So these are the basics. Remember, we have a class, we have an automatic property, whose value set inside the constructor. We've overridden to string to make the display more professional and useful. Further, when we made the books, we used named parameters or arguments, and we also used optional ones, so that, for example, if I type 13, take a look. You get to visualize. Oh, if I type 13, I hit search. You see, type ebook. So that overrides the default value like this. All right, let me close this, and that's it. In this video, we're going to learn about the null coalescing operator. This is a nice little operator because it helps us to write more stable applications that don't crash when, for example, an object reference has not been set. Let's take a look at this in action, otherwise it's going to seem very abstract. This is the basic HTML. So step one is to make a class file. So right click, add as usual, class. And we'll call this class car. Click OK. Click yes. There it is. So we're going to have some code prepared. When examples are simple, it's all right, but when they become more realistic, you have to prepare the code in advance. And then let's go through it. So as in the previous video, we will make a relatively simple class called car using automatic properties to save time. So we'll say public string, and then we'll say here make and model, and then get and set like this. And then we'll say public string previous owner like this with the get and a set like that. So now to set the values of these automatic properties inside the constructor, we have to take the following step. Delete that. We're going to say add up parameters. So we'll say string make model and then string prev owner like this. All right, and now we will say make model equal to make model. In other words, the value, the property equal to the parameter value, and then previous owner property equal to prev owner like this. That's it. All right. Now here, make sure that's the capital M like that. All right, that's our whole class. So it's a really easy class. Notice again, no backing fields for the properties are required because these are automatic. The values are set through the parameters directly inside the constructor. All right, delete that. And here I could, that's it. So that's the whole code. Now, going to default at ASPX like this. And what we're going to do is write some code here. It's more sophisticated than before, but similar. So here, for example, we can search for cars just the way we did before. So you can, for example, say search like this. Let's even simplify it. All we are going to do is a button. Do a button. That's it. Right, and then here we'll say get inventory like this, as if we were getting this from a database. We're simulating that experience. All right, VR then. Right, we don't need this. Delete that. Don't need that. That's it. So design view, a simple button. That's all it is. So left double click, and within here is where we're going to place the code that simulates the database, so to speak. So of course, the first thing to do is make a list of cars, so you can search that list. So using system.collections.generic, and it looks like this. All right, so let me put that in there, comment it out, and let's go to the process. Stage 1, make a list of cars like this. All right, car list is the name of it. On the right side, reserve memory, so new list of cars. Then you're going to add cars. Now, to simulate the operation of the no coalescing operator, we need a variety of data types. So we're going to say car list dot add, and then new car. So first we'll add the following: Honda, comma, Accord, comma, and then imagine that the previous owner is null. See that? That's a possible value, and the code works. Let's do it one more. Car list dot add, and now a new car again. Now imagine that the first make model business is null, like that. You see? And then the previous owner, for example, is Mary Jenkins, like this. So maybe you have a Mary Jenkins there, but nobody ever put down what her car was. All right, and then another one, car list dot add, and then you're gonna make a new car, and here you will say null. Actually, we've done that one already. So you know what? Let's do one that's complete. All right, one that's perfectly complete. So maybe somebody had a Jeep, and then like this, Cherokee, comma, and then say the person was here, I don't know, Bob Jones or something, like this. And then one more, so car list dot add, and now imagine, you know, this is coming from a database, and a common value in the database might be null, meaning the information is missing, like that. You see that? So you can just put in null. So we're simulating a variety of possible problems. All right, so now the next stage in the process, what you want to do is the following. We're going to display these. So we're going to say for each car, C in the car list, like this. So you're going to iterate over each car inside the list. That's why I have car here, like that. We're going to do the following. So we'll take our sample label, as we've done before, and then plus equals, like this. And then you put the dollar symbol, and then double quotes, and now you're going to type BR, and you're going to get the make. To get the make, we're going to do the following. First, we'll do it this way, just to show you what the errors are, then we'll correct them. T.makeModel, like this. To C.makeModel, rather. That's split, like this, okay? We can do this because make model, as you can see, is a string, and strings can be split. All right? So C is the car, has a property called make model. And you can split that property into the following. We'll say a new car, and we'll split that by the commas, like that. See, that's what that means. Split the value of make model by commas. That's what that means, all right? At the next stage, that is actually split into an array of strings. So the value that interests us, the make, is at index 0. You're going to put after that 0, like this. So believe it or not, hover your mouse here over split. You see how that returns a string array? That's why I can have all of this here as an array of strings. And then it looks fancy, but it's still just the name of an array of strings. That's why I can put a 0 like that. All right? And then close this like that. All right? So imagine this is the only code that there is, just to begin somewhere. Take a look. So crank it up in Edge. Give it a second to build all the files. I get inventory. And notice we get an error. You see, it says object reference not set to an instance of an object. Alright, so let's start correcting this. Put that symbol there. Alright, the question mark. And put the question mark there also like that, you see? This is the null coalescing operator. It helps us to ensure before we make use of anything that it exists, that it's not null. So when I run the code this way, I hit get inventory, you see this? Make Honda, make Jeep, make nothing. Now the application is more stable, correct? It's not crashing anymore, it's not giving us this kind of nonsense here that we see in the server application error. Alright, so it looks like this. And of course, here what we're going to do is extend this. So at the next stage, let me delete the reference code that I had earlier. Imagine you only want to get the model out of there. So to do that, you can take that code there, Control C, Control V, change where it says make to model, right? And keep the same things. The only difference is change this to index 1. And again, remember, split returns a string of an array of strings. That means that index 1, you have the model. That's it. Right? This doesn't matter how fancy it looks. It's still just an array. Alright, so it looks like this. And the last bit might be, what if no value for the model or the make is given and so on? Alright, so we can handle those also. Take a look. This is what you can do. You can now write a double symbol like that. And after it, you can put a default thing to be displayed. So for example, you can say, first one was make, so make not known. Alright, you see? Like that. Let me decrease the size of the font a little. And let me see, 140%. This is a nice feature, make not known. Now let's repeat this also for the next one. So imagine, again, no models is given, so model not known. This is the default value to be shown in case no model is available. All right? And let's do this for the previous owner also. So you can say sampleable.text plus equals, of course, to append dollar symbol, and now you'll say a BR, and you'll say previous owner, colon, and then you will see T, put that symbol there, the question mark. Okay. Question, I'd rather C, and then question mark dot, and then previous owner. And again, this will work fine, but if owner is not known, put double question mark, and then you're going to specify no owner known, like this. Alright, that looks like this. There you go. And remember, with this, you can basically check that C exists, then you can check that make model exists, you see? So it helps to get rid of unstable applications that crash when something does not exist, but you try to make use of it. Alright, so I'll launch it in Edge, hit get inventory. Now enlarge all of this, and you've got make Honda, model Accord, previous owner, no owner known. You see that? Now you have a nice stable application. Of course, notice the results are being accumulated, so let's fix that quickly. Here type sampleable.text and set that equal to nothing. And one more thing to separate the results, sampleable.text plus equals, and then between double quotes say something like this. Alright. And also a BR, you always need that BR, right? I was going to output on the same line. Now when you launch it, you get inventory. That looks like this. This is the inventory. Now it's nice and clean. Everything is separated and the application is stable, like this. All right. That is it. So these are the fundamentals of this concept. In this video, we're going to learn about overloading operators. So click up a project. And let's go here to Solution Explorer, right click, add, go to class as usual, call this vector, and click OK. Click yes, that's it. Now vector is just a collection of numerical values for our purposes, so we have to define what it means to add them. Alright, so let's take a look here. You know, because somebody has told you that 2 with that symbol plus 4 equals 6, correct? You also know that in the context here of C#, something like hello, like this, plus and then world, like this, it gives a new string that says hello world, like this. Alright, so you understand that the plus symbol can operate on numerical values, but it's also been overloaded, assigned a new meaning to, for example, so that it can operate on strings. Alright? So the same principle applies here. Vector for our purposes like two numbers between arrows like that, you see? And to add another vector would be to type something like this. And then you define the sum. The sum would be the 1 and the 2 added together to give a 3, and then the 2 and the 4 added together to give a 6, like this, you see? That's how you define the sum of two vectors. So here's to make this happen. The first of all is define the things that define a vector. So we're going to say here, and we'll deal here with those automatic properties, so everything is as efficient as possible. So we'll say public double, we'll call it x coord, like this, okay, for x coordinate, and then also y coord, like this for y coordinate, you see? Then you can make this into properties. So let's do that next. So public double x coord, and now you're going to type here get and set, and then repeat it for the next one. So public double y coord, and now you'll type here get and set, like this. All right, to complete that one, you see? There you go. Now let's put this all in a single line. Let's not really push it down over multiple lines, not necessary. There you go. So now you can set the values of these properties inside the constructor automatically. So double x and double y, like that, and the x and y represent, this is your x, the first value in the vector, and the y is the second value in the vector. So you'll type x coord equals x and y coord equals y, you see? Now, we're going to define what it means to add two vectors. So you're going to type public static operator, like this, you see? Let's type here vector like this, and then operator, plus. So accessible anywhere, public static means class level, of course, vector is what it returns. The operator is a keyword, and a specific operator is an additional operator. So they're going to say here vector vec1, comma, and vector vec2. All right? Open, close, curly braces. And that's it. The next stage, what we're going to do is return a new vector. And to add two vectors, remember up here we took the x-coordinate of the first, and you add to it the x-coordinate of the second. So you repeat that down in the code. You're going to say vec1 dot, and then you can say, for example, x-coord plus vec2, like that, and then x-coord, you see? Comma. And then you repeat this for the y-coordinates to form the y-coordinate of the sum. So vec2 dot y coord, and then vec2 dot y coord, you see? Close out the semicolon. Make sure this is y, not x, and that's it. So this is how you overload basically. So this is the plus symbol. Now that plus symbol will be meaningful when you apply it to vectors. Also, let's override this one. You can say public override and then choose toString. All right, let's override toString. Remember, toString is defined inside the base root class called object. So in our case, we want to return a nicer representation of a vector that looks like this. This is the mathematical version. So to that you're going to type return, and then you will say here between doubles, like this, you will say x coord, comma, and then y coord. See? And then close this with a semicolon. And that's it. So this is our basic vector class. We've got two automatic properties, set them inside the constructor. Now we have an overloaded plus symbol. So the plus symbol becomes more meaningful in the context of vectors, like that. And now we also have toString overridden, so that when we display the vector it looks the way it would look in a textbook. So an arrow like that, number, comma, number, another arrow. See? Alright, so now we are going to make use of this. Alright, so go default.aspx, and what we are going to do is add some vectors together. And for our purposes, to keep things efficient, place a button in here. We're not going to read them from the user. We could, of course, and in a real application you would. But for our purposes, all we will have is a button that says add, like this. And then go to design. That's it, you see? Alright, put the BR there after that one to push it down to the next line. And there's your design. Alright, so left double click on add. Alright, delete this here. And here, tab that over. Alright, so you're going to make some vectors. Every time somebody clicks the button, you're going to make a vector. We'll call this one vec1 equals a new vector like this. Alright, then specify the things that define the vector, 1, 2. That's the x-coordinate and the y-coordinate of the vector. Repeat this a couple more times, like that. Just rename it to vec2, of course. Change the x and y coordinates, so they're not all the same. It's going to get confusing. Change this to vec3, change it to say 5 and 6, like that, see? Now imagine we want to add these vectors together. So for example, we want to add the first vector with the second vector and then the third vector individually, see? And then you want to add the second vector with the first vector individually and then with the third vector individually. So you're going to go through the process. So to do that and to learn something new along the way is this. I'll make some code. I'll bring in some code that I made earlier, like that. I wish the little cursor would not do this sometimes, like that. There you go. And the code is going to do this. So stage 1, we are going to use a for each. We're going to say for each vector, like this. v1 in vex, like this. So we need to now make an array of vectors. To accomplish that, you will type the following. We'll say vector, just to show you that you can. You see, you can make an array of vectors. Vex equals a new vector, like that. And then you're going to put vec1, vec2, and vec3. So now we have made an array of vectors. You see? There you go, our own custom data type. Alright, next. So for each, and then vector v2 and vex, open close curly braces, we're going to say the following. I am using nested for each loops for the following reason. First, the outer loop, this one here that I'm moving my cursor over, will fix VEC1. And then first VEC2 will be added to VC1, and then vec3 will be added to vec1. See? And so on. Alright, so to display them and make use of the overloaded plus operator, the one that's meaningful in the context of vectors, you can type sampleable.text plus equals as always to accumulate. And then here you're going to say a BR, then you will say v1 to string. Alright, so first we want to give a nice formatted representation of v1 plus, and then v2 to string. See? Equals. And the next line, you're going to type v1 plus v2. And now, in this context, hover your mouse over that plus, you see? It says a vector is returned by that operation. So that plus now returns a vector, because we defined it to do so. And then to string. And close this with a semicolon. See? That's it. Now remember, in this context, if it's brown like that, that displays directly as it is on the screen. On the other hand, if it's black, then it's first converted to, this is v1, so the first vector and the second vector and so on. See? Alright, so let's crank this up an edge. Take a look at the results quickly. Hit add, and you see there are the vectors, all added. Let me make it big. See? So 1 and 2 gives 2 and 4. 1, 2, and 3, 4 gives 4 and 8. 1, 2 plus 5, 6 gives 6 and 12. So this is the first vector added with the other two, correct? Then the next block is the second vector added with each of the other ones, and then including itself. And then the third vector added with each of the other ones, including itself. You see? There you go. All right, and it's working as expected. So remember, the big idea here is when you have a custom type that you've made, it may be necessary to overload or basically redefine the meaning of some of the basic arithmetic operators like addition, subtraction, multiplication, and so on, because this context may dictate to do so the way it does here. In this video, we're going to learn about enumerations or lists of named constants, and we use them because it's easier to talk about, for example, Monday, Tuesday, and Wednesday than it is to talk about 1 or 2 or 3, correct? Somebody comes and says to you, today is 1, you would say 1 what? But if somebody says, today is Monday, that you understand, correct? So that's what I mean by a named constant. Alright, so it's more meaningful. So click up an HTML page, and here's put a drop down. So drag that in there. See? Alright, now, we're going to add some items to it. So go to design view, click it, click that arrow, enable auto postback so it refreshes from the server every time you submit it. Edit items, click add. So for the first one, we'll say Monday, click add. Tuesday, click add. And then Wednesday, and that's it. Click OK. There you go. So if you switch to source view, as you can see, that action has added these items to the source view. See? These list items have been added to the drop-down list. So that's the construct now. Alright, in design view, let's take a look. So that looks like this. So let's double click that now. That brings up the event handler for the selected index changed. And above here, we're going to say public, like this. enum, that's an enumeration, and then you're going to give it a name, and then you're going to specify the named constants and name them. So you're going to say Monday equals 1, and then you can say, for example, Tuesday, Wednesday, and so on. Okay? And in this context, close out the semicolon. These enumerations are usually meant to be accessible everywhere, so you put them outside in your classes, put them like the level of a namespace, for example. Alright, so it looks like this. Alright, now, further. As you can see, we can use this now. So to use it, here, because Monday is set equal to 1, hover your mouse over Tuesday. You see Tuesday is implied to be 2, and Wednesday is implied to be 3. Alright, if I set this equal to 0, now Tuesday is implied to be 1, Wednesday is implied to be 2, see? So the numbering is determined by the value that assign to Monday. Alright, the numbering of the other entries in the list. So at the next stage, within the drop-down list 1 selected index change, you will say switch. And you're going to switch on the drop-down and then selected say value like this. Alright? Now, if you have your mouse over selected value, that's a string, see? Alright, you can also do, for example, selected item, hover your mouse over that one. Now that's a little more interesting, right? That's more complex. It doesn't return just a simple string, you see? Alright. So that's how you can check what is returned. Always hover your mouse over it, and then it's going to give you some information, you see? Alright, so here's go with selected value, or if you want, there's also item. Alright. Now you're going to do case, and let's see, if you type Monday, see that? And if somebody selects Monday, the selected value is Monday. Let's take a look. In that case, you're going to say sample label.text equals, and we want the numerical value of Monday, so we will say $, and now you will say something like this. Monday is day. If you want, you can even do it this way. Take a look. You can say days, then Monday is day number, and to get the number, you're going to do INTI in front of it, and then days dot Monday, see? And then close this with a semicolon. Alright, and notice we need one more. We need to have a break, correct? That's it. Alright, so that's in the case of Monday. Select this code, Control-C it, and then Control-V it down below. And then just change Monday to Tuesday, like this. And then here, change this to Tuesday. See? So as you can see, it's easier to work with Tuesday, Wednesday, Monday than with numbers, correct? Numbers are not very meaningful. Numbers have to be given like a special meaning in the context. Monday, Tuesday, we know what that means. Everybody knows what that means. Like that, you see? And now here we're going to put also Wednesday, and then also Wednesday over here. Alright? So it's like this. Alright, and notice that in this one here, because we want the day, I leave it as it is. But in this one, I want the number, so I put the INTI in front of it to get the number out. That's how you cast to a numerical value. Change the form to show the numerical value. Alright, give it a go on Edge. Load it. Alright, let me enlarge this so it's easy to see. So here's Monday. Select Tuesday, you see? Tuesday is day number 2. Wednesday is day number 3. Monday is day number 1, and so on. See? There you go. That's working as expected. Alright. That's it. So remember the big idea with enumerations, list of named constants, and named usually for the simple reason that it's easier to deal with intuitive names than with some arbitrary sounding values like 1 or 2, because then you always have to ask 1 what or 2 what. With Monday, you know. Same thing, for example, if you had months, an enumeration of months, correct? You would do the same thing. You know what January is. If somebody said today is, what month is it? You would say 1. You still know that, but then imagine somebody says it's month 7, you see? Then you have to think about that one a little more. There you go. In this video, we're going to learn about namespaces. So namespaces are basically used to construct logical hierarchies. Alright, so crank up a project. And this time, we'll crank up Visual Studio. Don't make a project just yet. We're going to make a new kind of project. So File, New, and choose Project on that website. And here, under Visual C#, make sure you choose Class Library as I have it, like this, that icon. And then click OK. Here it might be helpful to rename it. Let's rename it. For example, here, Math Library, like that. And then click OK. Alright, so this is our namespace. As you can see, Math Library. This is, of course, collapsible. And within it, we have a class called Class 1. Alright, so let's rename this class from Class 1 to, we'll call this one the Basic Math class. Alright, and then we'll make one more class. Public class, say, Financial Math, like that. You see? Open, close curly braces. And we'll make it simple. So within the Basic Math class, we're going to place one function. Public, double, add. Okay, and then we'll say double x, double y, and then we'll say return x plus y. That's it. Within the Financial Math class, we'll say public double get interest, like this, and then interest is usually calculated on some amount of money. So for example, we'll say we should deal with decimals, right, when you deal with the money. But for our purposes, just to illustrate the concept, doesn't matter that much. We'll go to doubles. So double, we'll call this the principal, and then double rate. So then the interest is defined as the following. We'll say return the principal times the rate. That's how you get interest. All right. So here we have a namespace. Within that namespace, as you can see, we have two math classes. So Math Library and Basic Math, Financial Math. Each of those, as you can see, stores a function like this. And everything else that we've learned previously could be put inside these classes and so on. So this is the basic hierarchy. Now, remember we made a class library, right? So if you expand class 1.cs, you can see there are two different classes in there. And then those are the methods that are available inside each class, you see? And those are the signatures of the methods, like that. Now, when you build this, click Build Solution, Control-Shift-B. Notice that this generates the following, where I'm tracing. At the end it says DLL. This generates a dynamic link library, which is basically, as you see here, a collection of classes inside a namespace. And to make use of it, we will do the following. So you're going to right-click, make sure you copy that path. This has already been built, so now we have it. So close this, File, Close Solution. And let's go to File, New, Website, as before. Choose a template, click OK. Here, open Default, like this. And let's get 2 text boxes in there. So we can add some numbers. So we'll say text box 1. Let me close the Solution Explorer. And let's do one more text box. Alright, that looks like this. So in Design View, we have 2 boxes. Alright, let's name them. So this will be value 1 as an example. And then the next one here will be value 2, like that. And then let's add a button that will actually find the sum. So let me delete this, like that. Put the button in there. Mr. Button, like that. Put the BR in there to break down to the next line. So simple interface as usual, correct? So change the button text so it's more meaningful. Call it add, like this. Alright. And because we want to make use of both of them, say we can also find an interest. So we'll do one more box here, just to see that we can. So do the text box like this. So this will be principal to be invested, like this. Put a BR in there. And then the rate of investment, like that. So like that. Go to the end, put a BR in there. There you go. So now we have a new button that will be labeled Find Interest. So we named that to Find Interest. Put a BR after that. See? Alright, so in Design View, we've got an Add button and that. Alright, so when you left double click the Add button, this is what we're going to do. First of all, we don't need the page load yet. There you go. See where it says Using System? Below that, we will type Using. And now if you just try to use the math library, it doesn't work. You see, it's not accessible. So, to make it accessible, go to Solution Explorer. See where it says bin, right click, go to add reference. Alright, and if you see where it says browse, recent, okay, click browse. Here, paste that path, delete the DLL if you want. Alright, hit enter, and you see now there's a math library.dll. Click OK. Make sure it's selected here, math library.dll. Click OK, and that adds the library, see? Like that. Now we can make use of it as follows. Up here now we can type using, alright, and then math library as a namespace. You see that? Now it's accessible. And now, remember button 1 is the add button that we left double clicked. So we will say here basic math. Notice that shows up as a function from the math library namespace. So we'll call this BM equals a new basic math object like this. And then you can type, of course, BM. Let's do samp label. And then the text equals. And you want to find the sum of 2 values. So of course, we can now do that as usual. See? There you go. So we'll say BM dot, and notice that add shows up as a function on the basic math object, and double x double y. So of course we can say double to parse like this. Text box 1 dot text, comma, and then of course you can say double parse, and then text box 2 text. All right, close all of that. Make sure the parentheses match. Close with a semicolon at the end, and that'll display the sum of those two values from that math library. Basic math. Yeah, that's that. And now, find interest. Left double click on that. And of course, here it's pretty much the same logic. We'll just take this code, Control C, and then Control V down below. Rename it, of course, to the following. This one will now say financial math. We'll make a new financial math object. Like this. There you go. Of course, these methods, they could also be static methods. So you could type financial math dot and then, find interest or something like that. All right. That's another option. So here, we'll say now, I will rename this to FM. We'll say FM like this, and then dot, and then of course it says here get interest as the function. So the interest will be on the principal, so get that from box 3. Apply the rate to it, which is in box 4. And that's it. See? So these are the basics. All right. Let's go on Edge. All right, so if I enter here a 1 and a 2 and I hit add, it says 3 as you might expect. If I enter, say, 456, 0.85, that's a little too high, make it 0.085. Find interest, and it's going to find the interest, you see that? And so on. So it's working as expected. Add, and you can find interest. There you go. So these are the basics. Remember, big idea, namespace, groups related functionality together. Inside namespaces, you can place even other namespaces if you wanted to. And then, remember, that was when we did using system.collections.generic. You see that? System is a namespace, collections, and then generic, and so on. You see, so you can even nest those. In this video, we're going to learn about structs. Structs are usually used to represent simple composite objects like a point, where you basically have an x and a y coordinate, and the idea of structs is that these are value types, not reference types. All right? So here, let's make a project. And once you have the project, let's add a class file. And all we will do is put the struct inside this class file. So to say this here, simple struct like this, like yes. All right, so here we're going to make a really simple struct called point. All right, so you can say here public. In fact, you can delete this and you can just say public struct like this, point. All right. You can still define a couple variables to represent the point. So. And properties also. So, for example, you can say public double and then x, and then you can still do one of these, get and set. You see, public double y, and then a get and a set, like that. You see. And you can also initialize them, so I can type say public point. So you can still have a constructor, and then we'll say here double x and double y, then you can set the values inside the constructor of the properties. So x equals little x and big Y equals little y, like this. Alright? So that's that. Alright, so this is the basic struct, like this. Remember, it looks superficially similar to a class, but internally it behaves differently because it's a by value kind of object, okay? When you make copies of it and so on, not by reference. So next we're going to make use of it. Go into default.aspx, and here we're going to put a button. Alright, so button, there we go. Alright, put a BR in here after the button. Change the text on the button to something different. So for example, let's say here, make and show points, like this. Alright, so you're going to make and show some points. Alright, let's delete the centering of the text. We don't need that. So really simple. See, one button. Switch to design view. So one button and a label. That's it. So let's double click on make and show points. Alright, this is the event handler. So here we are going to do the following now. We'll make an array of points. So you're going to type point. That's the struct that we made, like that. And you can say points as the name of the array on the right side. Now you can say new point array. See? And specify the length as 10, for example. And close that. Now, we want to fill the x and y coordinates of each point. So we are going to do this. We'll say for, like this, inti equals 0, I less than points length, and then I plus plus, open close curly braces. Now at the next stage you're going to type the following. Alright, remember the objective is make an array of points. You can say points at I, and you're going to say new point, and now you need to initialize the x and the y, and you want to make them random also. Alright, so the thing that you can do is this one. You can say the following: new random, see that? Dot, and then say next, like that, you see? Now notice that this has several versions, and one of them is the integer minimum value, max value, say from -10 to 10, and then repeat that for the next one. So a new random, like this, and then object dot next, and then from -10 to 10, closes to semicolon. Alright, we'll take a look at whether this works in that momentarily. So, with that in place, and this should say points, like that. Once we have them generated, of course, we can display them, so we can use a for each. So for each point p in, like this, points. There you go. We can display, so you can say sample label.text. And now we're going to make use of the properties that we have there. So we want to show the point as we would see it in a book. So you're going to put a parentheses, and then you're going to put that symbol, and then you're going to put p.x, and notice the property shows up, and then comma, and then parentheses, curly braces, p.y, see, and then closes with a semicolon. There you go. Alright, so let's take a look at the effects, whether this is what we really want. So crank it up an edge. So, and then new random makes an object, the next function gets a number. And that's how you can initialize the x and y coordinates of each point. So give it a second here. Alright, hit that. And there's an obvious problem, which is, notice that all of them are the same, right? That's not very random, so we have to fix that. So take a look. The way to do it is, imagine here you put the following. You're going to say using system.threading, like that. So let's take a look. As the loop runs, to ensure that there's a bit of space between the time the points are made, we can say something like, for example, thread.sleep, and then you can specify an amount of time in milliseconds. So for example, make it 1000 milliseconds, which is 1 second. So it will sleep and then resume, you see? Alright, so hit it again in Microsoft Edge. Alright, then now this is going to take a little bit of time because it's, as it runs, it sleeps a little every loop. And we'll see whether this is sufficient. See, now, as you can see, the points are a little more random. See that? And that's what we want. So here, there you go. It looks like that, you see? So this is the basic code. And again, remember, a simple struct has the struct keyword. You can still use properties, for example, with the getter and the set. These are the auto properties. You can still write a constructor like this one. Alright, and then you can make an array of points. And also we've learned now how to make a new random object, and then how to generate a value between -10 and 10, how to ensure that we don't want them to be the same all, so make sure that you put something like thread.sleep for 1000, that means 1 second. That means that's enough time so the numbers generated are unique, as you saw there, they're different. And then you can still again use a for each loop to access the x and y coordinates of each point and then display them. In this video we're going to learn about delegates. Delegates you can think of as function wrappers. They basically are ways of representing functions and then stacking function calls together. So here, click up a project, and what we're going to do is the following. I'm going to put a button in there first, like this, and then put some label in the button like update, like this labels, alright, with new times. Right, so this is the button. Now under the button we're going to put labels. You can keep the one that we have there, add a couple other ones. Alright, so change this label name here to say main label, like that. And then over here you're going to make more. So label, put that in there, like that. Should double quote that. Alright, so here we'll call this label 1. And then let's do one more label here. Again, make sure you get BRs unless you don't want them. Alright, let's take this. Control C, Control V down below. Alright, let's rename this label 2. And the main label. Alright. So in design view, that's all we have. See, that's really easy. Alright. Again, if you want, you can also get rid of these label texts, so nothing shows up by default when you launch the page. So it looks like this. Alright, so in design view, it's that. Alright, left double click and update buttons. And here, to make a delegate, you're going to write this above this class. You're going to say public delegate. See that? That's a keyword, it's blue. And then void is the return type, and you're gonna, call it a name. So for example, we'll call it like this, label updater or something like that, and then close this with a semicolon. See? So this is a delegate. It's public accessible anywhere. Delegate is a keyword, void is the return type, and label updater, like this. And this thing basically would be used to represent several different functions. Alright? So in our case now, specifically, inside the button 1 click event, we're going to write some code. So stage 1 will be to write the following. Actually, let's do it this way. Go outside here. First you're going to say public, and then make sure you put void. Alright? Because the methods that are called through the delegates have to have that same void as we have in the declaration of the delegate. So public void, and we'll say here update label 1. So that means we'll now type samp. We'll say label 1.text. We'll update that with the current time, which you can type by doing that, and then date time.now. Just do the date now, that's all. And then to see the effects of everything more clearly, let's make this sleep, so things slow down for us. So to do that, you're going to type using system.threading, and then under here you're going to write the following: thread.sleep, and then again stick in a time interval, say 5000. That means 5 milliseconds. I'm sorry, 5 seconds. So 5000 milliseconds is 5 seconds, like that. 1000 milliseconds is 1 second. Alright? And that's it. Now you can repeat this a couple other times for the other labels. So do that, paste that down below. The next one will be update label 2. Do that. And again, change the text to label 2. The rest of it is the same. Let's also do it one more time. So public void, and then this would be update the main label like this. And again, here, let's put that, you see? So, labels, finished, updating at, and that's it. Alright. So remember, in this context, the thread sleep is only to exaggerate the effects of time, so they're more visible. Alright, now, to call update label 1, update label 2, and update main label, we can do this with the delegate as follows. You can make a delegate inside the button click event. Right, you see? We'll call it LU equals, and now, to assign something meaningful to it, you can just write the name of a function, like update label 1, you see? So, update label 1, and then further you can type LU plus equals. You can stack the function calls together so they're executed sequentially after only one button click. So now you can, for example, say here update label 2, see, with the plus equals. And then if you want, you can also do LU plus equals. And another way of doing this, instead of just writing the function name, is to write new label updater and then specify the function that this is to wrap, like that. So you see where it says void and then target. So now in case that would be update main label. Update main label and closes to semicolon. See? And then at the end, to make it work, what you can say is lu.invoke. Invoke the delegate. Make it work. Alright, so this is our code here. Alright, so crank it up now, that's it. An Edge. Give it a second to load as usual. Alright, so we have that. Let me bring this up. It's bigger. Okay, I'm going to hit update label. You have to be a little bit patient because remember, we specify time intervals, sleeping times, to exaggerate the effects of time a little. See that label's finished, updated, okay? So here let me just fix the formatting a little bit, like that. There you go. So here, to make everything more clear, let's put the BRs in there. That never hurts. And of course, if you wanted to, you could also do this with the same. Let me call this one the main label there, okay? We could do this all with the same, like that, label, and just put in BRs. All right, that's fine. This is perfect. So take a look, crank it up again, exaggerate the time effect. There you go. See that? So clearly now, because of the sleeping times, you see this one was updated at that time, and then that time, and the last one here displayed at 5:11, right? And so on. You see that? There you go. So these are the basics. Remember, the idea here, let's not forget the point, which is that we have a delegate, like this, public delegate void label updater, like this. And then you can make an object of that type, as you can see, to type. Then you can assign different functions to it. You can stack the function calls together. And then lu.invoke will call the functions for you one by one. First this one, and then this one, and then this one. You see that? There you go. And that's how you can chain function calls together through delegates. And these delegates are used heavily in Windows event programming. And that's it for this one. In this video, we're going to look at the basics of making a simple generic class so that one class can operate on many different data types. A great benefit of generics is flexibility. Alright, so crank up a project and let's go here to Solution Explorer. Right click, go to add class, and now call this one here generics class, like this. Alright, simple generics class, click OK. There you go. Alright, so let's add this class. Now, yes, we're going to do the following. We don't need any of this really for our purposes. See where it says public class, generics class? After that, you're going to put this kind of symbol, T. This means that this single class can work equally well with several different data types. Alright? So in our case, data type will be this one. You type private, like this, T. See that? And then vals. So in this case, we are creating a generic array instance variable like this, you see? So in other words, this will operate equally well on doubles, on decimals, integers, and so on. Alright, so here we're going to say now T, like that, and then you'll call it input. So as you can see, you can also make parameters that are generic, like this one. See that? Alright, this is a parameter. Input is the name of it, and then the type is T, so it's a generic array. Alright, then you're going to take vals and set it equal to input. Now, of course, you should be able to display these values, right? So now we can say something like public, say, string display values, like this. And to do that, you're going to do the following. So for each T, little t, in vals, you're going to do the following. Put a string in here. You'll say string str equals null. So declare a string, initialize the value to null. Alright. Now the next, as you can see, the for loop here is going to operate. That t will be a different data type depending on how we choose to, make the object in a minute. Like that. The little t, of course, is each specific value inside the vals array. Alright, so then you're going to say str plus equals to accumulate. You're going to throw in the br to push down to the next line. Put the dollar symbol here. And now you will say value equals. And to get the value, of course, you'll put in the little t. Close this with a semicolon. That's it, you see? And at the end, you want to return this. You will type return str. Alright, so notice that we have a single block of code. And this will operate now on integers, doubles, and so on. Alright, so take a look. It's by default at ASPX. The only thing we really need this time is a button. So go to the toolbox, grab a button from there, drag and drop it in. Alright, put the BR in there. Alright, delete this one here. Delete that one. And change the text on the button to, for example, say display values. Alright, so in design view, this is it. Simple, very simple interface. Left double click the button. Now delete this. And here, we're going to type generics class, and now take a look. You can, for example, type int. Okay? And then you're going to say ints as the name of it, and it's going to be a new generics class with integers. And now to initialize it, you see where it says int inputs. Now you're going to type new int. And then initialize that, so you type some values there like this. So in this case, as you can see, we're initializing basically a collection of integers through the array there, you see? Now you can display this. So for example, you can type sample label.text plus do equals, and then we'll say ints dot display values. Alright? So notice the generics class here that we have constructed is operating on integers, but it can operate equally well on any other data type. So basically now, take a look. To make the code efficiency more obvious, take this whole thing, paste it down below, and just change it to double, like this. I will call this dubs, like that. Alright, change the name here to double, like that. And it's the same code, the same class, the same generic class here can operate on the doubles. And again, to emphasize it one more time, just so to see the flexibility and code reuse, that's really the purpose, right? The ability to reuse code. Right, change this integer to say now decimal. So a new generic class that will consist of the list of decimals. Like that, change the name in here to decimal like this. And then let's change this to dex like this. That's it. See that? Alright. So here, if you wanted to, of course, you can, throw in some decimals, make things a little more interesting. There you go. And with this one, throwing some decimals, just make sure you put the M in there because these are decimals, so you need the M at the end to indicate it's a decimal. That's it. So now take a look. When I run this code in Edge, for example, Seinfeld is a good show. Hit display values, and you see that value. See that? There you go. Now, what we're going to do, of course, is accumulate the input. So here, as before, type plus, and then type plus equals, like that, you see? So we'll run it one more time. See that? There you go. So the values are showing as expected, working as expected. There you go, there you go. So the big idea of generics at this point is you can define a generic class. This class can operate equally well on many different data types. So, for example, if I make a generic class here, it operates on integers well, or on doubles, or on decimals, and so on. If you wanted to, of course, what you could do is, not that this one is strictly required, but let's give a little bit of additional insight. If you set a breakpoint and go step into, under debug, F11, and you hit display values, I look very carefully. See this? So we're going to go through it, right? We don't need this here. Alright, so you first, it steps into it, hover your mouse over T. Alright, and the T is essentially like a parameter, so it does have a certain value. See that? And the first time T is integers. See? There you go. And that's how you can also step through this code the usual way as before, like that. And as you can see here down below, as you can see, those are the values inside the array, right? That little t, as you can see, is an integer, like that. And that's how that's operating, you see? And notice first also that it's a generics class with an int. There you go. And that t here, that t right now represents an integer, and so on for the other data types. There you go. So flexibility of code and reuse of code, which means you write less. In this video, we're going to learn about generic methods, or methods that can operate in different data types, and then we will also learn about constraining a method. All right. In terms of the data types that it can operate on, so we'll add a concept called constraints. I'm going to have a project and leave the HTML. The only thing to put in there is a button. This time we will not read any values from the user just to save time. Change this text on the button to say exchange and compare. So this will exchange two values and then compare them. All right? So a common thing to write might be a swap function, a function that swaps two values. So to do that, go to Solution Explorer. Right-click the name of the website, go to Add, Class, and then change this here from Class 1 to like this, okay? Generic methods. We'll call it gen methods. Keep it simple. There you go. Click OK, click Yes. This has a class called gen methods, like this. Alright. The only thing you should leave there is using system. Alright, we don't need a constructor for this class, so get rid of that. Alright, and then within the body of gen methods, we'll define the following. Public static, like this. So it's going to act at the class level. We don't have to make an object of type gen methods. Public static, and then we'll say here void. And then you're going to swap, and after the swap, we're going to put a t. See, and they're going to put ref tx and ref ty. Open close curly braces. So in this sense, the only thing that is new here, we have not seen before, is the fact that this is a swap t, which means it can act on several different data types equally well. All right, now, and again, remember that the ref keyword indicates that the parameters here, like that, x and y, when I change the values inside the method, those changed values are accessible inside the calling code also. All right, keep that in mind. So here we're going to say the following. To do the swapping of the values, you can say the following. And here let's actually label this, right? So this basically means method can operate on multiple data types equally well, right? That's what it means, right? So you can say ttemp equals, you can, for example, take the value of x, all right, or y. You can use a couple different ways. Take the value of x, assign it to the temporary one like this, all right? Then what you can do at the next stage is take x and assign y to it, and then you can take y and assign temp to it, you see? So first, save x, meaning x equals y now means overwrite the value of x with the value of y, right? So assign y to x, and then the last stage, assign temp, which is the original value of x, back to y. Assign original value of x back to y, like this. All right, that's the switching of the values. All right, let's do one more method here now. This one will be a little more sophisticated, and let me bring in the code. I made some code earlier. I'll comment that out. So this one will be called compare. It's going to operate on different data types. You're going to say public static string compare, and then t, and then tx and ty. And now, to compare values, we want to use the compare to method, and that one can be used if you have the following, where t colon is I comparable. See, like that. That's a new construct there. That's a constraint. So that the compare method works, but it works only if the data type it's operating on has I comparable implemented on it. See? So in other words, it makes sense to compare the values. Alright, so it looks like this. Now, next stage. You can say this. If x compared to y is less than 0. Now, why would I write this? I would write this because the compare to method, if you right click on it and go to the definition of it, see it's defined inside the I comparable interface. See that? So now if you expand that, if you look at what it returns, it says values meaning less than 0. This instance precedes object in a sort order. In other words, in our context, that means that x here, right, and y are related in the following sense. If the value returned by compare to is less than 0, then x is less than y. Alright, that's what it means. So to that, you can say now return a nicely formatted string, so it's more than just a simple comparison. You can say, for example, here x is less than y. See? Like that. The other possibility is the reverse, so you can say now else, and now you can say, for example, return, and then again put a dollar symbol, and then here x greater than y, see? And then close this with a semicolon like that. Alright? And if you want to know more about compare to, of course, right click, go to definition, read specifically here. See this 0? This instance occurs in the same position in the sort order as the object. Greater than 0, this instance follows the object in the sort order. There you go. So, like that. So, this instance means the x, and the object means the y, and it works like this, you see? Alright, so this is the basic gen methods class. As you can see, a couple of generic functions. Alright, because they can operate on different data types, except for the second, compare to, which is a slightly more restricted version, meaning a constraint is applied of type I comparable, like that. Alright, so now here we have the button, so go to design view and left double click on exchange and compare. And all we are going to do is hard code the values to save time. We don't have to read them from the user. You can, if you want to, input two boxes and then process that using double convert if you want to. Alright, so we're going to say here double x, say, is 25 and y is 34, like that. First, let's display these. So same playable.text, display the original values on the screen. So first display the value of x, and then display the value of y, like that. Alright, and now do the swapping of the values. You can say gen methods, name of class dot for member access, and then the function which is swap. And you see t now can be replaced with double because we're swapping doubles. And then you're going to put ref x and ref y like that. And because we are using ref, the values of x and y have to be initialized, and further now we can display them again. Swapped. See that? So let's take a look at the effects first to be sure this is working as expected. Alright, and for the second stage, make sure you put a plus equals there. And a BR also, right? And in fact, we get methods.cs. For these output, here's put BR also. Or is going to put them on a single line and make it look messy. Like that, you see? Alright, and then default.aspx and source view, just get rid of the center alignment, not necessary for our purposes. See? Alright, so give it a go, an edge. Alright, exchange and compare. Alright, so I do have to add a break, alright, after the button. So as you can see, x is 25, y is 34. After we hit exchange and compare, x is 34 and y is 25. So this is working as expected. Alright, here we are. Now, next stage, go back to default.spx. Let me add that to the button here, like that. Next stage in design view, we're going to compare those values also, okay? So we'll say sampleLabel.text plus equals, and now remember the way we designed compare, it returns a string that returns, one of these or this one depending on the specifics. So here we will now say gen methods dot compare, and you're going to compare doubles, so you put that there, you see that? And then the two values, so that would be x comma y, and close with a semicolon. There you go. And again here, yeah, this will be good. Let's give it a shot. An edge. Alright, exchange and compare. So x is 25, y is 34. And you exchange the values. Now x is 34, y is 25. And further, 34 is certainly more than 25. See, there you go. So it looks really nice and professional. Alright. So that's that, and that's that, and there you go. And of course, the nice thing is now, imagine you want to redo this. You can just type int as an example. See that? And just change the data type to an integer type or a decimal type. And the methods, the functions, the code that we have here operates equally well on these things. And the only thing is, of course, here you also need to put the integer. And if you right click on int and go to definition, you see it says public struct integer 32 and it implements comparable. So that will work with the fact that our function has a constraint where it says t should be comparable. And these are the basics. In this video, we're going to learn about upcasting, downcasting, and then how to implement a generic interface. Alright, and how that exactly helps us. So, imagine you have a list of objects that you have made of your own type and you want to sort them as an example. Alright, so we are going to figure out how we can sort objects that we have made ourselves in some fashion, sort them. And that comes from implementing comparable, a generic interface that can act on different data types. Alright, so here we're going up a project, and the only thing that we would put here is a button in HTML, and the button will say sort and show. That's it. Alright? Now, let's put a BR in there. Keep the label as usual. So, design view, sort and show. Alright, Solution Explorer. Right click, add, as usual, class. You can even call it class 1 if you want, but we'll call it, say, for example, like this, gen interfaces, or interface. Okay, so for generic interface, click OK, click yes. So remember, it's just an example. All right. Now, this code is realistically complex, so what we're going to do is, I would not try to remember this, it's too much. I'll pull it in. I made it earlier. I'll comment it out and recreate it line by line, explaining what I'm doing and why I'm doing it. So first we need using system like this. All right. Now, then you're going to make the class called quad, public class quad, like this, for a four-sided shape of some kind. Now you're going to put the colon, and then you're going to put iComparable. You see how it shows up? Then you're going to put after that quad. So we need system, so we can use iComparable, like that, all right? If you right-click and you go to the definition of this thing, as you should, see it's namespace system, and a function that it has in there is this one, integer compared to. So notice that it returns an integer, all right? So when we implement this interface, we have to keep that in mind. Let me close it. So in our particular case, it's going to look like this now. So we have our public class quad, now outside the curly braces, and now we're going to say private string name like this, and then we'll say public quad string NA, set the value, so we'll say name equals NA, like that. Because after all, every quadrilateral shape, every four-sided shape, which is a square, rectangle, rhombus, they all have a name, don't they? Right, so it's a good idea to centralize the name feature in the quad class. All right, next, because this thing here has a function, right-click, go to Quick Actions, and then choose Implement Interface. So now we have to write code. All right, so delete where it says throw new not implemented exception. All right, delete that. And what we're going to do is the following. We'll implement it in a way that's sufficient to illustrate, our point. So we'll say this. If this.name.compared to, this means the current object, all right? And the name of this object compared to other.name, like this, meaning the other object. You see that? We see where it says quad other. So we're comparing two quads, in other words. So the one on the left, the this means is the one on which the function is being invoked, and the other is the one against which it's being compared. All right? So if this is less than 0, like that, we will return a number like -1. Else, we can return some other value, okay? So we'll return 1, like that. That's it. So we have just implemented compared to, like that. Now notice that this is not necessary. You see, you can remove it and it will still work. But then remember that name means the current object on which compared to will be invoked, essentially. All right, that's why I like to have this present, because to me it's more suggestive of what I want to know. All right, so basically what this is saying is, if the current object here, right, compared to the other name there, is less than 0, then return -1, which means basically that the current object will come before the next object in the list when we sorted. All right, a simple interpretation. Now, let's delete this. Next stage. We're going to add a virtual function called perimeter. So we'll say here public virtual string perimeter, and then open close curly braces. And again, we're going to centralize as much as we can, so we'll say return $, double quote, and then the perimeter of, put the name within the curlies, is, and then close with a semicolon. The rest of the specific name, okay, and the perimeter, specific name can come from here because the name instance variable is declared in this class up here. See that? Private string name. But the perimeter will come from the derived classes. All right. So now we're going to say public class square like this, and derive from quad like that. You see? Open close curly braces. Now we add refinements. So private double side length and then public square. So string n for the name, and then double s for the side. Call the base class constructor with the name, and then side length equals s. That's it. I've chosen to express this as a single line just to save space. All right. Remember, normally that means it would look like something here. Okay. That curly brace will go down below. You see. Now we have to implement an overridden version of parameters. So we'll say public override and then string and then perimeter. Now we want to keep return base.perimeter because it provides useful default functionality right here. We don't have to keep typing that, right? So you want to keep that. What you want to do is add a small refinement, which means 4 times the side length. Because to find the perimeter of a square, you take 4 multiplied by the length of one side. That's it. All right, so refinement comes from the derived class. Generic functionality that's equally applicable to all the classes. You stick into a virtual method in the base class, so you don't have to keep writing it. All right. Next, we can repeat this for a rectangle. So Control C and then Control V. All right, so we'll rename this to rectangle. That derives from a quad also, so that's fine. All right, change here where it says side length. We'll call that, for a rectangle, got 2 sides, so we'll say side 1 and side 2, and they're different usually for rectangles. I'll call this here rectangle also as the name of the constructor. String n, all right, call the base class constructor with the name, and then initialize the other 2. So now you're going to say double s1 and double s2, and now we'll say the following. So you have to initialize the fields. Now we'll say side 1 equals s1 and side 2 equals s2. That's it. They've been initialized. Now, again, override perimeter inside class rectangle, return base up perimeter, and then specify the bit that applies to rectangle. So 2 times side 1, like this, plus 2 times side 2. Make sure you enclose this within parentheses so the calculation is done first. All right? And then it's combined together with base.perimeter with the rest of it. So that's that class. Now, let me delete my reference code. And this code is mechanical. There's a lot of it, but it's mechanical. And the big idea here is, remember, iComparable is being implemented using the compare_to method inside class quad, like this, which means now when we stick different shapes into a list of quads, we will be able to sort them some fashion. All right? So now our names will be sorting, in our case, we'll be sorting them by name. So go to default.aspx, design view, left double click, sort and show. All right, and then let me delete this. Looks like this. So first thing is, I'm going to put a quad on the left side, and we'll call it SQR. And now notice the following. You're going to write here, new square. This is upcasting. This is converting, you see the object on the right side, because it's derived from quad. You can make on the left side a quad, on the right side put an object that is of a derived type. All right, so we'll call this one here square, and then side length 4. Again, quad, and now we'll say RECT equals a new rectangle this time. You see that? Give it a name, so we'll call it rectangle, comma, and then we'll put in the 2 sides, say 2 and 5. See? And now you can store this in a list, for example, so you can sort the list. Imagine you had many of these. You see, you need a way to sort that information. So now we will say here, come up here and type using system.collections a generic, and then here list of quads. All right, so we'll call this LST equals a new list of quads. To initialize the list, you can always use an array. All right, so to do that, you're going to type new quad, you see, and then initialize it with SQR and RECT. That's how you can always initialize a list with an array. And then you can sort the list. Now take a look. lst.sort. See this? It makes sense now. It doesn't give an error. If you don't have, imagine if you don't have that there, okay? This sort would not work. So take this here, comparable quad. All right. And then if you took this compare to method out, we would have problems, okay? So for our purposes, now we have a way of sorting these quads. All right, and now that we have this, we can sort them, and then the last stage would be to do the following, all right? You're going to say the following. If shapes, or rather LST at 0 is a square, so is a new keyword. You see, you can check whether something is of a certain type. See this? If LST at 0 is a square, if a square is there, you can say sampleLabel.text plus equals, for example. All right, and now we're going to talk about downcasting. That means going from like a parent to a child type. You're going to type square in front of it. Now you'll say here is shapes like this at 0. See that? All right. Actually, this was list, so put an LST in here like that, and then dot perimeter. Close with a semicolon. You see? Else, for example, if at list, inside the list at index 0 is a rectangle, so you can say LST at index 0. If that is a rectangle, like this, then you can call the following code. Paste it down below. You see where it says square? So change that to a rectangle, so it gets cast down to a rectangle, and then the perimeter function on a rectangle will be called. You see? String square perimeter, string rectangle.perimeter. If you remove that, see, now it says quad perimeter. Do you understand? That's why it's important. That's why I have the cast, because it changes the way the functions are recognized. You see that? There you go. So here we will put now a rectangle. All right, that's downcasting. So from a parent to a child class. All right. So when you want to talk about bulk actions, you can upcast to a parent class, perform a bulk action like a sort. And if you want to add refinements, call child classes, then you can on child class objects, and you can downcast. All right, let's take a look. Otherwise, you might ask what's the purpose of it, correct? That's always a good question. So sort and show, the perimeter of rectangle is 14. That's it. That was a rectangle. All right, so these are the basics of upcasting and downcasting and implementing a generic interface like iComparable. So real code, but I hope you've learned a lot. In this video, we're going to learn about generic delegates. So creating a project, this is the basic HTML, and leave that. Let's add a button, and the only thing the button will do is summarize some information for us. All right, and close this with a BR, and that's it. So one button on interface looks like this. That says summarize. All right, left double click the button, delete this, and first let's make this delegate. So up here, you're gonna put the following: public delegate void, and now we will say something like, for example, to make it more powerful, we will say summarize, put a T in there, and then you'll put TX and TY, and then close this with a semicolon. So first notice that public accessible anywhere, delegate is a keyword, void doesn't return a value, name is summarize, and it can act on different data types because the T is present and not integer or double or something like that, okay? This is a generic delegate. All right, now remember, delegates function essentially as function wrappers, correct? You use them to point to multiple functions, so you can cascade function calls, for example. So here, the same principle holds. Okay, so for example, to make use of this now, we can type something like summarize and then put an int in there for integer. You see, now we can give it some name like s, and now on the right side we need to start assigning functions that it represents. So to do that, we can say, for example, public void like this, and the first thing, imagine, is to find the sum of two values. So you can say, for example, find sum, and I can say double x and double y, and we can update the label, so we'll say sample_label.text equals like this, and then we'll say the sum, so x plus y equals, and then of course we'll add them, so x plus y, and then close this with a semicolon. See, there you go. So now we can assign the following. We can say find sum. See, you can set that equal. All right, like that. So you can assign find sum here to that side. All right, now because these are doubles, see how there's a conflict, so change the integer to double. You see, now it's fine like that. Right, but of course there are many other operations you can perform. So take this code, this basic function that adds, and define some other operations. So public void, say find ratio. So this time same plainable plus equals. Make sure it's appending. All right, and then a new line. So put a br in there, and now we'll say x divided by y. And now here we'll say x divided by y. See, like that. And of course here, you would have to ensure that y is not 0. You can figure that out. Let's do one more. So public void, and then say find product, which is the result of multiplying two values. And then here we will say x times y, and then within the next curlies, make sure x and y go together in the curly, right? Remember, if it's brown, it shows on the screen exactly as it is. And here, just put in the BRs, so this way stuff gets pushed down. Next line. All right, new line, and then let's do one more like that. There you go. All right, so now we have to stack up these cols. So then you're gonna say s like this, s plus equals, and now you're gonna put the next function name. So find ratio would be the next one. You see that? And then s plus equals again to add the next function. So that would be find product. See that? There you go. And then of course, we can call it. So you can, for example, type s and then double x double y, so 4,5, and close with a semicolon. See, that's how you would invoke that delegate there. That's how you would call it, specify the name, and then pass in those values of 4 and 5, like that. All right, now let's take a look at the effects. Let's launch it in Chrome, or rather, this is a good book, by the way, Outwitting the Devil by Napoleon Hill. Alright, let's make this large and summarize. So as you can see, 4 plus 5, 9, 4 divided by 5, 0.9, 4 times 5, 20. So it's working as expected. And there you go. So here, a single delegate, because it's generic and has t there and not a fixed data type like integer or double, can operate on different data types. So specifically, if you take this and say we look for all occurrences of double, all right, I replaced them with integer. 7 occurrences replaced. Run the code. See that? It works equally well. There you go. And just to illustrate, now imagine we replace it with decimal, like that. So replace those occurrences. Now it's operating on decimal types. And summarize, and there it goes. You see? So, generic delegate. Remember, you can basically, with a single button click, invoke a whole list of functions by chaining them together through the delegate s, which is of type summarize, which is generic, so it can operate on different data types equally well. In this video, we are going to learn about generic dictionaries. So these are known as key-value pairs. All right, so crank up Visual Studio. And all we are going to do inside the HTML is place one button. So drag and drop a button into the space. Change that text from button to show, like this. Okay, files. Let's do it this way, just show, that's fine. All right, now, delete that. And what we're going to do is learn how to open, for example, Notepad and Internet Explorer directly from a page. So now, go to Design View, left double click on the Show button, like that. Let's delete the page load. So it's like this. Now, I made some code earlier, I'll paste that down below. So again, I do that because I do not believe that memorizing things is a good use of one's mental energy. All right, so let me comment this out now. And here what we are going to do is this. First, we have to come up here and add using system.collections.generic because we're dealing with like this. See that? All right, and then one more using system.diagnostics. You'll see in a second why that is needed. That's how you can start a process. And the process, for example, refers to Notepad. So here within the button1_click, we're going to write the following dictionary. See that? Like that. And now the big ideas with dictionaries is that you have, where you see where it says T key, that means the type of key, and T value means the type of value. So in our case, both will be of type string. You see? All right. Now we're going to give it a name, so file programs like this, that's the name of our dictionary. Now we're going to make memory for it, so new dictionary of string type, and then close this with a semicolon. At the next stage, we're going to fill this dictionary. So you're going to say file programs like this, .add, and then you're going to specify the key and value pairs. So the key will be notepad.exe, and now, take a look. If you try to put a path like this one directly into your code, it doesn't work. You see how it gets underlined red? It says represents text. Those things there don't work. You see that? So to fix that, you put in front of this symbol there. Now you have a verbatim string. All right? So you don't have to. Otherwise, this is the old approach, this here. This is called character escaping. All right? Notice the little red goes away. Because this here already means something. To escape the usual meaning, you got to do that. See? And that's the old way, though. The newer way is to do that. Verbatim string. So it's interpreted exactly as it appears. So in this context here, this is the key, Notepad, and the value is the file. All right, next, there's one more. File programs, again, .add, like that. And then we're going to type here explore.exe, so this is Internet Explorer. And then you're going to put in http://www.bing.com and close this with a semicolon. You see, so it's going to open that page for us using Internet Explorer as the program. All right, now imagine we want to iterate over these keys, right? Because we have, potentially imagine many of them. So a way of doing it is this way. I can now type the following. For each, and now you're going to type key value pair like this. All right, and you're going to put string and string. Those are the types. We'll call this KVP like this, and file programs like this. All right, so you can iterate over key value pairs like that. You can now type process.start like this, and then display the key and the value. So you can say kvp.key. You see that's a property of the key value pair. And then kvp.value. That's also a property of the key value pair. That's it, you see? Then the realistic application, because a program could be missing or something else could happen, it would be better to put this in a try catch and so on. But for our purposes, to keep it short, this is sufficient. Like that, because I know that these programs do exist on my system. All right. So next, You can also iterate if you want over individual keys and values and so on. So as another example, you can do something like this. For each, like this, string, key in, and to get the individual keys, you can type the name of the dictionary and then the name of the keys collection. Type keys, you see that? If you hover your mouse over it, you see that? There you go. That's it. So that's how you can access just the keys. And again, maybe you want to display them, so you definitely can. You can type same playable.text. And then, of course, if there are multiple ones, you got to put the BR. And then to show the key, you can type key. Close this with a semicolon. Don't forget the plus equals to append. And the dollar symbol. And it looks like this, you see? Alright, and now change the name of the text property. It looks like this. Alright, so that is that. Now, we want to make sure that we have this file here, sample file.txt. Let's change that to just txt actually. So to do that in Windows, I'm using Windows 10, I will type CMD, which is short for command prompt, open that. That looks like this. And I'll cd dot dot, cd data, if I have it. I don't have it, so I'm going to make it. So I'll type md data, and then change into it. So you're going to type cd and the name of the folder, data. Now type dir, that shows you the list of files. Nothing inside. So to open a file in Notepad, you're going to type this, notepad.exe, and then samplefile.txt. This will make the file. See that? Then now it's asking you whether you want to make it. Say yes. And now we will say this is some simple text inside a file. Make sure you save it there. Control S. Then you can close it. Now take a look. To recall previous commands, just hit the arrow up. And now you see sample file.txt is present in the directory. Alright, that's that. So launch this in Edge now. Let's take a look at the results of our work. That's not Napoleon Hill. And hit show. You see that? And it's working as expected. So you can now launch Internet Explorer or some other browser, a process of some kind, directly from your page and show it. And you can open up a file if you want directly from a browser. And there's the listing of the keys. There you go. So that is that. Let me close this. There you go. So these are some of the basics of generic dictionaries and an example of what you can do with a generic dictionary. In this video, we'll take a look at the connection between delegates and lambda expressions. So, look up a project inside the HTML. We don't need that. And all we are going to put there is a single button that says show results. So drag a button into the page. Put a BR after it, like that. Alright, go to design view, left to double click on the button, and perhaps change the text on the button, so we'll say here, show results. I'll do a hodgepodge of things that just show different concepts. Alright, design view, show results. Alright, now, because there's a lot of bit of code, I will drag in the code that I made earlier, like this. Comment it out so it's inactive. And stage number 1 is we have to add the following. And instead of putting this, you could put this in a separate file, but for our purposes, we can also just place it here. So we will say public delegate to show you that you can delegate, and then BOL, and then compare, and then $x and $y, like this. All right. So remember, delegates are function wrappers or method wrappers essentially. And then we'll say here public delegate like this. And the double and the value here is multiplied, the name of it, and then $x and $y. There you go. So we have two delegates, right? One returns a boolean and the other one returns a double. All right. So next, inside the event handler for the button click, you're going to make two variables, $x, so that equal to 10, and say y equal to 25. And the first thing that we are going to do is type the following. Notice that once you have a delegate, you can make objects essentially of that kind. See, compare is the name of the delegate, and then comp. And now, to define a lambda expression, you're going to put equals, then a comma b, and then this will be mapped to the following operation. So you think of this as the mapping symbol here, mapping operator. It's going to be mapped to this operation right here, where a equals b, like this. All right. So comp, in other words, will allow us to check whether the two values are the same, and that happens at this stage right here where a and b are compared. So here, basically, a and b are the parameters, and the expression that is evaluated is whether a is equal to b. There you go. Now to invoke this, you can type the following: sampleable text, like this. All right, and then of course equals, and you're going to put a $, double quote, and x and y, like this, okay, are equal is, and now to invoke it, you're going to type comp and then pass in the x and the y. See? And then imagine, to show you that you can operate on this further, once you get a result out of it, you can convert it, say, to a string version and then all to lowercase, you see? So like that. Remember, this is function chaining, so it goes from left to right when it executes. All right, and that's it. Now remember, at runtime, when you pass in the values x and y, when comp x, y is called, basically this is the line that will be hit right there, the one I've just highlighted. The comparison will be made, and the value will be sent back. That's it. All right. Next, another kind. So you can also do the multiply delegate. You see, multiply, M-U-L-T, equals like this. And now here again we'll say a comma b. In the context here, notice that a comma b can be used and reused and so on. Okay, so over here, remember what I'm typing here, a, b, those are parameters, and you can use them and reuse them. They're local within each of these. It's local basically to this line. So then you can use it in another one like that. So a comma b, and then you're going to say here again, maps to an operation will be a times b, closes with a semicolon. There you go. All right, and now to invoke this multiplication delegate, this lambda expression that it represents, you're going to take Control-C and paste it down below the line from above. And again, it's the same thing. So this time we'll say x times y. All right, and then to append, of course, plus equals. And the next one is like this. And replace comp, of course, with mult as the name of our object. And again, to string like this, right? It's going to give back a number, so you don't need to lower. It's just a number like that. All right. And if you remove this, let's take a look whether that will work. There you go. See that? All right. Now, at the next stage, another thing that you can do is operate an array. So take a look. And for example, make an array of doubles like this, double array. All right, dubs array, we'll call it. And this will be a new double array. And then 1, 2, 3, 4, 5. Close with a semicolon. And now we're going to talk about actions. So type action like this. You'll see these. All right. Notice this is a delegate. So if you right click on action and go to the definition, you see this action, public delegate void action. So if you expand it, it says encapsulates a method that has no parameters and does not return a value. That's the essential key definition of an action in .NET. All right, you see it's right there in front of you. You can extend them, however, they can be generic. So now if you right click on action, this particular version, go to definition. This one does take a parameter. If you expand it, you see it says the parameter of the method is delegate encapsulates. So encapsulates a method that has a single parameter and does not return a value. There you go. So again, no need to guess. Right click, go to definition, or hover your mouse over it, tells you what you need to know. So in our case, the action will be this one, show double, like this. All right. Now, another lambda can be used to define this. You're going to put a little a there like this as a single parameter, and then a mapping symbol, and it's going to say sampleable dot text. You want to append like this to existing text. So you're going to type here plus equals, and then you will say br, and then you want to show the square of a. So to that you're going to type plus, and then a times a, and close with a semicolon. See, now remember the definition of actions, they do not return a value, right? In fact, if you type action like this, see, if you go through this list, take a look. to the ultimate one, number 16, it says encapsulates a method that has 16 parameters and does not return a value. None of them returns a value. Right? That's a basic feature of actions as they are defined here. But remember, ultimately, it's just a delegate. And then, for example, to make use of these actions, one thing that you can do is type for each, and then variable d in dubs array, open close curly braces, and then the next stage, to invoke the actions, you can name type show double, you see? And then pass in d, and close with a semicolon. There you go. So these are the basics. Let me delete my reference code. This is the heart of our program, 2 delegates, and then compare, multiply. Right, the delegate types being used here down here, and then lambda expressions, which have parameters and expressions like this one, and then this one, and then also this one here, you see that, are defined using those. So if you take a look in Edge at the results, so you see that 10 and 25 are equal is false, and 10 times 25 is 250, and then the squares are printed. There you go. So the only thing I really need to do is put the BR in there. That's fine. Alright, here, put a BR in here, like that. And that's it. Those are the basic results. Once you launch it now, show results, and everything is looking as it's supposed to look. See? Alright, so these are the basics, and I'll see you in the next video. In this video, we're going to learn about expression-bodied members and then lambda expressions that are defined by blocks of code. Okay? Alright, so think of a project, and what we're going to do is have a box, read 3 values from the box, and then find the maximum value. Alright, and do some other things, like learn how to convert from one array of one data type to another, and so on. So here, what we're going to do is type enter values and then put a text box to get the values. So view, let me get the toolbox. Alright, get the text box, pull that in there, close this with a BR. Alright, at the next stage, we're going to have a button. So get rid of this, BUTT, like that. And now it's here, put BR again. Change the text on the button to max, like that. Alright, get rid of the div. Alright, design view, that's all we have, box and a button. So left double click on the button. Now here, this code I would consider somewhat sophisticated, or perhaps, a little more challenging than a lot of the other ones. But it's the best way to grow and move forward. So what I will do is take what I have here and just delete it all and paste in the code that I made earlier, and again highlighted. Let's go through its construction line by line. Okay, I'm trust that at this point, once you've gotten through so much of the course, you're beginning to see what it takes to begin to program well, how much you have to know. So using here system like this, and then I will skip the rest of it. I'll just go down to the following. You're going to make a delegate double, and then compare values, and then double x and double y, like this. Alright, so you have a delegate that returns a double and accepts 2 doubles, so encapsulates functions that have that kind of signature. Alright, at the next stage, you're going to go with the public partial class underscore default, like this. Alright, so it's the system.web.ui.page, so it inherits from page as usual, like this. Alright, let's rename this to partial. Alright, open close curly braces. Now, at the next stage, first what we're going to do is define an expression member. So you're going to say double like this, and then from string to double like this, in a new way of creating functions. That's what this is essentially. So instead of putting curly braces, you can now just put something like a lambda expression, you see that? And then convert to double, you see? And it looks like this. Alright, and then the thing to be converted to a double will be the S. There you go. So it's more streamlined. It looks a little more modern, like that. It's an expression-bodied member. like a function. Remember, functions are members of classes. So at the next stage, you're going to define the button click there. Okay. So here, if you come back and you left double click, so he's going to stick it back into that. Yeah, it's pretty good. There you go. So next, a string array like this. You can say textbox1.text.split, and then you're going to split by character, which in this case will be that, closest to the semicolon, you see? Alright, that looks like this. Alright, now, and here, you can put a little c like that, it's fine too. There you go. Next, you're going to convert that array of strings into an array of doubles using a different approach. So you're going to say double like this, and then double vals equals, you can say array.convert. Notice there's a convert all method, but it's not so easy to use. You need to have an array you operate on, so in this case vals, and then there needs to be something called a converter object. See that? That's a converter, input-output converter. Alright, so we need to make a converter. You can say new converter object like this. Alright, and in our case we're going to transform an array of strings into an array of doubles. So now you're going to type string, which is the one you're converting from, and then double, which is the type to which you are converting. And this new converter really just wraps a function. So now you're going to say after that from string to double, like that. Alright, so from string to double wraps a function call. There you go. Alright, next. So this here will accomplish the conversion of the array in one line from one data type to another, like that. There you go. And remember, ultimately, of course, it's just going to grab each value and hit it with convert to double like this. Alright. Now, next, you're going to type compare values like this. Now, this is a delegate type. It's like a data type. You're going to give it the name compare values. And now you're going to define a new lambda that says xn, comma, x or yn. And then you're going to define the body of the lambda. That looks like this. And because this lambda will do several things, you can close the body of it within curly braces like that, you see? Alright, so then you're going to say this double x equals xn, and then y equals yn. So assign the values from the parameters, like that. So yn, that's right here, see that? That's where that is located. Alright, and then you're going to say return x, the following. If x is greater than y, then you'll return x. Otherwise, you will return y and close this with a semicolon. There you go. So this is an expression bodied lambda, and close it at the end with a semicolon, like this. All right, this lambda expression here spans multiple lines, not a single line. There you go. So you can, again, inline code. Just as up here, you can inline this function, you see? All right, so that looks like this. At the next stage in the process, let me delete this. What we're going to do is the following. We're going to compare values. So to do that, you will type static. Let's do it this way actually. Here. Sampleable.text. All right. And then you will say compare like this, values and list. And this will be a function that we create. You're going to pass in the following. The first thing will be compare values. All right. So in other words, when this says compare values, that means this entire block will be passed into the body of the function. We've never done this before. Right? You're passing around entire blocks of code. And then double vals at 0. This will be the first value, like that. Right? Control C, and then you repeat that for the other ones at index 1 and then at index 2 because there are 3 of them, so the indexes go 0, 1, 2. There you go. Now, next stage. Static double. Let's try that again. Move this up there. There you go. So static double like this. Compare values in list. And now you're going to specify the parameters. So the first one will be compare values. Now this indicates that A delegate can also be used as a type for a parameter. We'll give it the name comp first 2. And then you're going to do the double first, double second, and double third. So the 3 values to be passed in. All right. Next, we're going to type the following. So return like this. And now you'll do this. If third is greater than the result of comparing the first 2, so you'll say comp first and then first comma second. Remember, this here will run first, and it will return a value comparing the first 2. Right? Then you return the third. Otherwise, you're going to run comp first again and return the bigger of those 2, like this. There you go. So it looks like this. All right, and that's that. And here it's giving us a thing that says cannot implicitly convert type double to string. You know what to do, right? You can just type string, right? And that'll fix it, you see? There you go. All right, so it's a very sophisticated code. Crank it up in Edge, take a look at the results. But again, this is why programs ultimately end up making a lot of money, right? Because it's... Alright, so enter some values, say 1, comma 5, minus 3, find the max, and the 5 is found. Alright? Enter something fine like this. So imagine 1.01, 1.02, and 0.999. And the max is displayed as 1.02. There you go. So it's working as expected. So again, to review, because this is a lot of code here, right? First we declared a delegate. Then we can declare this expression bodied member. That's a function that's defined essentially with a lambda now. You see that? All right. Then we had an array of values that we made. Then we created this line here to convert the values from string to double type. Then we have an expression bodied lambda like this one. Then we have this function here called compare values in list that takes that lambda as an argument. And then it looks at the other values also. And lastly, compare values in list is where the magic happens really, because see, this one says if the third value is bigger than either of the 2 first compared, then you return the third value. But if it's not, then simply return 1 that is the bigger of the first 2. There you go. Now I know because I've done this before, so it doesn't seem like an easy thing. You must absolutely, at this level of coding, type it, run it, process it, and then you'll develop your understanding quickly enough. And these are the fundamentals, though, of making some of this stuff useful. In this video, we're going to talk about anonymous functions. So, pick up a project, and all we're going to do is this. Here we'll have a single button. So let's put a button in there, like this. Alright, that looks like this. Then you're going to put a BR in there, of course, and here just type show results, that's it. Okay, we're not going to get any text from the user. It will take too long here. So show results. Alright, and then we'll display some results to the user. So click design, left double click on show results. Alright, now I made some code earlier. I'll drag that in there. Comment it out. Alright. So let me delete this. So within the body, but outside button 1 underscore click, you're going to say private void show square like this, and then double X. And then you're going to put an arrow like this. You see that? That's an expression member. It's a function. In other words, it takes the form of a lambda. And samplable.text plus equals. And then you put the BR in there, of course, to push down a line, depending on when you call it and all that. But and then we'll return x times x. See? That's it. Alright? So as you can see, this is a very streamlined way of writing functions. Alright, now, within the event for the button, we're going to place the following code. We'll say list. And of course, we need to add namespaces. So let's come up here. So that using system.collections.generic and then using system.threading like this. Alright. Next we're going to say list double and then vals equals, now you'll say a new list of doubles and then you will initialize this. You can do this a couple of ways, but you can just write an array, so new double like this, and then 1, 2, 3, 4, 5, 6, 7, whatever, some values, doesn't really matter what they are. There you go, so this will make a list of doubles like that. Alright? Now, one thing that you can do is perform an action on all the values. So the way to do that is to type vals, the name of the list, dot, and then for each, and then show square like this, you see? This is how you can call show square in each value, alright? And notice that in this case, show square is named, correct? So show square represents this expression here. See that? So it's a named quantity. Now, if you want, you can also do stuff that does not involve names. For example, you can say vals dot for each, and then to have something nameless, you can type delegate in there, you see, like that. And then double X, and then define the body. So to do that, you can put a curly brace this way and this way. Alright, close it with a semicolon, and then define the logic between the curly braces. So this is a nameless one, anonymous. So for example, you can say sample label.text, and then plus equals here, and then br, and then plus, and then math.pow, x comma 3, close with a semicolon. You see? There you go. So this one does something similar as the previous one. The only difference is we're not calling anything named. Right, we're just defining an anonymous function, a nameless function like this. Alright. Using a delegate keyword there like that. Alright, and this does accept one value though, of course, right? The x. And then you cube the x because that's what power that x comma 3 means. Cube it and then display it on the label. We're using plus equals to append and br to push down as usual. Alright, so that's that. Now the next stage, you can also do stuff like this, which is quite interesting. You can type thread td equals, and now you can make a new thread. So new thread, and believe it or not, in this case, you can even make, even though, you know, with IntelliSense there doesn't necessarily suggest it, you can type delegate like this. Alright? See that? So when you make an object of this type, you can create a delegate also. Right? So when you make this thread object, you're also making an anonymous function. In other words, you're sending a piece of processing so that it runs on its own thread. Okay? And then you can stick in stuff like this. So if a list double, see, ours equals, and then you will say new list of doubles. And again, you know, set it to some new double like that, right? A new double array. With some numbers there. Doesn't matter really. There you go. See that? And then of course you can operate. So you can say, for example, rs.sort, and then you can say rs.for each x. In a lambda expression there, you can say sample label text plus equals, and then br and then x. You see? Like that. There you go. Now with threads like this, you get to start it, and then so you can say td.start. It's going to start the thread, its own little separate piece of processing, separate from the main program, so to speak. And then I'll tell you about join also in a moment. All right. So the big idea here is that this anonymous stuff is quite powerful. So if you know, example, you can create an anonymous function like this one, method like this. So it runs, but it's not named. And you can basically, even when you make a new thread object, we can make a delegate. In other words, it can see that do a bit of processing of its own, and you don't have to put this off into other functions or anything like that. Okay, there you go. Now take a look. If I run this, there's one slight issue, which we will fix momentarily, but let's take a look at the reason. All right, so show results. See, there it goes. All right. That's it. Now, there's one more function, td.join, I want to tell you about. Join is this one. You see where it says blocks the calling thread until the thread terminates while continuing to perform. There you go. Start causes the operating system to change the state of the current instance to thread state.running. All right. So in other words, here thread is an object. In this case, you're making a new thread, which is a delegate, so it runs off in its own thread of processing away from the main program. All right. So that's kind of interesting. And notice that just now when we printed that stuff, there were only really two main lists. Okay. So let's do it this way. Same playable.text. Otherwise, we will not be able to see the effect clearly. Let me separate this. Take a look. All right, that looks like this. Okay. And now after this one, let's do one more here. So same playable.text plus equals to append br that. All right, and now if we remove the join and we run this, see that? And there are only two lists, correct? But there should be three of them. So the join, take a look, td.join and edge. And now there are three lists as there should be. All right? So the reason again is first we call this bit that generates a list. Then we call this anonymous function here that generates a list, anonymous method. And then lastly, we create this object called td, which is a thread, and then it has its own anonymous method inside, which runs in its own separate thread. And then we started, and the join function blocks the current thread, waits for this one here to execute, and then it resumes. You see? So everything is displayed. So these are the fundamentals of anonymous constructs of this kind. In this video, we're going to take a look at the basics of LINQ, which is language integrated query. It's a powerful way of manipulating data directly within your C# code. So pick up a project, and here, what we will have is a button. So put a button inside the HTML. Change the text on the button to something different. So for example, like this, show values, and that's it. All right. Switch to design view. Left to double click on show values. All right. Let me delete this page load. We don't need that. All right. So as always, I like to be prepared. I have the code prepared. I'll drag that in there. Comment it out. It's a little bit of code, but it's sequential from top to bottom. So the first thing to do is we have to add two new namespaces. So using system and then using system.link, language integrated query. And then using system.collections.generic for lists. All right. Now, what are the two new namespaces that we are using? So here, the first thing that we're going to do is create an array of names. So you're going to type the following, IEnumerable, like this, string. All right? And they're going to give it names as the name, and they're going to say a new string array. And then they specify the initializer list. So we'll say John, and we'll say here, and we'll say Janet, like this. All right, and then say Mary, and then lastly say Steve. And we'll close this with a semicolon. The underlining in my case is the result of the fact that I have a dictionary installed that checks spelling. All right. So, all right. Now, next, this is the following thing to be observed. Notice that on the left side we have IEnumerable. Right? That's an interface, a generic interface. As you can see, the new string array here can be created as such. Right? Because it's possible to take an array and then step through it, and each entry inside the array is a string. So it's enumerable. You can list the values within it, and each value to be listed is a string. Next, list, and then you will say int Now we'll make a list of integers. So we'll say lst equals new integer array, and then specify the initializer list. So throw in some values there. Doesn't matter. I'll show you some of the methods. Of course, as you can imagine, there are many of them. All right, and then at the end, all right, what we want to do is the following. Notice that we can't just leave it in this form, right? It says cannot implicitly convert type integer array to a generic list of arrays. So you're going to hit dot and then to list. See? So you can convert an array to a list of integers. Now that we have collections of items to go through, we can do that. So first we're going to type IEnumerable and then int. And first is operate on a list of numerical values. So you're going to say values, say more than 10, like this, correct? And to make that happen, you're going to type the name of the list, dot, and notice that these are all the functions that will become available, and one of them is where. All right, so choose where. And then you're going to specify a condition that applies. So in our case, where x is such that x is greater than 10 and closes with a semicolon. See? So if you have a massive where, you see where it says IEnumerable int, it returns, in other words, an enumerable construct that we can iterate through with a for each loop, for example. All right? And further, it says func int comma bool. All right? And then there's a predicate. Right? So you're going to take each value and you're going to basically apply some action to it. You're going to check whether some condition holds. And either the condition holds on it or it doesn't. That's it. Okay? All right. So that's the where. That's the, as you can see, we have basically language integrated query. And then we have basically inside that a lambda expression. See? All right. So here, to make use of it, you can do the following. You can say, for example, values more than 10 dot, and you would like to be able to use the for each. So to do that, you got to convert this to a list back. See? Back to a list. All right? Because remember, IEnumerable is not a list. All right? So that's why the toList didn't. That's why here for each doesn't show. You see? Convert it to a list, and then for each does show. And now you can again display the values. So for each x, you're going to do this. You're going to take the x and display it in a label. So same label.text, and then plus equals, throw in the dollar symbol, double quotes, br, and then x equals that. Close this with a semicolon, and this will display each x like that from the values more than 10 list. All right. Now we can tell just by examining it. 12, 25, and 54 should print. All right. So that's the first thing. Now I'm going to display a horizontal line here also. So to do that, you can type sampleLabel.text plus equals and then br, and in a horizontal line you can embed by typing hr close this way and close with a semicolon. See? All right. Next, imagine we have this array of names and we want to extract names that, for example, have a J, and then we want to sort the names from, say, shortest to longest. Right? These are the kinds of things that you do when you operate on data. So again, you're going to type IEnumerable as the type of strings this time. You see that? That's why we mean IEnumerable is generic, because it operates on integers and now on a string and so on. All right, so now you can say names with J and then sorted. So we have to accomplish this. And I've named this variable this particular way because the functions will be chained from left to right. So you're going to type the name of the names array. Then you're going to type where. Then you're going to check each name, where each name is such that the name dot contains the letter J. And then further, once you have all of those names that contain the letter J, dot, you're going to order that result by, and then order by the name such that the length of the name is used for ordering. Name that length, you see? And then you close this with a semicolon. Alright, so these are the fundamentals. Again, from left to right, you can chain these functions, and this is link. And as you can see inside each one, basically you have a lambda expression. See that? Where, and then order by. Powerful, right? So next, to display it, you could, remember, because this names with J sorted is enumerable, we can convert it to a list back and then use for each, or if you want you can just type, just to show you, for each and then var str and names with J sorted, open close curly braces, and then sampleable.text plus equals, and now that symbol, double quotes, br, and then str, close the semicolon. There you go. So remember here, sampleable.text, and this is to append, string interpolation, dollar symbol, br to push down a line, and then within the black curlies, that's the actual value to be printed. All right, next. So these are the basics of these concepts. Let me delete my reference code. There you go. So we have to confirm that this will work as expected. So crank it up an edge. Show values, and as you can see, 12, 25, 54, and then Job, John, Janet. So each one contains a J, and it's listed from shortest to longest as expected. There you go. And so this is, remember, a combination basically of, you have a length expression, lambda expression like this one. You stick that into a method like where or order by, for example. When you combine the two, the code becomes very powerful, as you can see, and very expressive, and you can accomplish a lot. And also, do remember that on the left side, many of the results in LINQ return items of type IEnumerable, like that. Welcome. In this video, we're going to talk about using LINQ with custom types. So crank up a project. Go to default.spx. And here, all we're going to do is put a button that says show people. So drag that in there. All right, and then type show people. So we'll have a little thing, a database, so to speak. We query it, and we show people who have, for example, a certain letter in their names and make a certain amount of money and sort it a certain way. All right, so to accomplish this, this is the basic HTML. Go to design view. I'll have to double click on show people. Looks like this. All right, the next stage here. So the first is up here, you're going to type using system.LINQ. All right, and then we're going to make a class. So we'll call it class person. You can just do it right here, like this, open close curly braces. All right. Public class person. And now here, you're going to declare two auto properties. So we're going to say here, public string name, of course, in the get and the set. All right, open, and then public decimal salary, and then get and set. And then you're going to make a constructor, so public person like this, then parameters. So you will now say string name, comma, and then decimal salary, those curly braces. Now set the values of the properties inside the constructor, so big N name equals little name, and big S salary equals little salary, like that. So this is our simple custom type person with two automatic properties and a constructor, a parameterized constructor. So the next stage, I will put some code down below that I made earlier and then comment that out. I've already done a good chunk of this anyway. So let me delete the portions that are not necessary anymore. Alright, so you're going to make an array of people, so person like this, and I will say people equals a new person array, like that. And then you're going to initialize this to hold, say, 3 people. So now you'll say new person, and then we'll say John, and then comma and his salary, some number in there, like that. And then you can repeat this a couple more times to initialize a couple more people. So Control C. And then Control V, just change the name. So what else did I say there? Bobby. And then change this number here to something a little different. There you go. And lastly, let's do one more. Throw that in there. Say the last person will be Joan. And say this here will be some value, salary. So there you go. Our salary, and now close this with a semicolon, you see? Alright, so that's that. Now, we can delete this first line that I have prepared. And now we're going to query this. So you're going to say IEnumerable. Now notice enumerable doesn't show up. So we got to come up here and type using system.collections.generic. Alright, and let's make use of it. So type IEnumerable. Let's try that again. IEnumerable. This time we'll say person as a type of object that can be enumerated from the list of people. I will say people with N. So we'll say we'll be searching for people who have an N in their name, and then further have, we'll sort by salary descending. So to do that, we're going to say now people.where, and then PR stands for each person inside that list there, like this, PR.name, and say it ends with, right, a lowercase n like this. All right. In real life, because people type information sometimes inconsistently, you would have to convert to, equal cases first, everything, but it's something for you to figure out on your own. So remember, we have people, the name of some kind of object like people here, then where, so an extension method, throw in a lambda there, right, then you continue dot. Next stage in the process will be to order by descending, so select it from the list of methods, and then again, per, and then you're going to hit that with per that salary, see? And then close with a semicolon. All right. So choose each person who's got an N, and then order the results by salary. And that gives an enumerable object. And now we can step through it, of course. So we'll say for each, and then person P and people with N. Open close curly braces. And now we can print. So we'll say sample label.text. Plus equals, put in the dollar symbol, double quotes, break to push down the line, and then we'll put the name first, so p.name, throw in a space, and then p.salary formatted as currency, so :C, and then you close this with a semicolon. Alright, delete that. So this is the heart of our program. Alright, crank it up an edge. Alright, so show people. So Joan 87656 and John, because both of them, as you can see, have a little n at the end, and then it's sorted by salary, descending, meaning from high salary to low salary. So that's working as expected. Let me close this, and that's it. So as you can see, you can also mine custom types, like for example this one here using LINQ, and it's very powerful and works well. Welcome. In this video, we're going to learn how to write queries using query syntax, not, for example, method chaining as we have before. So bring up a project, and the only thing that go into the HTML here is this one here. So you're going to put a button in there and nothing else. All right, and replace the text on the button to say show, like that. Switch to design view, left double click. All right, delete that handling stub, and now we're going to type here using system like this, that collections, the generic, and then using system the link. So to make use of it, we'll do this. I have some code that I made earlier, like that. I know it looks like a lot, but it's routine code. It's mechanical. All right, so here, first thing is, when somebody clicks this button, you want to clear the label so it doesn't accumulate the output all the time. Sample label.text, like that. Then you're going to make a decimal array. We'll call it salaries, naturally enough. All right, so new decimal. Right, this is how you can query a decimal, an array. This is a particularly a decimal, but it could be any array, essentially. All right, so throw in some values there, like that. All right, and then like that. There you go. All right, now you can type IEnumerable. You can type string. So here, I want to make an observation. Notice that the return set and the result set will be of type string, not of type decimal. So we'll say salary results equals, and now you're going to define the body of the link query. So you're going to say from salary, and now hover your mouse over salary. Salary is what is known as a range variable. So now take a look in salaries. See that? That's a range variable. It's the quantity that goes over all of the entries individually. This one, this one, this one, this one, this one. All right. Where, and now you're going to specify some kind of logical condition. Okay, to, for example, filter the results in some fashion. So 35,000 is less than or equal to salary. And like this, salary is less than or equal to, say, 75,000. There you go. Now I can order by the result set, so salary, and they can do it descending, for example. The default is ascending from small to big. You want to reverse that, throw in the descending keyword, and it goes from big to small. And now, to remember, because the objective is to get an enumerable construct of strings filled with strings, you're going to say select like this. Then you'll say here BR and then salary : C and close this with a semicolon. So you can format the results like this also in place, you see? Right, so with that in place, the next stage, of course, is to iterate over this and display the results. So you can go, with the conversion to a list and printing, or you can just do for each like this. And now str, how do we know that we should say string? Because remember, this I enumerable is filled with strings, correct? See that? T is string. So string, okay, say here formatted salary in the salary results, display the results. So sampleable.text plus equals to accumulate to append, and then you'll say formatted salary that has the thing to be displayed. Close with a semicolon. All right, so that looks like that. All right, crank this up an edge. All right, let me enlarge the view here. Let's show, and you see the salaries are there, sorted, descending, so from highest to lowest, and they fall between the 75 and 35 mark. All right, so that's working as expected, like this. Now, one thing that you should become aware of is the concept called deferred execution. You will see this in books. So to see that more, what that means, take a look. All right. Imagine I place a breakpoint right here. All right. Let's do it even here. All right, and then go debug and step into. All right, hit show. Okay, take a look. Deferred execution. Take a look at when this actually runs. You see now it's going into it. Now it's running. You see that? So the one thing that you should be aware of with LINQ is the concept of deferred execution, which means, right, this stuff he'll sell results is actually runs, as you can see. So a query variable essentially runs when you iterate over it using a for each construct, not when you write it over here. It doesn't run then. Okay? It runs when you iterate over it. Otherwise, your program will be potentially carrying huge amounts of information, right, in these query results. All right. So that's that, deferred execution. All right, next stage, take a look at another practical example of what we might be able to do. I want to also display a horizontal line, so sampleable.text plus equals, and then, of course, BR. And after that, another bit of HTML called HR. This will add a horizontal line to the output. All right, next. You're going to make now a dictionary and string comma decimal like this as the key value pairs, and this will be named salaries like this equals a new dictionary of string decimal key value pairs. Let's add some key value pairs, so we'll say name salaries.add, and I'll say here John Jones, that's the key, and the value will be his salary, so say 45355, close with a semicolon. Then we can repeat this a couple times, so Control C, Control V down below. All right, now let's repeat the name John here a couple times because I want to illustrate a concept down below. So 76 like that. All right, again, do one more time. Let's see, John Jenkins. That, and then throw in 89,000, and then let's do one more like this, So the last one here will be Steve Jobs. Of course, his salary was more than, like that. Let's say it's only 98,000 though for Jobs. All right, now we're going to again query this. Right, this is data that we have, key value pairs. We're going to query it. So variable var, in other words, and then dict results like this. Okay, and then you'll say from name salary like this. That's a range variable again, like that. In name salaries, in other words, name salary will refer at first to John Jones, John Smith, then John Jenkins, then Steve Jobs, and so on. Name salaries is the dictionary itself, all right? And name salary is the particular combination of a key and a value. All right, so it looks like this. Next, you'll say here where name salary that key that contains, for example, the name John and like that, name salary that value say is greater than or equal to 65,000. Okay? Like that. And if you wanted to, you could add order by and so on, but for our purposes, next we'll say select. All right, so we will select those records that specify, that apply in the case of these two conditions. The name is John and the salary exceeds 65,000. So in our case, that would definitely be these two people, right? Smith and Jenkins. All right, so next, select, and now we will say here BR, and then let's format the output so it looks good. Name salary that key, see that? Earns, and then name salary that value colon C to format as currency, right? And then per year. Close with a semicolon. See? That's it. Now hover your mouse over the results. You see where it says IEnumerable, and that var, that's called implicit typing. We've seen var before. So sometimes it's difficult to tell what the output will be from a query like this when it's sufficiently complicated. So if you do a implicit typing, then it tells you what the output is. So IEnumerable. So now you can, for example, specifically of strings. So if you wanted to, now you know, okay, I can put IEnumerable and then string here. Now we also know, because at the end you see these are strings, correct? These are just strings that include formatting information. All right. And now, of course, we can iterate over this as usual. So let me delete my reference code. And we will say for each, and then string name sal and date results. I'll say sample label.text plus equals to append, and then name sal, and close with a semicolon. And that's it. All right. So here, let's delete the reference code. And that is it. So let's give this a run, an edge. Let's make sure it's working as expected. So hit show, and there you go. So now you've got the first result set that I've described, and now the second one. So both names contain John, and the amounts are 65,000 or more. There you go, and that's it.